Aniket Patkar.
You can call the other name, na? Santosh Mukha.
Nikhil, are you there?
Nikhil, are you there, Nikhil?
Second, sir.
Santosh Mukhawar is there? Santosh Mukhawar. The author can raise the hand, na? So it is easy for you to identify.
Presenter, please raise your hand.
Yes, sir. Those who is in Lenovo, I have given presenter rights.
Okay, sir. Thank you. Please share your screen. Sir, share, sir.
Sir, extremely.
Yes, sir, Virendra
Sorry
Garu.
for inconvenience. Sir, actually, someone meeting which was in cohort. That's why joined back once again. Someone Lenovo, I have given presenter rights.
Year 039. Probably you turned on two or three systems, sir. Please turn on your.
Harsha, sir, please turn off one system.
Okay, sir.
Yes, Nikhil Bembede is ready.
I have given presenter rights.
Okay. Welcome, Nikhil. Bembode and to present a paper on assessment of concrete field steel tubular members and experimental review. Please go ahead, sir. Your time is 8 for presentation and 2 minutes for question and answers.
Sir, am I audible?
Yes, we can hear.
Can I start?
So you please make it full screen, sir, and you please go ahead with your presentation. We can see your presentation.
Now is it full screen?
Yes. Go ahead, sir.
Myself, Nikhil Srihari Bembde. I am a research scholar, and I am presenting here a short presentation on assessment of concrete field steel tubular members and experimental review. Contents are introduction, application of CFDST members, literature review, overview of the study, results and discussion, future scope, and references. Introduction. Concrete field steel tubular members belongs to family of composites. There are mainly two types of these composites, that is CFST and CFDST, that is concrete field steel tubular columns and concrete field double steel tubular columns. Their structure and construction of CFST and CFDST can be easily understood by observing these figures. In first figure, there are different cross sections of CFST are shown. In the structure of this CFST member, there is one tube which may be a circular, rectangular, or which may be of any type of the cross section. In between that gap, the concrete is filled. And in CFDST, there are two concentric tubes which are placed at well distance separated from each other, and the core between that two tubes is filled with concrete. From these two CFST and CFSD composite members, CFDST is very popular and very useful because it has increased the strength to weight ratio as compared to CFST. CFDST also have better properties such as ease of construction. Ease of construction is because there is no need of farmer to construct these columns lightweight, high strength, and good seismic resistance. These are some properties so that it is very beneficial as compared to CFST. Applications of CFDST member. CFDST can be used as legs of deep water, pressure pipes, transmission tower poles, high-rise buildings, columns for high-rise buildings, and wind turbine. In this figure, use of CFST and CFDST in practical application is shown. In figure 3, we can easily see the use of CFST in Canton Tower, China. It is the tower constructed for surveillance of the Commonwealth Games conducted in China. And in figure 4, we can observe CFDST column use, CFDST member use for pressure pipe and electricity pole. From my literature, I have selected 5 papers to represent. First is Yan and Zhao, presented by Yan and Zhao, which this paper, aim of this paper was to develop simple formula for predicting compressive strength of CFDST short circular column. And for this, they have tested 24 specimens with inner and outer SHS steel tubes to withstand the axial compression, and they given a novel design formula to predict the compressive strength of circular short CFDST column. Second is Wang et al. He proposed a study to evaluate the effectiveness of present European and American design code provisions for CFDST design. And from the study, they have concluded that Eurocode gives the better and closer result for compressive strength as compared to American code, and American code overestimates the capacity of CFDST column. This is M.I. Kapler and Hassan published a paper in 2019. The aim was to explain the experimental study that has been conducted to investigate the effect of internal steel tube on the mechanical response of axially compressed CFDST column. And the test indicate that the CFDST column may achieve better performance over the CFST column when a proper inner steel tube framework is used. Et al. Published a paper in 2018, and the aim of the paper was to study the mechanical behavior of square concrete filled bimetallic tubular CFBT step column subjected to axial compression. CFBT is nothing but a type of CFDST column, and from the study, they concluded that the string compatibility and lateral resistance should be taken into account to accurately predict the compressive behavior of square CFBT column. Chen et al. 2018 presented paper which was focused on the study of behavior of square concrete filled stainless steel step columns after exposure to elevated temperature under axial compression. And from the study, they found that the high temperature had a great influence on the ultimate load bearing capacity of these columns, and cooling methods also had some effect on it. Overview of the study. Many studies are related to CFDST composite members such as step column, short column, beam column, subjected to axial load, flexure, torsion, cyclic load are available. Also, studies on the effect of various parameters such as steel tubes, strength of steel tubes, strength of core concrete, specimen length, diameter to thickness ratio of tubes, axial load level are also available. In my paper, these studies are summarized so that one can understand the behavior of CFDST members easily. Results and discussion. Improvement in the ductility is recorded for CFDST as compared to CFST when the members are subjected to compression and bending. That is, CFDST gives better performance in compression and bending as compared to CFST. Energy dispersion and ductility of members with inner CHS and greater than those of the SHS tubes. Long-term sustained loading results in the increment of deformation and decrement of column CFDST columns ultimate strength. Increment in core concrete strength resulted in increment of ultimate axial load carrying capacity of CFDST column. Installation of the steel rings as external confinement resulted in improvement of stiffness, ductility, and strength of the members. Stiffness reduction occurs with the increase of axial load level. Temperature is the substantial influencing parameter on the ultimate load bearing capacity of CFDST column, and internal tubes offered a percentage increase in the compressive strength by range of 18.95 to 6.44% in axial load carrying capacity of CFDST column. These are the results and discussion about the papers which I have studied. Future scope. From the study, it was observed that uh, most of the study had been carried out to increase the strength, ductility, flexural strength, stiffness, and torsional behavior of the composite columns, particularly for CFDST members with internal steel tube. Significant increase in strength is observed. Significantly less work is available on non-linear analysis of these members. So it is intended to carry out non-linear analysis by considering the various types of non-linearities for these members to predict the failure patterns and safety of these members for better performance and durability of the structures. These are the references. Thank you. Any questions?
Yeah, audience, they have any questions, they can ask. Mr. Nikhil, any Indian examples you can share?
Hello, sir. Hello, sir.
Any Indian example we can
Sir,
share regarding this?
there is less construction works carried out by using these members in our country, and there is no any code also. Code of practice is not available. So there is a lot of scope to work on this composite member. I don't know till now which structure is constructed in India by using these composite members. But there are lots of work by using these members carried out in the foreign countries.
Okay. Thank you. Thank you, Mr. Nikhil.
Okay, thank you, sir.
Thank you.
Thank you, Mr. Nikhil. Sir, I think next presenter is ready. Mr. Aniket Patkar.
Hello.
Aniket Patkar, please share your screen.
Yes, sir. Sir. Yes, sir.
Yes.
Yeah, welcome, Mr. Aniket Patkar.
Yes, sir.
Yeah, you will be presenting on break-even analysis and the
Yes, sir.
response of longer span frames with or
Yes.
without post-tension beams in multi-purpose halls.
Yes, sir.
Yeah.
Sir, shall I continue?
Welcome. Yes, Mr. Aniket.
Good afternoon, everyone. Myself, Aniket Patkar. I am MTech Structure student at Vishwakarma Institute of Information Technology. Today, here I am presenting my research work in front of you. My project title is Break-Even Analysis and Response of Longer Span Frames with or without Post-Tension Beam in Multipurpose Hall. Sir, am I audible? Hello.
Yes, you are
Yes,
audible.
you are
Please
audible.
continue.
Introduction. Reinforced concrete or non-prestressed beam subjected to external or superimposed load. Due to this external load, downward deflection occurs in RC beam, as shown in figure 1. This leads to development of cracks. In case of long span beams, excessive deflection occurs, leading to cracks or more width and sometimes collapse the structure. To overcome the above problem, we introduce a steel tendon in tensile zone of the beam, which subjected to tensile force. By tensioning the tendon, the tensile force in the tendon is converted to compressive force in the tendon. This compressive force is transferred to concrete and creates compressive stress in concrete. Due to this compressive stress in concrete, the beam deflects upward as shown in figure 2. When an external load is applied on the beam, the downward deflection due to external load contracted by upward deflection caused due to tendon. Finally, the beam deflection is reduced within the allowable limits, hence the structures becomes safe. Some are the applications. In building construction, post-tensioning allows longer span, thinner slabs. In addition, it means a lower overall building height for the same floor to floor height. Post-tensioning can thus allow significant reduction in building weight versus a conventional concrete building with the same number of floors. This reduces the foundation load and can a major advantage in seismic areas. In post-tensioning allows longer clear span and very creative architecture. Objectives: to carry out analysis and design of multipurpose hall with variation in the dimension of a RC frame structure, and computation of the percentage cost difference between RCC and post-tension prestressed concrete beam with respect to span. To eliminate or control cracking and deflection of beam by restrict the depth of beam. These are the objectives. Problem statement: RCC structures are commonly used for assembly buildings. Post-tension prestressed concrete beams are frequently used for the same buildings, or we can say for short span buildings. 2 decades ago, there was a big issue of skilled laborers for prestressing work, but now there are so many private agencies for execution of the same work. In RCC frame structures, depth of beam increases with increase in span. Because of deflection limitation as well as large column introduce obstruction and receive minimum service utility area of the hall. Cost per beam, which is major aspects for comparison of reinforced concrete or post-tension prestressed concrete beam in multipurpose hall, because costly structure are generally neglected or omit in construction if another cheaper option is available in front of it. My project scope: this work includes the analysis and design of multipurpose hall with variation in the plan dimensions. Material utilization depends on dimension effect. Here cost comparison between of a RCC frame structure with interior RC beams and RCC frame structure with interior PT beams of an various plan dimensions. The first model consists of a conventional RC frame with all beams and columns as RCC. The second model considers peripheral beam as reinforced concrete and interior beams with PT beam, and also calculate deflection of beam by restrict the depth of beam by using unbonded post-tension prestressed concrete beam method. These guidelines helps to the structural designer to reach a definite conclusion regarding the superiority technique, two techniques over one another with respect to financial aspects and structural stability. Methodology. Firstly, multipurpose hall. There are 5 various types of floor plan dimensions. There are first one 5 into 10 meter, 7.5 into 15 meter, third one 10 into 20 meter, 12.5 into 25, and 15 meter by 30 meter. After that, I have drafted all the plan dimensions drawings in AutoCAD software. After that, I have input this file into Icace software and modeling the all these floor dimensions. After that, analyzing in this software Icace all the frames. For analyzing, design RC beam and design PT beam which are both the methods, different type of methods designed in ETAPS and adopt PTRC software used to design the PT beam. Then after that, I have designed the RC beam and prepared the detail estimate in Excel. Same as for PT beam, prepare detail estimate in Excel and bar bending scheduling to for the cost estimation. And then after comparison between both the beams with cost effective. Results and discussion. Table 1 shows the economics of RC beam, vice versa PT beam. Here the graph between this estimated cost for PT beam and RC beam. PT beam and RC beam crosses after the 7-meter span. We afford the PT beam. Depth. Table 2 shows depth of RC beam, vice versa PT beam. Here the comparison for RCC beam depth and PT beam depth. How to restrict the depth of beam in PT beam, which is same as for deflection criteria. Here the deflection for RC beam and PT beam, which shows graph 3. Conclusion. Finally, the conclusion of this project, cost per beam of post-tension pre-stressed concrete beam reduces after 7-meter long length beam, and also result shows that control deflection of beam by restrict the depth of beam by using unbonded post-tension pre-stressed concrete beam method. A break-even analysis is done because importance of decision-making point of view, as it helps the structural designer either we go for RC beam or we go for PT beam casting method. Also, the result shows that variation of cost with respect to the span of beam, where the break-even point between RCC and PT technique is approx 7-meter span. Here some are the references or IS codes we refer. I have referred in my project: IS 456, IS 1343, IS 875, IS 1893. Thank you, sir.
Thank you, Mr. Aniket. Nicely presented. Any questions from the audience?
I request any audience, if you like to speak, please raise your hand so that I can unmute you.
Any questions from any audience?
What is the grade you are considered for RCC as well as your post-tensioning?
Hello.
What is the grade you are considered? Concrete grade.
For RCC M30 and for PT beam M40.
Okay. Good. So thank you, Mr. Aniket Patkar.
Yes, sir. Welcome, sir.
I think if there are no questions, we can close the session. We can go to the next paper. Thank you.
Welcome, sir.
Yes. Lingala Ajay. Yes, Mr. Ajay Lingala.
Sir, this is Ajay, sir.
Yes. Please raise your hand.
Sir, I have given presenter rights.
Okay, sir. Okay. Please share your presentation and continue.
Welcome, Mr. Ajay Lingala.
Okay.
So you will be presenting on the topic torsional vibration control of a structure using fluid viscous dampers, right?
Yes, sir. Yes, sir.
Yeah, please proceed.
Is it visible, sir? Hello. Hello.
Not in a full screen. I'm not able to see a full screen.
It's still loading, I think.
Ajay Garu, you need to minimize all windows except your PPT.
No, sir.
No,
No.
no.
Sir, no. Sir, no. Hello. Hello.
No, Mr. Ajay, it's the same thing only. We are not able to see the full screen.
Can you please stop sharing once? I will tell you once again.
Okay, sir. Okay, sir.
Please click on share button. Now you are sharing only. Actually, you can share your PPT. Go to your PPT. No.
No, sir. No, sir.
1 second. Wait 1 second.
Or if the organizers have the PPT, you can upload it and he can present from there.
Mr. Ajay, please,
Sir,
can you
please,
share
sir.
your PPT? We will upload and
Yes, sir. Now please share your entire screen instead of sharing PPT.
Is this, sir? Share my meeting window.
Not your meeting window, entire screen.
the first option will be there. Share your
Okay, sir.
screen. Okay.
Click on share content, please. Click on share content. Just now you have seen, yeah. Yes. Here, left side, click on
First one.
screen one and then click on share. Yes. Now click on share. Yes. Now we are able to see your desktop. Now please open.
Okay.
Yeah. PPT came. Okay. Please keep it slideshow and you can proceed further.
Okay, sir. Is it visible, sir?
Yes.
Yes,
Okay,
visible.
sir.
Please
Okay, sir.
proceed, Andy.
Good afternoon, sirs. This is Ajay, MTech Structural Engineering in KL University, under the guidance of Anil Kumar, sir. And my topic is torsional vibration control of a structure using dampers. The damping reduces the effect of the structure when they are assigned to lateral loads by energy dissipation. The number of dampers are available and in use today. Most of the dampers usually isolate the superstructure from the substructure, dividing them in order to hamper the flow of vibrations into the superstructure. The structure endures two load types, the vertical loads and the sidewise loads, and conveys to the foundation. In the present study, disymmetric buildings are analyzed with and without fluid viscous dampers. The software ETAPS 2016 was used. Fluid viscous dampers are developed in the year 1960. Viscous dampers is a passive energy dissipation device. It dissipates energy by forcing a fluid through an orifice similar to the shock absorber to an automobile. Viscosity of the fluid used in the damper is usually very high silicon. This viscous damper consists of a stainless steel piston with the bronze orifice head. It is filled with high viscous silicon oil. Viscous dampers are the energy dissipation device. This type of dampers is very robust and they are used in the both new and existing structure. In viscous dampers, seismic energy is absorbed by the silicon-based fluid passing between piston cylinder arrangement. Viscous dampers are used in high-rise buildings in seismic areas. It can operate temperature ranging from 40 to 70 degrees centigrades. Viscous damper reduces the vibrations induced by both strong wind and earthquake. Coming from the torsional motion is produced by the eccentricity existing between the center of mass and the center of rigidity. Some of the situations that can give rise to this situation in the building plan. Reasons for the torsional effects: lack of symmetry of the structural system due to a non-uniform distribution in plan of the stiffness, mass or strength. The symmetry configuration of the building results in a coupling of the translation and rotational mode of vibration of the structures. Coming from the literature review one, the author explained that two examples describing about the viscous dampers can be effectively used in different configurations to reduce the response of high-rise buildings to wind and earthquake. From the literature review 2, the author studied the seismic behavior of viscoelastically damped structure under mild and strong earthquake ground motions. From the literature review 3, the author has summarized the aspects of torsional response of ductile structures and presents a modified design procedure in which the ductility of the system has been reduced. From the literature review 4, the author summarized that the coupling of lateral and torsional motions may cause the edge deformations large in a symmetric plan systems compared to system with symmetric plan systems. Coming from the comparison of structure with and without dampers using UTAP software. I used M20 grade of concrete and FE 500 grade of steel are used for all slabs and beams of the building, whereas M25 is used for columns with the same grade of steel. Elastic material properties of these materials are taken as per IS 456 to 2000. The different structural elements considered are columns, beams, and slabs with variable sections. Rectangular column size is 230 mm into 650 mm. Beam size is 230 mm into 450 mm, and slab sizes area is 16 meters into 35 meters, and slab thickness is 125 mm. And this is the 7-story building. Total height of the building is 19.2 meters. While applying the loads to the structure, we consider only the external loads, which are actually acting on the members, neglecting its self-weight because ETAPS 2016 automatically takes the members' self-weight. The seismic loads EQX and EQY are using loads by using code IS 1893 to 2002. And also the wind loads, wind X and wind Y are given by using code IS 1875 to 1987. And this is the 3D modeling. Coming to the story response, maximum story displacement is in the maximum story displacement, the 7-story when we are not using fluid viscous dampers, it is 17.6 mm displacement. And when we using fluid viscous dampers, it is 7.472 mm displacement in the X direction. In the earthquake, X direction without fluid viscous dampers is 17.663 mm and with the fluid viscous dampers is 7.472 mm. So that when we using dampers, 10 mm decreases in X direction. Coming in the earthquake, Y direction without fluid viscous dampers is 24.165 mm and with the fluid viscous dampers is 6.254 mm. So that when we using dampers, 17.911 mm decreases in Y direction. These are the response spectrum curves when we do not have time history available to us. And then for most of the buildings, the response spectrum, design spectrum, whatever it is suggested is IS 1893 is available. We can make use of that and find the maximum forces and maximum deformations which might occur in the structure using this response spectrum analysis uses almost same principles as time history analysis, but only instead of finding time history, we will find the maximum values of the response. It shows the 7-story without fluid viscous building for 0.1. The coordinate system of the structure is spectrum widening and model is 0% is participated in X and Y direction. These are the response spectrum in the time history X and Y maximum 1.3626 mm and in with the fluid viscous dampers time history X is maximum 0.277 and in the time history Y direction maximum 0.625. Coming from the conclusions, by comparing both the results, we observe that the joint displacements are reduced by using the dampers. The stability of the structure is increased and torsional vibrations are reduced using fluid viscous dampers. We observed that buildings with dampers can reduce the displacement about 75% than the buildings without dampers. When fluid viscous dampers are used, up to 80% decreases in the time period. For the further research, this paper is limited to use of FED 250 to the structures in exterior corners and some few recommendations for further study. Same structures can be modified with FVD 500 and can be used in exterior middle position. Tall structures can be an extension to this work. Its use in steel structures can bring much effective solutions. The structural systems like K-shape and M-shape can be used along with fluid viscous dampers. And these are the references. Thank you.
Yeah, well presented, Mr. Ajay.
Thank you, sir.
Yeah, good. So, any questions from the audience side? Okay, nothing is there. We can proceed to the next paper.
Yes, sir. Yes,
Okay,
one
sir.
question.
Thank you, sir.
Lingaya Ajay. Yes, sir. Hello, Ajay.
Sir.
Okay.
Hello,
So
sir.
can you quantify how much percentage reduction in torsional vibration when you apply this dampers? Yes. Ajay Linga, are you?
Sir, is this visible, sir?
Yes, yes. There is a question.
Sir,
So how much percentage can reduce the vibrations?
in X direction or Y direction?
Both.
Sir, in
Okay, if you quantified, you tell. Otherwise,
this 10 mm decreases in N direction, sir, X direction. With on in X direction and Y direction with 17.11 decreases in Y direction, sir.
okay. Any more questions from any other participants? Yes, sir. Venkatraman, sir.
Yeah, thank you very much, Mr. Ajay. Nicely
Thank you, sir.
presented.
Thank you, sir.
Thank you. We can move to the next topic.
Yes,
Next
sir.
speaker.
I think Venkata Lakshmi garu. Hello. Please raise your hand.
Yes, sir. I have given presenter rights.
Okay, sir. Thank you.
Yeah, I think the topic is assessment of antenna mounting building structural strength using micro trimmer analysis.
Yes, sir.
Venkat Lakshmi ma'am, your voice is not audible.
Sir, audible now?
Yes, ma'am. Now it is audible. I have given you presenter rights. You can start sharing your screen.
Okay, sir. Share. Share the screen, sir.
Yes, it is visible, madam. You please make it presentation mode.
Yes, sir, I have made. It is in presentation mode only.
Okay,
No,
ma'am.
it
Make
is-
it slideshow and please remove your pop-up windows. We are seeing the pop-up windows on the right side.
Yes.
Now it is okay, sir.
It's okay. You can go ahead.
Please proceed, madam.
I'm Venkat Lakshmi. working in the ECIL, antenna products and satcom division, and research scholar in Christ University. I am going to present the assessment of antenna mounting building structural strength using microtremor analysis. The presentation outlining introduction, details of instruments and software, data measurement and frequency calibration, results and calculations. The antenna is used to radiate electromagnetic energy efficiently.
Madam, your voice is too low.
Antenna is used to radiate electromagnetic energy efficiently and in desired directions. Any satellite ground station requires fully steerable dish-shaped antenna, that is parabolic shaped antenna, for fixed satellite services. Antennas for ground stations we are establishing ground foundations and on rooftops, and sometimes new buildings, existing buildings, structural steel towers, RCC towers, based on the RF requirements, radio frequency noise requirements. We are selecting whether we can install on ground or on rooftop building. If it is new building, we can from the beginning of analysis and design, we can design the antenna building structure. If it is an existing building, we have to assess the strength of the building, whether it is suitable to mount the antenna structure or not. For rotating antenna structures, the natural frequency is very important parameter, because that structural frequency, natural frequency, if it is very near to the servo frequency, that antenna is having rotating element, that motor, if it is very near to the servo frequency, motor frequency, resonance will come. So to know that existing buildings strength and stiffness, natural frequency, we have to find out. The microtremor, it is having the velocity sensor and acceleration sensor also. With this, we can measure the frequency of the building, recording the data, by collecting the data and by analyzing with the software, that FFT analysis. In this study, I have considered that one antenna, 7.5 meter antenna mounting structure, existing building, whether we can build on that structure or not. This figure explains how that antennas are installed on the buildings. And typical section elevation drawing also shown in this figure. This type of building only considered, whatever shown in the drawing, that building only considered for assessment of the strength of the building in this study. These are the details of instrument. That microtremor MR 2002, it is recorded unit. This is this one. This is the recorded unit, and this is the sensor and a mounting plate. This is power cable. This is sensor cable. Then this is the carrying case. This is the block diagram of the working of this instrument, how this works. Using this sensor we have to mount on any location. We can take that signals around some half an hour or 10 to 15 minutes or half an hour or 1 hour. Each event measures some 30 seconds to 1 minute. With this, we have to record that if it is velocity sensor, velocity data, it will record based on the natural vibrations, natural noise. Then that recorded data we have to analyze with the software View 2002 or Excel or any other softwares also. How we can calculate the FFT, any software we can use. In this study, I have used View 2002 software. This is the software screen. Because we have to open it and then have to analyze it. It is 3 channels. It is triaxial sensor. So 3 channel data it will collect. Then FFT we can calculate. Then this data measurement is the building considered is this building. It is having square 2-floored structure with a top cone and ring beam. The data collected on the sensor on putting 4 locations. One is on ring beam. This opposite, diagonally opposite 2 places conducted the test. And third one is the bottom of the cone. The first floor slab, we place the sensor. Again, first floor slab also, diagonally opposite. The data we collected. Then ground floor, sensor mounted on ground floor, the data collected. And each location, the data collected for 10 to 15 minutes. And channel 1, channel 2, channel 3, there is X, Y, Z, 3 directions. Each event 30 seconds. First one is the ring beam, velocity sensor on ring beam, R1. This is R2, sensor location. Collected data, the sample data shown. Like this data will come, velocity versus time. The dominant signals taken and then analyzed, the frequencies and dampings. This is the FFT plot for sample event. These are the results frequencies of all events for one location. This is signals when sensor mounted on R1. For 9th event, we got in X direction 13.82 and channel Z, that is vertical direction 13.48 and channel Y 11.7. We got the frequency. Sample damping calculation also shown, and then how this damping plotted. The decayed signal taken, the dominant decayed signal from 16.95 to 17.5 seconds and 20 to 21 seconds and 15.6 to 16.2 seconds for event 18. It is only sample only given. In this for channel X, 14.5 Hz frequency and damping is 3.6%. And channel 2, 12.8 Hz and damping is 3%. Channel 3, 15.7 Hz and damping is 3.8%. This is when sensor mounted on R2, the frequencies are 14.23 in channel X, channel Y 13.7, channel Z 16.09. Like this, for all locations, frequencies worked out. For antenna structures, the servo frequency is around 2 to 3 Hz. So the building frequency should be more than 8 Hz specification to be given always. So for the study shows that the building considered for measurement of natural frequency is stiff and overall natural frequency is more than 8 Hz. That is more than the required specifications. The frequency obtained is 11.38 Hz. That is in vertical direction, channel 3, with the data collected by fitting the first floor slab at T1 location. And channel 1 X channel data is 12.08 Hz. Channel 2 Y channel data is 11.78 Hz. Channel 3 11.38 Hz. So overall 11.38 Hz is the lowest frequency. So it is more than 8 Hz. Hence, it is proposed that the building considered for the study is safe and having required stiffness to take antenna load. Hence, antenna may be installed on the building. That way, we have concluded. So, with this type of measurements, we can measure the frequency of the structure. With that, the stiffness of the structure we can assess. That antenna structure's frequency also validated with the measured and analysis results also. The foundations also we have validated with these measurements, the frequency measurements. So these type of instruments are non-destructive test type of equipments we can use to assess the structural strength of the buildings or any towers or any structures. These are the references used for this study. Thank you, sir.
Sir, thank you. Yeah. Questions from the audience side, please.
Dear participants, if you have any questions, please ask to the author.
Any questions are there from the audience side?
I think no questions, sir. I think
No questions. Anyway, it's an interesting topic, and the information shared are quite knowledge sharing and very interesting. Especially when the telecom industry is going for 5G network in a big way, your principles and all learnings can be applied there. Well presented. Thank you, Dr. Lakshmi Garu. Thank you.
Thank you, sir. Thank you.
Venkatraman, sir.
Yes. Who is the
I think
next
we have
speaker?
completed all the participants, the author's presentation, sir.
Okay.
No more for this session, and the next section will start at 2 p.m. sir.
Okay.
And
Okay.
there we have two keynote speakers from which is very good, Dr. Siva Prasad from Triple IIT Kanchipuram and Dr. Binkan Palsa from IIT Bhubaneswar. After that, we have 20 papers to be presented by various authors.
Okay.
Yes, sir. Now,
So,
sir, please, Venkatraman, sir, please conclude the session and
yes. So first
yes,
of
sir.
all, thanks to all the speakers. They have presented their work in a very nice manner. We started with Mr. Nikhil presenting on assessment of concrete filled steel tubular members. And he said how that is better compared to the conventional thing. This was followed by Mr. Aniket Patkar, who spoke on, who did some break-even analysis and response of longer span frames with or without post-tension beams in multi-purpose hall, and he was trying to show how economical it will be, and he was trying to also give the break-even point beyond which it will be economical if you go for PT beams in multi-purpose hall. This was followed by another interesting presentation by Mr. Lingala Ajay on torsional vibration control of a structure, and he has taken a rectangular plan building, 7-story building. He was doing analysis, and he was also sharing the benefits of using fluid viscous dampers, how it reduces the deflection in X and Y direction. That was another interesting paper presented, and followed by the last speaker, Venkata Lakshmi Garu. She presented on this assessment of antenna mounting building structural strength using microtube analysis. Very interesting study. So overall, it was a different perspective on different topics, what they shared, what kind of work they were doing. I hope it was very useful and informative to the participants also. Personally also, I have picked up few learnings from these papers. Thank you very much and all the best wishes to all of them. Thank you.
Thank you, sir. Thank you once again to be our
Thank you.
chair, sir. Thank you very much, sir. Dear participants, we'll meet in the afternoon 2 p.m.
Okay. Thank you, Venkatraman sir, for the nice summary of the session. Thank you for joining us, sir.
I request the participants to please fill the feedback that was in the chat box. Virendra, sir.
Yes, sir. Yes, sir.
Sir, I will keep the session as it is like this only, and we will resume at 2 p.m., sir.
No problem. No problem.
Okay.
Please join all participants at 2 p.m. We have very good presentations and keynotes. Thank you all. Please fill this feedback form and we'll meet again at 2 p.m. Thank you. Thank you, one and all.
సార్ షేర్ బటన్ హైలైట్ కావట్లేదా? అది పీపీటీ చూపించాలి కదా.
Kishore sir, give transfer rights to Kameshwar sir.
ఓకే, థ్యాంక్ యూ.
Sir, I have given, sir.
ఓకే, థ్యాంక్ యూ సార్. Sir, hope it is visible too. Sir, is it visible?
No, sir, it is not shared, sir. Please share once again.
Okay, thank you. Sir, now is it visible, sir? Is it visible, sir? Harsha garu, is it visible?
Sir, no, sir. I పిలుస్తున్నా Kameshwar sir.
One minute, sir.
Sir, click on share and share content, your entire screen, sir.
No, show share button is not highlighted. 1 minute, I will log in once again. Why it is 1 minute.
Sir, I will take back and give you once again, sir. Shall I do like that?
1 minute. Let me re-log in because there is a problem. Okay. Now, just now I try. Just
Okay, sir.
one minute.
Kishore sir.
Is it everything is okay, sir?
Sir, if the PPT is with you, you can share. Kameshwar sir is having some technical issue.
Okay, sir.
Yeah,
I shall share.
yeah, please share the PPT.
Akshay sir, kindly confirm.
Yeah, it is visible now.
Yes, sir.
Sir, HM ready join అయ్యారండి.
No, sir, not joined.
Not it join. I think Dr. Srinivas might have joined.
Yes, sir, sir is there. Srinivas sir is there.
Let us wait for Reddy garu, HM Reddy garu.
Yes, sir.
శ్రీకృష్ణ గారు మీరు ఫోన్ చేస్తారు రెడ్డి గారికి జాయిన్ అవ్వమని.
Yes, sir. Yes, sir.
ఒకసారి ఫోన్ చేయండి, టైం అయింది కదా.
Yes, sir. Just now. So, Kameshwar sir. Sir.
Yes, sir.
Sir, HM Reddy garu call చేశాను
Reddy
sir.
gaరు
1 minute.
Okay.
He will join in 1 minute, sir.
Okay.
Srinivas sir, good afternoon, sir.
మీరు అంటే రైట్స్ ట్రాన్స్ఫర్ చేయాలా?
Yes, sir. Yes, sir. I transfer the rights to. Yes, sir. I transfer the rights to Srinivas sir and AVS Prasad sir also. So they can unmute them, sir.
Yeah. Hello.
Hello, sir. This is Dr. Siva Prasad from IIITDM Kanjipuram, sir.
Welcome, sir. Nice to meet you.
Welcome, sir. Good afternoon.
Good afternoon, sir. Thank you so much for your invitation, sir. ఇది నాకు షేర్ చేయడానికి అవ్వట్లేదు సార్. ఐఎమ్ నాట్ ఏబుల్ టు షేర్ మై స్క్రీన్.
Yes, sir.
Sir, now because actually that when your turn come, then you will be able to share it. Now we are sharing the screen.
Okay, sir. Thank you. Thank you, sir.
Good afternoon, sir. Good afternoon, all of you, sir. I am Professor from Goodwall Engineering College.
Good afternoon, sir. You are welcome to this session, sir.
Thank you, sir.
We are waiting for HM Reddy garu. We'll start the session soon after he joins. So మళ్ళీ ఇంకోసారి ఫోన్ చేయండి, లేట్ అవుతుంది సెషన్. శివకిషోర్ గారా?
సార్
సార్ ఇంకోసారి ఆయన ఫోన్ చేస్తారు రెడ్డి గారికి, లేదా ఒకసారి అడగండి. ఆయన షాల్ వి స్టార్ట్ ద సెషన్ విత్ బిఫోర్ హీ జాయిన్స్. అది కొంచెం తెలుసుకోండి.
ఓకే సార్, ఓకే సార్, కాల్ చేస్తాను సార్.
ఒకసారి Sir, I think we'll start the session. It is getting late, already 10 minutes, so we are late by 10 minutes.
Okay, sir. Yes, sir. Sir. Okay, sir.
Okay. Good afternoon to the participants. And we are sorry that the session chairman not yet joined. Then he may join at later stage. And we welcome that Dr. A. Srinivasulu garu. నాకు షిఫ్ట్ చేయండి ఇది స్లైడ్ షిఫ్ట్ చేయండి. ఓకే నెక్స్ట్ చైర్మన్ yeah, that this session will be chaired by H.M. Reddy garu. Unfortunately, he has not yet joined. Then we welcome Dr. A. Srinivasulu garu. That I'll give the brief introduction about A. Srinivasulu garu. Next slide, please. Yeah, I'll give the brief introduction about Dr. A. Srinivasulu garu. Professor A. Srinivasulu obtained his BTech in civil engineering in 1997 and MTech in industrial structures in 2000 from Visvesvaraya Technology University, Belgaum, and PhD from Andhra University, Visakhapatnam. Currently, Dr. Srinivasulu is working as a professor and HOD, Civil Engineering Department, Godlavalleru Engineering College. He is having more than 21 years of expertise in research and teaching, and he is a member of many professional bodies like ICI, IEI, ISTE, and ISSE, etc. And he is a reviewer for many international and national journals. With this, I invite Professor A. Srinivasulu garu to co-chair this session, and also I request Dr. A. Srinivasulu garu to introduce both the keynote speakers and hand over the session. And take over the session. Okay. Thank you, sir.
Sir, Kameswara garu, for introducing me to the session. Now, can I introduce, sir, about the today's
keynote? Keynote, yes, sir. Please proceed, sir.
So, welcoming you all to the afternoon session for our structural engineering session today. So, our keynote speaker for our structural engineering afternoon session is Dr. Dinkar Pasla. So, about Dr. Dinkar Pasla, I'll just give some brief introduction about him. Dr. Dinkar Pasla holds bachelor degree in civil engineering from Osmania University, Hyderabad. Master's and doctoral degrees both are from IIT Madras, followed by a postdoctoral research fellowship at the University of Leipzig, Germany. He is an associate professor at School of Infrastructure and head of the School of Infrastructure, IIT Bhubaneswar, India. He is also the chairman of Indian Concrete Institute Bhubaneswar chapter. Prior to joining at IIT Bhubaneswar, he was the head R&D at ACC Concrete Limited, Mumbai. He has been active in the areas of structures and materials and is also the in charge of Concrete Technology Laboratory at IIT Bhubaneswar. He has nearly 75 research papers to his credit. Presently, he is guiding 6 research students for their doctoral and master's research programs, apart from being the coordinator for several research and development projects. He is also a reviewer for various international as well as national journals. He is also a very active consultant for different industries in the fields of analysis, design, repair, and rehabilitation of construction. His research interests include concrete technology, characterization of cementitious materials, use of admixtures in concrete, high performance concrete, self-compacting concrete, corrosion of steel in concrete, durability and non-destructive evaluation, and construction materials. So this is the brief introduction about our today's keynote speaker, Dr. Dinkar Pasla garu. Yeah, now I'm handing the mic to Dinkar Pasla garu or to Kameswara garu. Please take over.
So I invite Dr. Dinakar Pasula to start this keynote lecture.
Sir, I think he's not here, sir. Sir, not available.
Oh, he's not available. Then how about another keynote speaker?
We shall have the second keynote lecture, sir.
So actually,
Sir, I'm sorry. There is some. I think there seems to be some confusion. It's supposed to be my keynote lecture at 2 o'clock, sir.
Okay, sir.
This is Dr. Suprasad from
Because sir, we are in great confusion because our chairman has not joined the session. That's why it got delayed. Then sorry, sir. Sorry for the confusion. Sir, I request Vice Chairman to introduce the first keynote speaker. So, Dr. Srinivas Garu, please introduce the first keynote speaker.
Sure, Professor. Sir, actually, can you just share the screen? Actually, I do not have about you.
Yes, sir. Yes, sir.
Yeah. Now it's my pleasure to introduce our keynote speaker today, Dr. Sivaprasad AVS. Dr. Sivaprasad AVS is obtained his PhD in mechanical engineering with a specialization in solid mechanics from IIT Kanpur in 2015. He obtained his MTech in mechanical engineering in the same specialization at the same institute in 2007. He studied BTech in mechanical engineering in Sri Venkateswara University College of Engineering, Tirupati from 2001 to 2005. After obtaining MTech from IIT Kanpur, Sivaprasad worked for a year from 2007 to 2008 in GE India Technology Center, Bangalore, where he got exposure for designing high temperature components subjected to mixed cycle thermal fatigue loading conditions. After obtaining PhD from IIT Kanpur, he went to University of Arizona, Tucson, USA as a visiting postdoctoral research associate, where he worked on peridynamic differential operator and its applications. Prior to joining at IIIT DM Kanchipuram in May 2018, he served as assistant professor in the Department of Mechanical Engineering, BITS Pilani, Hyderabad campus. During his PhD, he studied the dynamic behavior of materials subjected to extreme strain rates using a mesh-free method called smoothed particle hydrodynamics. His primary areas of interest in research are meshless methods, dynamic behavior of materials, and wave propagation in solids. At present, he is focused on nonlinear waves in the thermoelastic solids and applications of symmetric smoothed particles hydrodynamics. So with this, I would like to invite our keynote speaker, today's structural engineering keynote speaker, Dr. Sivaprasad AVS, to carry over. Thank you, sir.
Thank you, sir. Thank you for the introduction,
Yeah,
sir.
sir.
So if I am allowed to share the content, then I will.
Yes, sir. Now you can share the content, sir.
So I should be able to share the entire screen, no, sir?
Yes, sir.
So are you able to see my screen, sir?
Yeah.
Yes, sir. Great, sir. Perfect.
So, yeah, thank you very much. Without delaying further, I would like to start off my session. I am currently an assistant professor, as it was introduced, in IIIT DM Kanchipuram. So the title of the talk is going to be Numerical Investigations Enabled Design for Blast and Shock Mitigation of Structures. So the motivation behind this, in short, is the ammunition storage structures and buildings, primarily in defense laboratories, but also in other organizations like ISRO, or even in chemical factories or any other industries where there are inflammable material to be stored. So in those buildings, how to design those buildings so that the damage causes whatever, like whenever there is an accident that takes place, right, because of explosion, we keep seeing lots and lots of news that this building caught fire because of an explosion that happened, etc., etc. So how to minimize the damage? How do you minimize the damage? So that's the motivation behind getting into this, right? So let me move to the next slide. So the flow of the talk is like this. It's going to be on brief overview of blast phenomenon, and then shock waves, the mathematical theory. I'll keep it very concise because case study is of more relevance in our talk now that we have lost time. So, so let me move further. So what are the various high strain rate phenomena in solids that we keep coming across? For example, the impact of celestial bodies on planets, like asteroids impact on planets. So that will result in crater, and that's actually like an explosion. It's not really exploding because of a chemical reaction, but because of a mechanical impact. So there will be a explosion kind of high pressures created because of this impact. And the other thing, bird strike in aeroplanes, then our case, which is blast wave, and then car crash. All these things involve large deformation. Everything happens in dynamically, like just within a fraction of seconds, everything happens. So bullet penetration, and then machining operation. Because I have a mechanical engineering background, I'm interested in machining operations wherein these things happen. And also there are certain material synthesis where shock compaction, that is, you explode the charge, and then so one of the examples is explosive welding. So there you will see material transformation taking place. Okay, so this is one of the part of our simulations, but I'm not going to discuss all these things today. So today our focus is on blast wave. So what is this blast wave, and how do we design structures against or mitigating this blast wave? Okay, so in all these cases there is large deformation and fracture. So to model them, primarily our interest in modeling this phenomenon. To model them, we need to have some special weapons in our armory, right? So let's first understand the blast phenomenon. So here you can probably see my screen that there is an explosion taking place. All that's in yellow color is nothing but the expansion of gases. So it is the explosive material that's expanding suddenly. So it's a sudden expansion, like combustion, right? So it's a sudden expansion of those gases that creates this explosion. So around this, there is an envelope of air which can be seen as a silhouette of this thing, right? So this envelope of air is nothing but the shock wave. Although the fire that is erupting because of the explosion is confined to this region, there is a thick air envelope around this, which is because of the blast wave. And you can see in the bottom picture, it's actually a GIF file, an animation, where an explosion takes place, and then there's a wave that comes through. So there will be a change in refractive index. That's why you will see a different color, like a little translucent here compared to here. Like the sky, there will be contrast that you can see because of the change in the refractive index, because of change in the density of the air, right? So a shock wave will push the air ahead even before the expansion of gases pushes the air. Okay, so one thing that we must understand from this picture is there is material that is expanding at some pace, at some velocity. But even before that, there is this shock wave that is expanding at a different velocity. So there are two envelopes here. One is the material envelope, and the other is the air envelope or the shock envelope. So looking at the pressure versus time graph, so the kind of loads, if any structure is in the vicinity, or for example, these tables, etc., which are there in the vicinity, they might be experiencing a pressure like this, a spike suddenly, and then decay, either triangular or exponential. And then after that, there will be a suction. There will be a suction here. It's like, air is an elastic medium. You all know that. So when a wave propagates through, it will undergo compression and then expansion, because it's like an elastic medium. So it will be oscillating about its main position. So in the process, there will be suction after that pressure, right? So that's why you would see when there is something that's flying, it will try to come back a little bit. Even if we stand near a fast-moving train, a train that's moving at above 100 kilometers per hour, we'll feel a drag towards it. So that's the reason for this suction. Okay, right. Now let's understand a little bit more. Okay, and the blast wave is actually a pressure wave traveling in the air at the speed of more than the sound speed, right? So such speeds are called supersonic. You might have seen supersonic jets. So supersonic shock wave propagates through the air and also the solid whenever it experiences a solid. So let's now there is a structure like this, a building like this. Okay. So, and then an explosion takes place. The distance from the point of explosion, the source of the explosion, to the structure where the shock wave is first felt is called standoff distance. Obviously, standoff distance is an important parameter. As a civil engineer, you might already be knowing, many of you, that standoff distance is an important parameter while designing blast resistant structures. So if you go to any armor based organizations such as Ordnance Factory or DRDO organizations, you will see the distance. They are all stationed very far away, right? So and then now depending upon the distance, so this plot, pressure versus distance, is a plot that tells us, depending upon the standoff distance, the peak pressure will reduce. Obviously, the one that's far will see lesser pressure, and the one that's near will see a very high pressure of impact, right? Impulse. Now, a simple test can be considered here to understand the phenomenon and see how we can do a design. So what people did here, this is actually a aeronautical research laboratory in USA. They did this test. So there is this concrete structure. It's a concrete structure, and there are two rooms in it. Rooms are maybe two kind of garages in it. On one side, it's just concrete wall. On the other side, I'll show you in the next slide. On the other side, on the back side, they did elastomeric retrofitting. I repeat, elastomeric retrofitting. That is, they paste elastomer. I'll show that in the next picture. So this was the test. So somewhere here they exploded the explosive, and then the explosive wave, including the fire, touches the concrete. I mean, it impulses it, and then what happens next? So let's see that. So before explosion, this is the wall. So this is uncoated wall, and this is coated wall. That is the wall with elastomeric retrofitting behind it. Okay, and this is the uncoated wall after explosion, complete shatter. The wall has completely shattered. On the other hand, the coated wall, you can see, right? So it is still intact, and if the resolution is good enough on your end, you can see that there is a little bit of fragmentation here and there, but and even in the bottom, you can see some small fragments of the concrete part, agglomerates. But then it's still intact, which means the concrete has not flown inward also. In this case, many concrete blocks have flown inward. That is, it would have harmed if there were any human beings occupying this place, it would have harmed them. But in this case, that was prevented. So that's a major achievement in the past 2 decades, where they used an elastomeric retrofitting like this. You can see on the back side, there is a black color that you can see. Of course, all these things are to look at the image, it's a video camera here. And this YouTube link should be able to give you full glimpse of this video, right? So let's understand the mechanism from a layman's perspective. So let's say this is the concrete wall, and let's say this is the elastomeric coating given to the back of the concrete wall. So the way it is done, it's there in all websites. So you have to just spray the coating and then allow it to cure, and then it will become like a sheet over the concrete wall. And then after explosion, what happens? The concrete has fragmented, but the elastomeric coating, since it is sticking onto the concrete wall so perfectly, it would bend severely. It will undergo large deformation towards inward and not allow the fragments to get separated. So it has got fragmented. The concrete has got distorted, but it doesn't fall off from the wall. Right? So that's the major achievement by doing this elastomeric coating. And then there are many design considerations in this. So to go deeper is our motive. So with this, I'll move to what is known as shock waves. Now, how does a shock wave appear? So here are a few pictures. Again, I've taken a bullet being fired, and then a sharp-nosed projectile being fired, and in this case, a blast. So all of these things are called Schleierine images. They are there as optical techniques. Okay, so the change in refractive index will give you the shock front. In this case, this is the shape of the shock front, and in this case, this is more sharper shock front. And in the blast wave also, you can see a shock front. So that's called the starting point of the shock wave, and it goes inward up to the material. Okay, so what is this shock wave? So there is traditionally an experiment called shock tube experiment that's there now in all majority of the laboratories who study aerodynamics or hydrodynamics, etc. For example, IT Madras has civil engineering department has this shock tube, mechanical engineering has a shock tube, and also aerospace engineering department has a shock tube. So what is this shock tube? This is a tube containing a driver section and a driven section. Okay, or the otherwise, whichever is the high pressure side, that is the driver section, and the driven section is the low pressure side. Okay. So to the left of it, there is a diaphragm here. To the left of it, there will be a high density, high pressure, high initial velocity, right? That gas will be filled, and then to the right of diaphragm, you will maintain vacuum. Okay, and then the diaphragm will be suddenly punctured automatically. You cannot stand close to it when the experiment is being conducted because it is not safe. So, and then this diaphragm is punctured or suddenly removed somehow, right? And then what happens is there will be a shock wave traveling towards the right. Since I have taken high pressure on the left, there will be a high pressure shock wave traveling towards the right. And meanwhile, there will be a rarefaction wave traveling towards the left. What is a rarefaction wave? A rarefaction wave rarefies the medium. That's why it's called rarefaction wave. So it will reduce the density and pressure of the medium ahead of it, while a shock wave will increase the pressure and density of the medium ahead of it. That's how they two are different. Okay, and this rarefaction wave will not be as sharp as shock wave is. So it will be like a diffused, line. So there will be a head and a tail to it. Okay, so that's why if you look at the density, right? So I've plotted density here. Even pressure will have the same, profile, and same with velocity. So density profile, if you plot along the axis of this shock tube, you will have a high density on the left, but then there is a rarefaction wave that is consuming this density. On the other hand, there is a shock wave that is increasing the density on the right. So this solution is called a Riemann solution to Riemann shock tube problem. Okay, so you can see that the characteristic of the shock wave is sudden. So a material which is normally strong enough to withstand quasi-static loads will not be able to respond properly to this shock load, even though the magnitude is the same. I repeat this last statement. A material which is strong enough to take a quasi-static load of certain magnitude will not be ready to take a dynamic load of the same magnitude. So this is a very commonly observed phenomenon. And the reason is this, because of the suddenness. That's why it's called shock, a mechanical shock. Okay, so let's get into a little bit of mathematics, which is unavoidable. So since we have governing equations like conservation of mass, momentum, and energy, all of them can be written as follows. I'll not get deeper into this, the mathematical part. I'll just tell you there is something called method of characteristics. If those of you who are willing to pursue in deeper math can actually take this up. So using method of characteristics to study the wave propagation in a nonlinear medium is what I'm showing here. So I'll just straight away go to the problem. So let's say there's a problem here where I choose a triangular profile as an initial distribution. Okay, and let's see how it propagates. It will just propagate if the medium is a linear medium and the wave phenomenon is also linear. It will just propagate like a unattenuated pulse. But on the other hand, there is something called inviscid-Burgers equation. Now, in inviscid-Burgers equation, you will have a nonlinearity because of this term. Okay, this is simple wave equation. This is the simplest possible that you can take to study the shock waves. Okay, again, using method of characteristics, if you do, and then find out the solution, which I'm not going deeper, you will end up seeing at one point, there will be a shock occurring. And that point can be found out in the XT diagram like this. So XT diagram means on the x-axis you will have the position, on the y-axis you will have the time, right? And each line represents the characteristic. Each line represents the characteristic. Okay, so let's see what happens to a triangular profile. So a triangular profile initially taken suddenly becomes a shock wave and then starts propagating to the right, right? So even though there is no scope for shock wave in a material, depending upon the boundary condition or the initial condition. In this case, it is the initial condition. There can be a shock wave. Okay, so this helps us understand what kind of phenomena, what kind of situations will give us shock waves. Okay, and then I did how a sinusoidal curve becomes a shock, like that. Okay, so let me just again take you through the brief of Huguenot jump conditions or Rankine-Huguenot jump conditions. So you have to take through this Reynolds transport theorem, all those things which are conventionally taught in fluid mechanics also, but they are both relevant in fluid mechanics and solid mechanics. So you will have a surface of singularity because shock wave is a surface of singularity across which stresses jump and then strains jump, and then so you have energy jump. Therefore, you need a separate treatment of the governing equations. So you'll have these jump conditions written, and then when you write the jump conditions, you finally get a local form of the jump condition like this, right? So where pi is any quantity. For example, for conservation of mass, pi has to be equal to 1 and Fn, the external source, is 0. So you will get this rho v equal to 0. And then you will get this for conservation of linear momentum, that is the jump in this quantity must be equal to 0 across that surface. Similarly, this one. So these three equations must also be satisfied in addition to the initial boundary conditions, governing equations in the respective bodies, right? There are two bodies here, the left side which is shocked and the right side which is unshocked or the parent material, right? Now for one dimensional case, it reduces to simple equations which we come across in fluid mechanics normally in any fluid flow. For example, the second equation you can call it as Bernoulli's equation, right? Because it's the momentum equation. The third equation is the energy equation, etc. Right? So if you combine these three equations, you end up getting a what is known as a Huguenot curve or a equation of state. So if you plot that, this is how it will look like. Now, normally we are aware of equation of states for gases, but the equation of state for solids look like this. Okay. Now, so what to do with this? Okay. So finally, we need to know that there is a relationship between shock velocity and the material velocity, and this is something that we get from experiments. Extensively done predominantly in CSIR laboratories and also in BARC laboratories. There is something called flyer plate impact experimental setup from which you can get this data. Okay. So once this data is obtained, you can feed this into the equation of the state and then implement the equation of the state along with the elastoplastic constitutive equation and solve the problem. That's how the procedure is. Now let us do a case study where we'll design a bilayer system, for planar shock waves. Okay. So what is this bilayer system? I'll just to compare. You can see there is this metal layer and then metal layer with an elastomeric backing, elastomeric retrofitting. Okay. So I took metal because metals have been extensively studied, but then this study can also be extended to concrete. And in fact, one of our ongoing projects is on concrete and steel coated polyurea. Polyurea coated on concrete and steel subjected to blast waves. So that's something that we're doing and it's still going on. So right now, I'll just tell you for any metal layer how we have designed. Okay, so what I'm showing here is the void volume fraction or the damage in the metal layer when there is no elastomeric backing and when there is a pressure wave hitting it. Okay, and when there is an elastomeric backing and a pressure wave hitting it. In both the cases, I have plotted the damage evolution, and you can see the x-axis is the time normalized normalized in terms of some constants. Okay, so that width, the time taken is significantly increased for the final damage to occur. So when it reaches a critical failure, I call it as completely failed. So 0.35 is the critical void volume fraction, and after that it fails. So that's my idea. Now, so this is the delay I get in evolution of the damage. Okay, so I have used different constitutive equations for the materials. So for metal, this is the constitutive equation, and I mean, this is more elaborate here. It will be given in this Material Science Research International paper. The material properties of, I think I have taken it for copper, but then it's not that important when it comes to wave propagation analysis. So and there is a damage model that's used for the metal. So I used this ductile fracture model based on void growth, right? So this was used there. So it's a nonlinear second order differential equation, which was solved using Runge-Kutta. A Fortran code was developed for this. So this is the applied loading term, and the matrix behavior is hidden in this equation. And this entire term is all that contains the void growth fraction, right? Now, for the elastomeric backing, of course, you know, elastomeric means they are rubbers, rubber coatings, right? So rubber materials usually have a spring, nonlinear spring. And then I also used a dashpot to take its viscous behavior. So it's a convolution between the hyperelasticity and viscoelasticity, where the viscoelasticity is taken by this time response function. I've taken only one term here. You can take more terms to suit it to Prony series. And then if it's weakly compressible in the sense that it's weakly incompressible in the sense that its Poisson's ratio is close to 0.5. So if this KB value is taken to be, this bulk modulus value is taken to be infinitely high compared to the shear modulus, like 10,000 times, etc., you will nearly simulate it as a neo-Hookean material where J is equal to 1. That is the change in volume is nearly equal to 1. Right. So let me explain you the XT diagram. So whenever there is a pressure pulse, so what happens? There is a pressure pulse that's going on like this, and when it hits the free surface and comes back, there will be a rarefaction wave. And when both the rarefaction waves meet, what you get is a tensile pulse. So this is why you might be wondering, when I hit a compressive wave, when I put a compressive wave on the wall, how come the wall is breaking? Why should it break? Because compressive wave will not remain compressive throughout. It will go look at the free surface, and if it hits the free surface, and when it comes back, it will be a tensile wave. So there will be a tensile wave here. And you can see when there is a tensile wave, there will be a fracture occurring at the point where the first tensile wave is formed. Now, as the tensile wave propagates, again there will be a compressive wave in the backward direction, and again there will be a tensile wave, etc. Okay, so now I have done this experiment for two pressures. One is 2 GPa. Please listen to this, 2 GPa. The other is 4 GPa. For 4 GPa, in a single shot, it grows to high tensile stress. For 2 GPa, the damage happens in two stages. In between, there is a dwell because of this compressive wave, right? So this is the final fracture occurring. And then after this, there is a complete failure. Okay, so here I have marked the regions of tensile wave and the regions of compressive wave separately, right? Now I did various experiments. I mean, all of these are numerical experiments, right? I mean, virtual experiments. They are done on computer, theoretical, right? So I took KB by mu B approximately 100, and then this is nearly incompressible. And then I found that this is the delay in the material. So why the delay? Now, earlier I didn't have backing when I showed the XT diagram. Now with backing, what is the XT diagram? So when a compressive wave passes, it continues to be a compressive wave even when it goes through the elastomeric retrofitting. Now, when it returns back, it will remain a compressive wave only. Therefore, the first tensile wave that was formed because of without elastomeric backing will remain compressive in this case. So there will be a delay in the fracture. So then you will get a tensile wave. And the tensile wave's magnitude is lesser. This tensile wave's magnitude is lesser than this tensile wave's magnitude. And then, therefore, the amount of damage rise in the without elastomeric backing case is higher than the amount of damage rise in the with elastomeric backing case. And like that, if you do analysis, you will see that there is a significant delay in the fracture. So that's the reason behind fracture. Now, if we can kill all these all these red lines indicate the tensile waves. If you can kill all these tensile waves, then you are delaying this fracture further. So let us see how we can delay these tensile waves. Okay, so how to weaken these? I want to weaken these tensile pulses. That is my design criteria, right? And get rid of at least get rid of or weaken this, right? So what I do, I pursue two ideas. One is thickness. If I vary the thickness, somehow the onset of this arrival of this tensile wave can be controlled. So I do this control. So this compressive wave on tensile wave. So when this compressive wave superposes with a tensile wave, what happens? The magnitude of the tensile wave will be either 0, or if the compressive wave is a higher magnitude, it will remain compressive only. So we try to make this thickness ratio. So we came across a solution where we can find out an optimal thickness. For every configuration, there will be an optimal thickness. It depends upon the material that you use. It depends upon the loading that you use. So it will be loading dependent also. So you have to repeat this analysis for that, right? So for different thicknesses, you will find out that the delay is different. And finally, at one particular, when the metallic layer, when the elastomeric layer is half the thickness of the metal, you will see that there is a significant delay, about 45 times the delay of the time constant, TD. TD is the time taken for the wave to travel through the metal layer. So it is allowing so much of time. So in that time, what's happening to the material? It's undergoing a lot of viscous dissipation. So you have to understand that viscous dissipation part now. Okay. So this is one important thickness based design that we did. I'll just take 5 more minutes, sir. I will just take 5 more minutes. Okay. And then, yeah, thank you. And then there is one more idea where you have a fictitious material. This is not now a fictitious material. When this work was carried out, this material didn't exist. But later on, DRDO in Delhi, they have devised a material, polyurea, which behaves like this. Okay, I'll just tell you how we came across. So backing higher impedance, right? So can we make it both viscous as well as higher impedance? For making it viscous, you need to have low impedance. Impedance means low moduli, right? So let us try to understand that part. So what I proposed, so this was completely my idea that I gave to my guide, and then we both implemented it. So when a wave propagates through the elastomeric backing, we told that a part of the elastomeric backing should undergo impedance increase in the impedance. So hardened region induced by the passage of shock waves. So this is called shock wave induced transformation of solids. This is not new. Shock wave induced transformation of solids is not new. It's there in ceramics. But then this was identified from mechanistic point of view in polyurea by us, and simultaneously by Micha Gurjicic in molecular dynamic simulations. So what we did, I'll just conclude. So when the elastic modulus and density are both simultaneously increased, the impedance increases, right? So if you maintain the ratio same, the impedance will remain same. Impedance will be increased, but the speed of propagation will remain same. So that allows sufficient time for the shock to get dissipated in the viscoelastic material. At the same time, we are not compromising with the impedance, right? So this is what we achieved in simulation. The earlier one was schematic. This is in simulation for a threshold pressure of 250 MPa. So if it is greater than 250 MPa, the material gets transformed into a hardened material. So this was actually investigated in molecular dynamic simulations, and studies are still going on where segmental dynamics of polyurea under high strain rate deformation is being studied. So the material aspect is still being studied. Characterization under same time, or maybe under XRD. XRD is better characterization technique to characterize the polyurea in situ deformation under dynamic conditions. So again, we were able to achieve around 30 times delay in the fracture. Okay, so these are the two design considerations which many people are now studying, and this work has been published in the Proceedings of Royal Society, London. Okay, so with this, I conclude my talk. If there are any questions, I would like to take, because I don't want to keep talking. There are a lot of things to talk about, but I would like to conclude here. Yes, sir, I am done. Any questions, I am ready to take.
So thank you very much, sir, for your nice presentation. Sir, just I would like to ask one small question. There are a number of NDT tests for evaluating the quality of the concrete. So here, a low intensity blast or low intensity shock, by creating a low intensity blast without damaging the structure, can we use it as an NDT technique for the to evaluate the quality of the concrete or quality of the structure? A low intensity blast, which will not damage, but by creating low intensity blast and measuring its response, in the structure. Can we use it as additive technique? One of the additive techniques.
I'm really sorry, sir. I have never thought about this NDT at all. But I think it, because once you do a blast, there will be some amount of damage. It may not completely damage, but I believe that there will be some extent of damage already imposed, no, sir? Because even if it's a small magnitude blast, I think even at the surface level, at least it may cause some damage.
I mean, the low intensity blast means because beating the drums, it will create some sound wave. Then we feel some a little bit of shock, like that increase that if you increase the intensity, the low intensity can be used as a technique to, if you measure the low intensity on the structure, that will be a measure for to measure the quality of the structure. That is just after your lecture, just I got this idea. Just I am sharing. Yes,
Yes, sure,
just
sir.
okay. Thank you, sir. Thank you
I
very
think
much.
acoustic emission is probably possible, sir. Yes.
Okay, thank you, sir. Dear participants, we are fortunate to have our chairman, sir, M.H. Reddy garu. Then I'll give the brief introduction about the M.H. Reddy garu. And sir, thank you very much, sir, for your lecture.
Okay, sir. So,
Excuse me, sir.
Yes, yes.
Sir, can I ask a question, sir? Quick question.
Yeah, please. Okay.
Good afternoon, Dr. Shiv Prasad, and good afternoon, everyone. Sir, I just have one small question. So, suppose we have a very less stand of distance at a near a blast, which would cause a very high rise in temperature. So, this elastomeric backing membrane, can it sustain high temperatures? Where more is it like more than concrete, or how would we analyze that situation?
Yeah, thanks for that question, sir. Yes, it's a good question. Actually, the Center for Fire, Explosive and Environmental Safety in Delhi is pursuing this idea. Definitely, there is this material called polyurea. I might have mentioned in my talk. This polyurea is a fire retardant material, and definitely it's not better than concrete. But if concrete can bear some heat and sustain some heat, and then whatever damage happens to concrete, after that, whatever remaining temperature or the heat is there, it may not affect polyurea that much. That's what their proposal is. So it's still going on. So fire retardant materials, among fire retardant materials, this polyurea is being considered as one of the fire retardant materials. It's V50. There is some limit called V50, like ballistic limit in. So there is this limit which tells that within 30 seconds it should actually lose that fire. Like if it should catch the fire and then get rid of that fire within 30 seconds. The fire should get switched off. So that polyurea has tested, but still it's still not in the commercial stage. So yes, there are certain materials which are comparable to concrete in fire retardants. Any?
Okay, sir. And one. Yes, sir. Yes, sir. That is clear to me. And one quick question: is there a codal provision for classification of buildings that need to be designed for blast resistance?
Oh, I'm not an expert on design of buildings as such. So I'm a materials person. So I took an application to building materials. Yes, but I'm not
thank you, sir.
an expert in buildings design. Yes, thank you.
Okay, thank you so much, sir. Thank you so much.
Thank you, sir. Shivkishore garu, just a slide, please, on M.H. Reddy garu. Slide, just. Yeah, we are fortunate to have engineer H.M. Reddy garu, and he's our board of studies member. And I'll give the brief introduction about Reddy garu. Next slide, please. Yeah, engineer M. Hemant Reddy garu. He is a deputy executive engineer working in APCRDA. He did his BG from Bapatla Engineering College in 1986. MTech structures from the Acharya Nagarjuna University in 2015. His total service is approximately 35 years. He is presently working in APCRDA for the last 6 years, constructed AP Secretariat buildings and also external infrastructure, and in charge of 50 floors tall towers now under halt. Having is having vast experience in multi-story buildings and also construction of bridges, design of design and execution of roads and infrastructure. Presently involved in cities challenge project Amaravati, and in addition to that, and we are closely, especially civil engineering department is closely associated with the HM Reddy garu. Whenever our students wanted to visit Amaravati, he was readily accept that our invitation, our request. Then many of our students have seen the structures in Amaravati, and also he is a member in many of our committees. And I invite HM Reddy garu to take the floor. Dr. HM Reddy garu.
Sir, thank you. Thank you, sir.
Okay.
Thank you for
Sir,
your introduction. Thank
sir,
you
now,
for giving me the opportunity to participate as one of the member in your committee.
So now that we have completed one keynote lecture, sir, another keynote speaker is not available. Now there will be paper presentation. I think list is available to you. Now please take over the floor, sir.
Yeah, please. We can start the lecture, I hope, sir.
Yeah, now the lectures are over, sir. Now it will be paper presentation. You may call one by one.
Yeah. Who is the next person, sir? I cannot.
Sir, actually, keynote sessions were completed, sir. We shall go with the paper presentation.
Yeah,
So,
paper presentation. Sir. Who will present the first paper?
Yes, sir. Yes, sir. So I send you the rubrics for the best paper, sir. So
okay.
I shall call the same series, sir. So,
okay.
In this regard, I shall call you paper ID number 22.
Right. Very good. Very good. Will you narrate how you are giving the marks in terms of presentation, something like in
yes,
4 different ways? Will you explain me? Will you narrate me?
Yes, sir. Sure, sir. I'm opening the file. Sir, there are 4 criteria need to be considered, sir.
Yeah.
The first one, quality and innovation, that is 20 marks. So you shall give the marks for 20 marks. Maximum marks are 20 marks. Next, presentation skills, applications and benefits. Next, question and answers. So the total marks are 80, sir. According these total marks, we shall give the marks.
Okay. What is the last one?
Last one is 178, sir. Paper ID number 178.
No. You are giving 20 plus 20 marks. No, what is the last parameter?
Question and answers.
Yeah. Okay. We can call the person 22 to.
Okay, sir. I'm calling.
Funny, మీ కాలేజే.
So, Commissioner, sir.
Yes, sir. Yes, sir.
Sir, Dr.
Sir,
Thank
you may call one.
Sir.
You can call one by one, sir. Where is present here?
Sir, Commissioner, sir.
Yes, sir. Yes, sir.
Dr. Tenka Pasla, sir, he is ready to join, sir.
Oh, as a keynote speaker? Okay. Because we have already introduced to the participants, then, Sir Reddy garu, there another keynote lecture is there. Then,
Yeah, better. Why not? Why not as you like?
Yes, sir. Sir, now, Shivkishore garu, you can ask him to start his lecture.
Yes, sir. He is joining right now, sir. Just 1 minute.
Okay.
Just call me.
Okay. Sir, if there is any delay in joining, we'll take 1 or 2 papers.
Okay, sir.
Then I think because we are losing our time, then we'll have 1 or 2 presentation before he joins.
Okay, sir. Okay, sir. So, ID number 22 is available. Please raise your hand so that I can give you the presenter status. If not available, I shall go with the paper ID number 61. Paper ID number 63. Paper ID number 63 is available, sir. We shall start with you.
Okay.
Paper ID number 63, Renu, you are the presenter. You can share your screen. Yes. Yeah. Renu Sara, your audio is, you are not audible. What happened to you, Renu Sara?
Yeah. 63 is not coming forward.
I think she is there, sir. She already shared the screen also. If you have any issues, let me know, please.
I think she may join later. I think we'll call another.
We'll call another, sir. Paper ID number 115. Please raise your hand. Paper ID 115. Paper ID 140. Ram Shankar R. Paper ID 140 R. Ram Shankar. Please raise your hand. Yeah, paper ID 61. Please raise your hand.
It seems Dasirathi 61 is ready, I think.
Yes, sir. So where actually I am not finding you. Please raise your hand. Paper number 61.
Last. The screen on the last.
Yeah, got it. Okay. So now you are the presenter. Please share your screen. Paper number 61. Yes. You can unmute yourself. Given to privilege to you. Please click on unmute. Yes, correct. Yeah, now you can share your screen.
Yeah. I have shared now.
Okay.
Is it visible, sir?
Yes, yes, perfectly.
Yeah. Shall I start?
Yes, sir, please.
Yeah, actually, I'm Dasadi going to present about noise reduction using concrete barriers, a case study.
Okay.
See why
Sir,
this study
please open
means.
your presentation, sir. It is just
Yeah, this is
setting
my
the.
presentation. I started my presentation.
No, the presentation, the PPT
No,
is not visible.
it
Not
is not
visible.
visible.
Not visible. 1 minute, sir. No visible,
So,
sir.
please select the screen sharing.
Sir, I have shared the screen actually, but it is coming entire screen.
Yes, sir, correct,
Yeah,
correct only.
Yeah.
You are in the correct
Yeah,
way
now
only.
it is coming.
Now
Yes.
it's connecting, sir.
Yeah, now
Sharing,
open
sir.
your. It is okay.
Yeah.
Perfectly.
Sir, perfect, sharing.
Yes.
Yeah.
Sir,
Shall I start
respected
now?
chair, sir, this is the
Sir?
paper ID number 61, sir.
Yes, sir. Sir, shall I go?
Yeah, please.
Okay, see, I'm going to present noise reduction using concrete barriers, a case study. See, why I'm doing this is, as you know pretty well, noise has become a lot of problems with respect to traffic, and it gives a lot of pollution. And that made me to see there are a lot of barriers. So I checked with the concrete as a barrier for reducing the noise pollution. I tried with that, but there are some more works to be carried on. But even though it is a part of my work, I started with just making it as a cubicles, and in order to see that whether noise reduction is there using that. And this is the present study area I have selected here, where a lot of movement with respect to traffic is existed, and as you know pretty well, because of traffic, noise pollution will be there. So my objective of this study is to first determine the noise pollution and whether any noise attenuation, that is reduction, is required, and what are the existing measures are available, and to construct a noise barrier and see that which barrier is useful. And my next work is how to go about providing a noise barrier. I have done a lot of literature with respect to this, starting from 86 to 2000, even though, but it made me to use of noise barrier, and here the noise barrier utilization is very very less, and the study is also very less actually. So that made me to think of using a noise barrier, even though we provide a noise barrier as an aquatic measure inside the halls or malls or at any place we provide. Now, coming back to pollution, as you know pretty well, noise is an unwanted sound, and it creates a lot of disturbance at all times. At all times, we face noise. There are different effects, and especially we have psychological and physiological effect, and a lot of fatigues, pressures. It causes depression and panic among users. That made me to create introducing any measure with respect to noise pollution. So I have chosen first a study area, as I gave initially. I gave with respect to a picture that I have selected a study area, and I have conducted survey. And even though I have conducted survey for 2 hours, where I have constructed a cubicles of length 1 meter, 1 meter, and height zero point 0.6, and I have constructed by two. That is, one is made of normally concrete mix, and another one is making with respect to a conventional a partial replacement of cement with respect to coral shell powder. So where I have used this noise meter for measuring the noise inside as well as the outside area. So these were the parameters calculated for the primary survey where I have conducted. Once I have conducted the survey at the initial level without anything, so what happened? The noise level was 80, around 46% higher than the standards, and at place 2 it was 11% higher. And why it was low means with respect to starting from 59.3 to 87 decibels, and the 90, so 90% of my noise level exceeds 90% of my time. and see around 66 decibel, 21% higher than the standards at place 1 as well as place 2 values. So now it is ideal time for based on my objective that a noise attenuating measure is required at this level of noise what we have now. So how to control noise? There are different measure where you can able to control the noise actually. So we can control at source or a path with respect to protective equipment. I have used the transmission path as a source of reducing the noise. So this where you can use the source where this is the source is there is a path, and this is the receiver. So this place I identified as a path as a barrier, and where I have provided a cubicles in such a way that noise whether using a cubicles whether it is reduced or not. That's what I have said that and I have placed as a barrier for this. And this way, in this area, I have constructed the cubicles like this. See, I have constructed 3 cubicles, but even though I have compared mostly with respect to a normal concrete as well as the conventional concrete, even though I have casted even using the fly ash bricks too. I have used the fly ash bricks too for that. Even but in my comparison, I will show a small comparison of all the three actually. So what I did actually, I have measured the noise outside as well as inside actually. Because it's a data logger, I can easily able to log my thing actually. So the result what it has been present here, even though as I told you, the 50% higher than without the barrier. But when I show that, so there was a reduction using the 16% using the coral shell powder, and 15 to 10 decibel reduction I got with respect to using the concrete barriers. These were the values I got with respect to using this value, and these were the places actually. If you see this is the open place. This is using the normal concrete as well as with respect to the coral concrete. If you see this, how the noise is reduced inside the cubicles from 73 to it is 61. Similarly, the maximum is 98 where outside, whereas inside it is got only 86. So there is a locations actually. So with this, my consideration is noise reduced with the level of commotion decreases, which is appeared in the previous figure. And the noise level is 73.3 from the year 2013 when I started this actually, expanded to 105 decibels in 2019 at both the locations. So there is a considerable changes with respect to my data even that. And actually inside the area it is reduced to 70 to 74, and at area it is 79 to 79.64 area. See, all these I have summarized, and this is the percentage of reduction with respect to the equivalent level of noise inside as well as outside actually. So when I compared this noise barrier, whatever I have provided, even though I have provided the M30 concrete with the normal as well as conventional and fly ash, as I told you, see, all are reducing noise. But only thing is actually the percentage of reduction it is varies with respect to this. That means I got a noise reduction of about 11 to 20%, and 3 to 7% use time introducing for comparison. Nothing more than with respect to this fly ash. So this is my conclusion. As you know pretty well that everyone contributes the noise pollution, and there are different sources of noise pollution. But I have identified traffic as a pollution, and I have identified the cubicles as one of the measure that it can be noise can be reduced. But how best the concrete can be provided in areas where the noise can be is more, it can be easily uh, um, easily find with respect to the further research. Actually, even though it is a startup with respect to providing a barrier, why I am using this barrier is because nowadays noise has become that much as a pollution. Actually, and aesthetically, it is very difficult to provide concrete as a barrier. But we have to find a way that a concrete can be provided by some other way, by a thin wall, or by way of by screens like this. If we can think of providing as a barrier where the noise is higher. Thank you. So this is where, and apart from that, is near to railway station, and it is very proximity to railway station, and the movement of
Okay, now I request HM Reddy garu to invite the second keynote speaker, Dr. Jankar Pasla.
Welcome, sir. Sir, I need to introduce or nothing?
Before you joined, he was introduced.
Yeah.
Then I think he can start.
Yeah.
The lecture. He can start the lecture.
Sir, kindly please give your present lecture for this Dr. Suprasad, sir.
No. Dr. Jankar Pasla. Dr. Jankar Pasla.
Dr. Dinkar Pasala ji, you are the presenter. You can share the content. Yes, sir. We are hearing you.
Dr. Dinkar Pasla, please unmute your microphone. Please unmute yourself.
Yes, sir. He shared
So
the.
good afternoon, sir. Can you hear me, sir? Can you hear me?
Yes, sir. Yes, sir. Perfectly.
Okay, thank you so much. Sorry, there was some confusion here and there. Thank you. Thank you. Firstly, I would like to extend my thanks to KL University Management and the Civil Engineering Department for inviting me for this keynote lecture. I immediately accepted it, but today being a working day for us, sorry, I came in the 11th hour and I was requesting all this. Very sorry for that. But anyhow, we'll quickly start off my presentation. I can share my screen. Be able to see, sir?
Yeah. It is
Able to see my presentation?
Yes, sir. Screen
Yes, sir.
is
It is
screen is visible.
Okay, thank you so much for this opportunity once again. Like this is my area which I work. I'm basically a concrete technologist. Also work in structural engineering, but my focus is more on the materials, new product development. Okay, and since Bhubaneswar is situated since in a good state like Odisha, like where we have a lot of mineral waste, lot of waste from the fly ash, slag, and also these red mud. So many wastes are being available. And also, I also sit in this pollution control board meetings and all. We work out some strategies how to effectively use this waste in various proportions in a high volume way. Okay, no matter whether it in the concrete or in the geotechnical applications, whatever the applications, maybe in the brick industry and all. But still, a lot of fly ash and all these wastes are still left unutilized. We have a mammoth problem of having this red mud waste in Orissa, and they're working on some strategies, and we are also started working on those materials for various geotechnical applications and also in this concrete and all this. Okay, and like this is what my presentation today for all of you is the sustainable concrete to the effective use of industrial waste. Okay, the industrial waste which I'm going to focus here as far as my presentation is concerned is like maybe the fly ash, the slag, and what new products we have developed. And also, you might have heard about this industrial, the geopolymer concrete. We have worked extensively on that. Okay, we're still working on that. Okay, it's a cement-free concrete. We have effectively used this red mud and the fly ash and the slag combinations. Okay, 3 industrial waste in one go, in one shot, and we have developed a product. And we also patented that product, and we're going to have a what do you call we're going to have some small startup with a company called Nalco. Okay, Nalco, we're going to have a startup, okay, to have a cement-free concrete. So, like, this is what the basic intention of this presentation is: sustainable concrete. Many people, when I refer this, many people talk about the sustainability. What exactly is the sustainability? Okay, in the true sense, actually. So, I also thought when I work in the sustainable concrete, is simply using some industrial waste, okay, reducing the CO2 emissions and all. If I use a material, okay, which is a CO2 emission waste, and also that it will become a sustainable concrete. That is only to one extent, actually. But there are a lot of other issues. We'll see that actually. The sustainable concrete, like if you look at, since our focus is mainly on concrete, if you look at the positive impact of the concrete, we all know that is the most widely used construction materials next to the water in the world, and it requires the lowest embodied energy. Okay, as far as the environmental impact is concerned, and also the raw materials. Take the Indian scenario, the raw materials are widely available wherever we have this limestone quarries and all. We can simply use this. You can have the cement plant. I mean, you can have the cement manufacturing. But as far as the impact is concerned, okay, both the above indicate that any improvement will have a significant impact on the environment. Actually, if you increase the concrete production, if you increase the cement production, definitely it will. As far as the construction is concerned, it's a positive. In fact, less embodied energy and all this. But what is the negative impact we have on this as far as the environmental concern is concerned? Yes, the cement production, we all know that it emits, okay, so during the calcination process, it emits CO2. Okay, that CO2 is a big threat to the environmental actually. Okay, to the environment. And also you see this nowadays, India is a developing country and also require a huge amount of volume of concrete, okay, to use this in various construction purposes. And definitely every cement manufacturer, there's a lot of demand and supply gap. Okay, to meet those gaps, people started working on increasing the production capacities in all the cement plants. They started effectively using this fly ash and the slag. The blended cements are coming to the market. Now the composite cements are coming to the market. So many things are coming up in the market, okay, to meet all these demands. Okay, so this is what, so definitely there is a lot of impact, and definitely the lot of CO2 emissions will be there. And also if you look at globally, okay, in fact globally, like the CO2 emissions account for 5%, okay, and also the concrete usage is being increased drastically, okay, and it is at the rate of 30 billion tons per year actually. Look at the environment. This was the negative impact, and we have seen the positive impact. We have seen the negative impact as far as the environment is concerned. It's not only the environment and the sustainability. We have another issue actually. We have the economic impact. So the economic impact also accounts for the sustainability of the concrete. And what is the positive impact as far as the economic impact is concerned? Yes, definitely. India is a labor-intensive country. We have a huge amount of population. But definitely the construction provides a good livelihood to a large percentage of people. Okay, you take any major cities where a lot of construction activity takes place, the Hyderabad or any big metro cities, a lot of activities going to take place. a lot of activities are being taking place, and it provides a huge amount of livelihood to the various construction workers. And also you see this, it's increasing at a dramatic pace. Okay, 3 to 4% increase is there every year as far the construction spending is concerned. This is one of the positive impact. What is the negative impact as far the economic impact is concerned? Yes, the negative impact is, yes, the problem is because we are in a hurry. Everybody wants to build the structures in a hurry manner, and because of this, it leads to the quality problems, and definitely subsequently you're going to have the high repair and the rehabilitation costs. That expense, that itself is a very costly affair, and that also adds to the economy of the building or the infrastructure project, whatever we are handling it. And also we want to see that many people say that we want to cut the cost cutting, but where exactly they do the cost cutting? Because of this cost cutting, ultimately the quality will be affected. That we have already seen this. See the comparison between the government buildings and the private buildings. Wherever I go for any buildings and all, I see it's really in bad condition, especially in Orissa. I used to visit this government. In the secretariat itself is in a very bad shape, where the IAS officer sits. I also tell them in all the meetings, this is not the way actually. Simultaneously, on the other hand, you have the Infosys building, you have the TCS building. Why can't you have the proper maintenance program? Why can't you have all these programs? They never listens to us. This is what ultimately the quality will be affected. This is what, and definitely because of that, we are doing the double work and we are investing doubly in every infrastructure project. We will take the buildings or whatever it may be. That is about the sustainability. We have seen the environmental impact and the economic impact, and other things is the social impact. Yes, this also accounts for the sustainability of the concrete. And what is the positive impact as far as the concrete is concerned? Yes, definitely for some of these people as a business, it's definitely a long-term investment because it's within reach for most of the people, and it provides security to the users. That is what the positive impact as far as the social impact is concerned. But what is the negative impact? Problem is a lot of even the two-tier cities are being urbanized. Okay, they became like a metro cities. Okay, and they're becoming a lot of cities are becoming concrete jungles. Okay, and also we don't know, okay, whether the quality of the concrete is up to the mark. This is a basic concern everywhere, and these are the three things which affects the sustainability of the concrete. It's not that simply using some industrial waste we get the sustainability. It's not that. Yes, environmental impact is one concern. At the same time, simultaneously, all three will go hand in hand. We need to have the economic impact is also there that we already seen, and the social impact. What kind of impact it is having socially on the on this sustainability. So all these three account for will lead to the sustainability of the economy. That is what we want to see this. The word S is sustainability success can be achieved. It should have the maximum positive economic impact, okay, and the environmental impact and the social impacts. And that is how we'll define the sustainability. It is not that only the environmental impact, okay, it accounts for the environmental, the economic, and the social impact. It contributes to the sustainability of the concrete. This is what my presentation is. Like if you look at the concrete construction is concerned, yes, and how to attain this sustainability and how to effectively utilize these raw materials and effectively utilize this space in an effective manner. Use less raw materials and energy over the whole life is some of the slogans given. You can reduce the emissions and the waste over the whole life. Analyze the cost effectiveness. You should not compromise on the quality, okay, and analyze the social impact. Okay, these three things are some of the principles for the concrete construction. And as far as the sustainability is concerned, as far as the concrete is concerned, the cement is concerned, use less clinker in the water and more of the waste materials. Like that's what you see this in the market. We have nowadays, we are not getting ordinary Portland cement. Only the government clients insist for some of the projects we want OPC. They're still in a very traditional way. You see some of the projects, yes, wherever you go, the fly ash is available and the slag is available, slag cement. Yes, and many people come and ask me like what to do, like there's a trade-off between both these things, what to do. So effectively utilize all this, okay, so that it leads to the more sustainability of the concrete, increase the useful life of the project. Definitely there are reports, okay, they're using the fly ash or a slag cement, okay, the overall in the future, I mean in the long-term performance will be improved as far as the concrete is concerned, okay, and increase the overall cost. It leads to some cost effectiveness of the structure or the element whatever we're talking about, okay, and improve the defect insensitivity of the tolerance. Like as far as Indian market is concerned, yes, these two are the most widely available raw material, waste materials, the fly ash and the slag. And how do they account for the sustainability? How do these waste help us? Definitely, There are proven reports, and we also seen in the labs the fly ash or a slag, whenever you use, it really adds value to the product. It's more uniform on the homogeneous mix. Okay, it leads to the better performance. Okay, in terms of the fresh properties and the hardened concrete properties, it improves the pumping performance. It improves the hardened concrete, improves the durability. The service life will be improved, and you can reduce the maintenance costs. Okay, it aids in the use of the waste as a mineral admixtures. Okay, nowadays people are manufacturing these aggregates, the fly ash based aggregates. I think you see this problem. This aggregate is a natural resource. Okay, wherever we want aggregates for the construction, we go and quarry these mines actually. The same was the problem in the Mumbai. Now you see in Mumbai there is no natural sand because they're going and digging the sand near to this thing. The government of Maharashtra, they put a ban on the sand, the natural sand, and they have no other source, and they started using the quarry dust, the dust which we get when we crush these aggregates, natural aggregates. So they're doing this dust in the form of sand, and they're doing a lot of research on that, and that is what the availability is. Similarly, the day will come when government will impose a ban on these natural aggregates and all. Definitely, we need to work from alternate materials. We need to have some man-made aggregates. Like this in Orissa, we have two companies. They already started manufacturing these fly ash-based aggregates. Okay, and they are exporting in a very big way. Okay, and also good. It leads to the good working environment at the construction site. As far as this project is concerned, as far as my presentation is concerned, we are going to address three issues. We have effectively used slag in making a self-compacting concrete, some of the projects of our PhD students in MTech, and we have successfully used the structural lightweight concrete using the structural lightweight aggregates, which are all fly ash based aggregates, okay, which are widely available by two manufacturers. We have done some R&D projects for these two manufacturers. And that is also one good work we have done at IIT Bhubaneswar. And also we have got a project. I already told you in the initial beginning of this presentation that we have a we have a patent with we filed a patent with combined with Nalco, one national aluminum company, that using this fly ash, slag, and red mud, and we developed a cement-free concrete, and we're going to have a startup for these as well. So these three issues I will slightly highlight so that you'll see what exactly we're doing at. Okay, what exactly we have done is we have used effective, I said, the effective utilization up to 90% replacement of the cement. Only 10% is cement and 90% effectively in the development of self-compacting concretes. And with that, we have effectively, we could able to develop. With that, we could able to develop a strength in the range of 200 megapascals. And also we have studied, okay, we have studied effectively what is the durability and the corrosion aspects as far as the self-compacting concrete is concerned. These are some of the mixes we have defined from 20 to 100. Okay, and these are some of the fresh properties. The fresh properties, all the fresh properties proved to be self-compacting in nature. Okay, these are some of the typical photographs how we develop a something. Simply they're pouring this on the molds. They're not using any vibration. Okay, and we have gone up to 90% replacement, and this is what the flow and all. And these are some of the properties which have achieved using this slag. And these are, we have got some typical trends. We have got some design charts. Okay, somebody wants to use a slag, it's a design chart. Somebody wants to use a slag. Let's say he wants to use a 50% slag. Okay, directly go. Okay, you can pick up a strength, particular strength. You get a strength more than 80 megapascals. Somebody wants to use a 40%. Okay, you can directly go. You can pick this. So this is what the design charts effectively you can use this. And after doing this investigation, we have come up with these trends, and people can effectively they can start using these charts in developing the self-compacting using slag and all. And we could able to see this, okay, 36 we could able to develop a strength of nearly 100 megapascals using slag as a replacement material in the development of self-compacting concrete when compared to the normal concretes. That is about this slag. Okay, we have effectively used to the volume of 90%. The next interesting project we have is this the sintered fly ash aggregates. Okay? These aggregates are made from fly ash. You can see these aggregates are made from fly ash. Okay, they're very lightweight. And the specific gravity is also very light. And when I started using these materials in the concrete, definitely the density of the concrete comes down, and definitely the concrete becomes lightweight, and you have the densities of the order of 1900, 1800. We all know this, the concrete typical density is 2400. Okay, when we replace these lightweight aggregates, okay, the density drops down drastically, and it comes to the tune of around 1800 to 2000 kg per meter. There is a reduction of nearly 400 kg. And this is what the lightweight aggregate, there are various types of lightweight aggregates. You all know this. autoclave radiated blocks, these infill walls. Nowadays, see this. Everyone is manufacturing. A lot of manufacturers have come up with these plants, autoclave radiated blocks. Though we call it as a concrete, but still, it's a very lightweight concrete. It's not being used for the structural. Our intention here is, in this project is, my project, like what I'm going to present here, is only to develop a lightweight concrete which can be used structurally for structural applications for any beam element or the column element or a slab element. So other concrete, the foam concrete, the no fine concrete, these are not, though we call them as the concrete, but they are not considered as the structural concretes, and they are used typically for particular applications. So this is what, if you look at the lightweight aggregate family, we have earlier people started the natural aggregates, okay, the pumice and the scoria, and the manufactured also, but here our emphasis is more on the fly ash. Like the basic reason of the fly ash is, like you see this, especially the focus is Orissa State. We have 33 thermal power plants, and they have a very big issue as far as the fly ash is concerned. Okay, so that is why some of this, the Jindal and other couple of companies, they have set up their own, okay, dedicated plants, the fly ash manufacturing aggregates plants with the fly ash which have come from their captive power plants. There's a huge amount of fly ash is available, and they have only supplied these aggregates to us. We started working on this. We started exploring how to use these lightweight aggregates, okay, in the development of structural lightweight aggregate concretes. This is what, and you all know this definitely, because of this urbanization and all, definitely the coal demand will drastically increase because of the increase in the power consumption, and definitely the coal demand is going to increase subsequently, and because of that, a lot of ash is also being generated actually. And this is what the sintering process they normally do with the lightweight aggregates. The fly ash which you get up, okay, it's being pelletized. You have a pelletizer, something like this, which is rotated at a particular angle, okay, and where you put the fly ash, okay, you put the 95% of the fly ash and 96%, 4% of bentonite for this binding property. You rotate this pan, pan, okay, and after this you'll get a small pellets, and these pellets will be placed on a sintering stand, which is for 1 hour. It is a temperature of around 1000 degrees centigrade, and after that you will get a sintered pellets. This is what the process. You're going to see that this is what the pelletizer at a particular angle, it rotates at a particular RPM at a particular angle, and it generates a small green pellets, and those pellets will be heated in a sintered stand. You can leave them as it is for 28 days also. We'll get a coal bonded aggregates. You call them as a coal bonded, and if you heat it at a temperature of 1000 degrees centigrade or 1100 degrees centigrade for 1 hour, we'll get the sintered aggregates. Okay. And the sintered aggregates, you see this is a sintering stand. All these pellets, green pellets, are moving on the sintering stand, and they get pelletized, and they become a hardened stone. And this is how these lightweight aggregates look like. They're very lightweight. The specific gravity, the ordinary aggregates, you have specific gravity of 2.7 to 2.8, and they have a specific gravity of around nearly 1.44 or 1.45, something like this. Okay, and because of that, the density of the concrete comes down, and the concrete becomes lightweight. And this is what definitely we have. If you look at, we have done some of the studies. If you look at, definitely they have a weight reducing loading because the density comes down. Okay, the concrete density comes down. What happens because of this? The load onto the elements comes down, and because finally the foundation load also comes down, and you can reduce the foundation cost. And because of this porous nature of these materials, it improves the thermal properties. It gives a very good insulating material, like, okay. And because of this porous nature also, it improves the fire resistance. And we have the results have been proven. It increases the durability as well. And of course, definitely the environmental benefits. That is what our focus is. Because if you look at the concrete volume, nearly 60%, 60 to 70% is being, nearly 60% is being occupied by these coarse aggregates. And if all these natural aggregates are being replaced by these sintered lightweight aggregates, which are made from this fly ash, okay, and what more you want, and what more, and why can't I say it's a sustainable concrete? Why can't you say what is the environment? See the amount of environmental benefit we're going to get. Okay, and definitely your concrete is a sustainable concrete, and this is what the comparison of some of the properties. You see the density is almost half of the natural aggregates what we use typically in regular applications, and the only disadvantage is it has got a very high absorption capacity because of the porous nature compared to the regular aggregates. That can be accounted for, and that has to be corrected when you're doing the next design. We already seen that they are all rounded in shape, and whereas here these are all crushed and angular in shape, and this is made from fly ash, and this is a natural or the quarried ash. And this is what the other advantage is, like what we have seen is the internal curing. Like we see this when you make the concrete, from next day onwards, you start curing the element. You start curing the element. And so just give me another 10 minutes, I'll finish it up. We start curing the elements. So what happens? But here with this, what happened now? Because of this high absorption capacity, these aggregates, they absorb this water inside. After the concrete becomes hardened, they start releasing this water inside. So even if you don't cure these elements as well, okay, if you don't cure these elements, there's no problem as such, because the internal hydration will be taken care of by this fly ash aggregate. That also a study has been undergone by us, and we have proved that the internal curing is there with these aggregates. Okay? And what is the basic purpose of chain? The basic purpose is to allow the hydration to take place. It's not by replenishing the external water, okay, by giving some curing and all. So we do have some difficulties initially when we start being a lightweight aggregates. Okay, the design has to be very specific. Okay, you have to do a lot of trials initially. Once you know where exactly the problem is, once you know the difficulty, it's quite easy. Actually, it's quite easy, and we have done that, and we started working on that. Okay, maybe because of that we have some difficulty in pumping, but that can also be overcome. Okay, by slightly doing some corrections in the moisture mix design, the overall mix design. So there's some of these mixes we have done. This is how the aggregates, when you cut an aggregate, looks like this. You see this outer surface has been sintered properly, sintered. Okay, you have a hard mass outside, and the internally you see this porous nature. The black color is because of this fly ash. And we have done some grading curves, developed some grading curves for these aggregates. Okay, and we have developed some various concretes, and you see this. We have done some various concretes at different water cement ratios, and this is what our design slum from 95 to 100 or something, 110. And you see the density. The densities vary from 2000 to 1900. Okay, and what is the density of a regular concrete is somewhere around 2400. That is what the base. Our aim is to develop a concrete, okay, which should have high strength to weight ratio. Okay, that is what our intention is. Though at a density of 2000, whether I'm getting my strength, the 30 or the 40 or the 50 megapascal, am I able to achieve the strength using this lightweight aggregates? Yes, that is what the overall, what do you call, that is what the overall intention is actually. Okay? And this is what we have developed as concretes. The proper mix design is absolutely necessary to develop these concretes. This is what high workable concretes. And we could able to achieve strengths of the order of nearly 60 to 70 megapascals using this lightweight aggregates. So this is what the spectrum of the strengths actually. What the spectrum of the strengths we achieve. And we have come up with their own water cement ratios curve for this aggregate. Somebody wants to design this, been already been published. Somebody wants to design this using 100% lightweight aggregates in place of the natural aggregates. Yes, we have at a 40-50. Yes, we have a water cement ratio. Okay. You develop this, and you can design the concretes. You can refer our papers as well. And this is how when you see the cut portion, like you see this, it looks like this. The way you see the aggregates at every stage, the aggregates has been cracked because of this less stiffness compared to the regular natural aggregates. The natural aggregates, when you will see the splitting, you'll see only when you develop a high strength concrete, the aggregates get split. When the normal regular aggregates, normal concretes, regular normal concretes, you never see anywhere the aggregate is being splitted actually. Because most of the time, water is when the crack is being bypassed with these aggregates. Okay, and most of the time you see only the water strength. Nowhere the aggregate strength is being reflected on the overall strength of the concrete. And this is what the difference. This is what a conventional concrete looks like, and this is what a lightweight aggregate with using the sintered fly ash aggregates looks like. And what are the some of these findings we have? Yes, there is a 400 kg reduction in the concrete density compared to the natural aggregates. This was the density difference we have seen, and we could able to develop a strength the order of nearly 80 MPa. We're using this lightweight aggregates and using some iron materials as well. Actually, it all depends on the project need. Actually, these are some of the findings we have. So there's no problem as such. We can develop a structural lightweight aggregate concrete for the structural applications. That is what our project intention is, and we have achieved all those objectives. And this is what sustainable concrete, and this is what you take a sample of this lightweight aggregate and you see in a scanning electron microscope, you see this porous nature of this aggregates, everywhere the porous nature. Because of this, it absorbs a lot of water. And also when I use this in the concrete, well, the interfacial transition zone, the zone between the concrete and the aggregates is being highly improved actually. That is about the lightweight. The third project which we have is the concrete without the cement. So the other thing is what I already told that in Orissa we have a lot of abundant amount of fly ash. The red mud is widely available. Okay, the huge amounts of, and we have a project like how we can develop a concrete which is cement free without any cement, how we can how I can effectively utilize fly ash and red mud in one go in developing a product. That's what we have seen. These are some of the problems, the red mud and all this. So we thought that why can't I have a technology like we all know this aware of the geopolymer technology. We have simultaneously utilized this red mud and the fly ash simultaneously with geopolymer technology, and we have developed a product which is a highly sustainable and environmental product. So geopolymer is what we need to work out the materials. So the geopolymer concrete is a cement-free concrete where in the place of cement we'll be using this base like fly ash or a slag or this red mud and all, okay, which are rich in silica and aluminum, and we need to have some activators like sodium hydroxide and sodium silicate, and we'll develop it develops a 3D structure, something like this. So basic difference, if you look at the regular ordinary Portland cement and the geopolymer concrete, the difference lies here. Whereas here you use the natural raw materials in the case of the cement, okay, whereas here you use only the industrial waste, okay, the fly ash now, which are basically rich in silica and aluminum. And here you have this, when it comes in contact with the water, the hydration reaction starts, and you have all this stuff, CSH and CH, and finally you'll get all the products, all the properties like the strength, the flexural strength, the elastic modulus, and the Poisson structure. Same was the case here, but instead of here, we won't be having a structure like this. We have a different structures, and finally you will come up with a. But ultimately, you will be getting the same strength, the same stiffness, this same Poisson's ratio, and the same intensity. And this is what we have seen in the labs and all. The geopolymer concrete for the ordinary Portland cement. This is what how we developed this with age. This you take a fly ash sample before activation, before the geopolymer activation, it's a spherical in shape. When it gets activized, it looks like this. This is what the geopolymer particle morphology looks like. And what we have done a project using simultaneously the fly ash and the red mud. Okay, we have used the ambient temperature geopolymerization, and finally we checked all the fresh properties, the mechanical and the durability properties. So why geopolymer concrete? Yes, we have proved. Not able to show all this. It's a less shrinkage, less permeability. Okay, it's more freeze thaw resistant. It's highly acid resistant. There's no calcium inside, calcium hydroxide. It's highly more safe in the fire. So a lot of advantages are there. Still, we're exploring a lot on this, and this is what we have done in the lab. And finally, the remarks are to have the sustainability. Yes, we need to judiciously use all these waste, okay, which can contribute significantly making a sustainable concrete. Okay, we take the economic impact, the environmental impact, and the social impact. All these things have to be accounted for when you are talking about the sustainability of the concrete. That is what I want to emphasize. And judiciously, you have to use these materials when the time has come to save the environment, okay, to save the natural resources. Okay, and the India is growing, is a developing country, and definitely there's a lot of impact. There's a lot of impact on the availability of these raw materials. Nowadays, we see these people started using this construction demolished space as well. Okay, construction demolished place. That was because of the scarcity of these raw materials. Scarcity of this, definitely there will be a lot of scarce these raw materials in the near futures. We need to account for, we need to work on all this so that we have a sustainability solution. So that's it for my answer. If you have any queries, I mean, you're welcome.
Sir, this is a very good presentation. We learned a lot. In Bhubaneswar, there is a CSR laboratory, and also there is one industry, Kalinga industry, and about 20 years back, the CSR laboratory had developed this the sintered fly ash aggregate, because I was a retired scientist from CBRI Roorkee, and and before that, I worked in DST, Department of Science and Technology, and there was a fly ash mission. And from fly ash mission, we have funded to that CSR laboratory. And I think they developed this aggregate. And winter, after my joining in CBRI, we tested the centered fly ash aggregate developed by that laboratory. Because after my joining in CBRI, so it has become a sister laboratory to the CSR. Then because what we found, the strength we could not achieve more than M20 because the aggregate itself is weak. But there are certain advantages with this aggregate because this aggregate itself is a pozzolanic nature. Since it is a pozzolanic nature, that interface between the aggregate and cement paste will be very strong. And also, as you said in your lecture, because since the aggregate is weak, it breaks across its body, and unlike the normal aggregate. And because you have shown in your presentation, you're getting up to 70 MPa, but one thing, sir, we could not get more than 20 MPa at that time. Maybe there may be some improvements. And one more thing, just our experience, while mixing the concrete with the center fly ash aggregate, since it is light in weight, specific is very low, and it floats on the surface of the concrete. Then that difficulty we used to get. This I want to share this my observations. Okay, thank you, sir.
Sir, you are that same Kameswara from CBRA?
Yes, I'm Kameswara.
Yeah, you B Kameswara. Yes, sir. You are my
Yes.
PhD examiner, sir.
Oh, sorry. Thank. Okay.
Ganesh
Yeah,
Babu.
because yeah, correct. Yeah, I think you did your MS under Ganesh Babu.
MS and PhD both.
MS and PhD from both. Okay, okay. Nice to hear from you. Actually, after direct from DST, I shifted myself to the CBRI. Then I worked in CBRI for 15 years, and so that. Then very nice to hear you. Thank you very much.
Thank you, sir. Thank you.
Sir, over to the chairman, sir.
Sir, very great of you, and having Thomas Ragar here also as the evaluator for the keynote addressing personality, and we highlighted a very great materials which are badly required for the society. It is a very great lecture, sir. We have learned a lot from your lecture.
Thank you, sir.
Is it good for the mass concrete levels or in the low level of low cost housing? How you define this?
Yes, that's a good question, sir. Actually, I have another project also from Orissa government. I showcase the same thing using these lightweight aggregates for a low cost housing. After these cyclones and all, they had some issues. So they funded one project on this affordable housing. So I presented the same thing to them. The only drawback, like Dr. Kameswara said that earlier, yes, we also felt like that. But now things have changed dramatically, sir, because lot of the new machine, I don't know, I don't know the reason why, like he's right in those days, but now commercially they are producing these in a very big way. This Jindal and one Infra company, two big companies, big industrialists, they are developing their own. The sad part is there are no takers in India from the government side or from anybody because there's a lack of model provisions. This is one drawback. But they're minting money, sir. They're exporting these materials to Middle East and all in the ships and all. They're making huge amount of money because in Indonesia and all, the scarcity of raw materials, they're developing like anything. They're making money, both the companies. The sad part is only some of the private players, because of my presentations here and there, they started taking these aggregates and utilizing some Birla companies and all, but government clients, zero. Government, though I show the IS-456, you can use this as a lightweight concrete and all if the aggregates are not available, but still they're not coming forward to use this in the regular structural application.
They will come, sir.
Yeah.
Thank you. Thank you for your good lecture.
Thank you, sir.
Okay. Sevkeshwar Garu, we'll go with the paper.
We will go with presentation, sir. Paper ID number 63 is ready, sir.
Only one paper, 61 is completed.
Yes, sir. One paper is completed.
Yeah. So you can switch over to the next paper. You can invite the next paper.
Okay, sir. So paper ID number 228. J. Srinivas. Please raise your hand. Yes, Srinivas, sir. You can share your screen now.
My voice audible, sir?
Yes, Srinivas, audible.
Sir.
Yes, Srinivas, please share your screen.
Is it visible, sir?
Yes, yes.
Visible.
Good afternoon to one and all. Myself, Jay Sai Srinivas. I am a PG student from KL University.
Srinivas, excuse me, please go to presenter mode.
Yes, sir. Sir. Full presentation. Sir, can I present now, sir?
Please go ahead.
Yeah.
Good afternoon to one and all. Myself, Jay Sai Srinivas. I'm a PG student from KL University Civil Department. Today, I want to discuss about a study on analytical and experimental analysis of the structural members. This paper was under the guidance of Dr. Mr. J. D. Chaitanya Kumar, sir. And brief introduction about the analysis. Why we should do analysis of a material before using it for any type of construction, or it may be in any stream, mechanical or electrical, it may be. Analysis should be done, it's a necessary process. Why? Because analysis is useful to understand and use a brief study of the behavior of the material under critical loading conditions or different boundary conditions. So this process is used to estimate the characteristics of material which we are going to use under different construction processes. Now, based on the method, based on the different type of usages, we have to divide analysis into different types. There may be static analysis, dynamic analysis. Static analysis based on the loading conditions. Dynamic also behavior of the based on the time of loading conditions. In construction industries, we use analysis before the construction process and after the construction process. Before construction process, it is used to design better model and understanding the critical parameters like deformation, strength, and flexure of the different components of the structure. When coming to the post-construction process, it is used to identify the damaged materials and its damage propagation and health monitoring. It is used to develop a health monitoring model, etc. By considering both pre-analysis and post-analysis, we can develop a life model of a structure, which is nowadays it is having a great prominence in the industrial construction industries. So in order to do analysis, we have different type of methods like experimental, analytical, and other numerical methods also. Why we should do an experimental analysis on this type of analysis? Experimental procedures we can use, but it can be only to some extent only, because when the complexity in the structure increases, the experimental procedures cannot keep up with the results. We have to develop some different type of specialized equipments and specialized conditions we require, like temperature also have an effect. So in order to do such in physical manner, it requires a lot of materials for testing process only. It requires a lot of materials, and skilled labor is required, and also a specialized facility is required for this type of analysis. So this demands the urge of developing of a analytical methods. So we have already should have a brief introduction why analysis and why it is important. Now we can have a small review on that, why improper analysis leads to the failure. So I have a small example. This is a hotel New World Singapore. This building consisting of a 3 floors of a hotel with so many guests, and a commercial bank in the first floor and underground nightclub. What happened? This has been failed because of the simple underestimation of the self-weight of the structure. While calculating an analysis, the engineers have underestimated the self-weight of the structure. This leads to the collapse or overstraining of the supporting columns, and these supporting columns started to fail. It has developed a progressive collapse and leads to the complete destruction of the building. So, analysis methods is based on the effect of loads and physical phenomena on the components or any structural members. Based on my research or literature review, I have characterized this analysis into two methods or two cases. First case deals with the analysis of normal sections and special concrete section and different loading conditions, and analysis of dynamic characters of materials and damaged sections. In these both cases, both experimental and the analytical analysis are done, and the results are compared for the reliability of the analytical methods. Some of the observations of the case one. So the materials used in the case ones are reinforced concrete sections, normal reinforced concrete sections, and special concretes like use of GGBS concrete and high strength concrete are used. These are analyzed for the load deflections, which are and different variation methods also. Plain concrete, plain under and balanced reinforced sections also. And the loading, when coming to the loading cases, the loading may be linear and non-linear also they have used. The main computational software used in the analysis process are ANSYS and Icace. These are the literature reviews. With these basis, I have considered those observations. So first one is study on finite element analysis of reinforced concrete beams with the GGBS using ANSYS. In this one, they have developed a specified dimension concrete beam. They have casted in a real time or physical tests are done on the real beam, and the characteristics are completely noted, and the results are noted. Same beam used are developed or modeled in the ANSYS software also, by using some of the characteristics obtained from the physical experiments in order to get the reliability. So these beams are developed and modeled and used for the and also analyzed for the loads, different type of loads, and the deflection has been developed. These are the graphs obtained from those two experimental and analytical values of the GGBS concrete sections, and compare that. They have done for different percentages of the GGBS. I have because of the constraint, I have shown only 40% replacement. How the results have varied. There is a marginal or somewhat different errors in the both cases. In the same way, analysis of RCC beam using Icace. The procedure is same, but in this case, they have developed a plain under reinforced and balanced sections for testing. In the other case, a high strength concrete was developed, because high strength concrete is now used in the various elite programs and like metros. They are using the high strength concrete. Normal concrete has been not used for because of the different durability conditions. This second graph shows the Icace results and the for load and deflection responses for high strength concrete. In this case, they have not developed, they have not introduced any new materials like GGBS or something, but the case is they have used cyclic loadings. And in the case of cyclic loadings, we had shown that a particular behavior means it has a series of increasing loading, the craft and deflections are different. When suddenly the loading has been decreased, the error percentage has been increased. This is the conclusion they have made by using this experiment. When compared to the second case, they have used dynamic analysis and the different vibrational characteristics for analysis. Some of the materials used in this case too are steel, brass, copper, aluminum materials, and other damaged sections like cracked sections developed and analyzed in this type of case. But in this case, the vibrational characteristics requires more number of complex terminologies like functions. It requires stiffness factors, something which has been complex when compared when they are deals with the physical experimentation. It requires many physical equipments like impact hammer method for vibrations and some specialized analyzers and some techniques like fast Fourier transformations required to completely analyze in a physical format. So in order to reduce that, we use some numerical methods and computational packages for the analysis purpose. For complex computational like numerical methods, we use MATLAB programming as a software. These are some of the literature reviews based on the vibrational and dynamic characteristics of different materials and damaged sections. But in these three papers, they have mainly concentration. Most of the research is based on the cracked sections. Why means nowadays, as I have earlier explained, health monitoring and development of the service life model has been becoming a prominent thing in the construction industries. So how this crack is behaving under different loading conditions has been significant nowadays. So mainly presence of crack in concrete leads to the reducing the stiffness and other dynamic model properties. This reduces the behavior of the structure. So in order to detect and model the cracks, they have developed a few models such as so they are used for crack detection. They have used different methods like natural frequency methods. Nowadays, artificial neural network methods and genetic algorithms have been playing prominent role in this type of analysis. These are the results obtained from the different dynamic analysis of the cracked beam and the materials. The response of the cantilever cracked beam for various crack positions and depth are shown in this type of graph. And second one is a response of cracked beam for natural frequencies has been shown in the model. From the above review, I have conclusions that most of the analytical and experimental have the good agreement, but there always been some error percentage. The error percentage is based on the loading conditions, maybe boundary conditions. But as I noticed that there have been variations in the percentage with increase in the GDPS content and some other different loading conditions. So how the concrete is reacting to the same conditions? We need to. This is a future study, the micro analysis of the parameters, which helps to develop the analytical model. This is one of the future study. In it, we can conclude from these conclusions. And coming to the step 2, for vibrational and dynamic analysis, the case 1 results are coming as a benchmarks. So this is another reason why we need less percentage in case 1. I have a small example, like when you propagate a news by mouth in a series of people, there will be a percentage error when coming to the last person. The last person will get a message completely with a different context. Same way this is happening. When our basic values are having error, the final analysis will become more error when compared to the other things. And other parameters obtained from external data are used for modeling sections in computer softwares like ANSYS and Icace. These are some of the literature reviews from which I have studied this and concluded. Thank you. Any questions? Sir?
So,
Right, very good presentation.
Thank you, sir.
Srinivas. Yeah, it's a beautiful presentation, man. I'd like to ask some question here. You have compared the analytical and experimental results of various structural members, RC structural members.
Yes, sir.
Now, what type of all RC structural members have you compared in your investigation, like starting from the foundation to the
No,
slab,
sir.
or
They,
only few
no,
components?
no, sir. Most of the literature review, they have selected a single section, sir, as a beam only, beam or column, with that boundary conditions only, sir. They have never considered the foundation components, sir. And also, they have not done an analysis for most analysis for the frame structures also, sir. They have experiments are done, but they have in less compared to the normal RCC.
Of course, now from whatever the literature survey you made, from that literature survey only you have studied all.
Yes, sir.
So there the analytical and experimentals are in good agreement, you said, in the first, as the first conclusion.
Yes, sir. Yes, sir.
All the best.
One more question. What is the effect of D dash by D when you select only a slim member like 1200 by 200 by 100 mm versus the regular members how we have in the buildings?
I can't get the question, sir. Please, sir, can I?
Right.
Sir?
Very small member has been identified as 100 mm as only the depth.
Yes, sir.
In all the papers, whoever may be the doing the experiments.
Yes, sir.
And as a layman, I don't know what is the exact design. What do you mean by D dash by D in this case?
D dash by D means they have constraints
The effect
that
of that
crack.
in terms of design.
Sir?
The effective depth versus the total depth of a beam, when you consider it as a very less 100 mm beam, it gives a different ratio than the regular member, maybe some 450 mm by 230 mm.
Yes, sir.
So, how you can say anything about the analysis?
Sir, I will
When you
look
are
into
considering
it,
a very
sir.
small member and designing for a sustainable building dimensions.
Sir, thank you, sir. I will look into it, sir. I have not gone to that point, but I will look into it, sir. Thank you, sir. I consider that.
Good. Okay, take care. But it is required. No, it is to be understood.
Yes.
You should
Yes, sir.
when you are using the softwares and doing the things, you can be in a real dimension, not in a
Okay, sir.
smaller dimension like 100 mm.
Sir, I will note that point, sir, after analyzing.
Good. Take care.
Thank you, sir.
Any questions from participants? If you have any questions, please raise your hand so that I can unmute you. Okay. Shweta, are you ready? I'm making presenter.
So is that visible? So?
Please share your screen.
Yes, sir.
Your paper ID 178, right?
Yes, sir.
Sir, our paper ID is 178, sir, last number.
Okay. She can share the screen and she can proceed.
Shweta, please share your screen.
Sir, is that visible?
Yes.
Yes, sir. Good evening, one and all. This is Shweta K from Tyagaraja College of Engineering. I'm pursuing my ME Infrastructure Engineering and Management, and my topic is experimental study of source localization in acoustic emission using triangulation technique. And basically, acoustic emission is an elastic wave that arises rapid release of energy from localizing sources within the material, some common source of AE in engineering material, and initiation and growing of the cracks and failure of bond. A form of stress waves are generated when accumulated elastic energy from the sample are released. This technique involved in recording the waves produced in the structure by means of sensor placed in the surface and analyzes the signal to extract the information about the source. Predominantly, the frequency range is limited to 30 kilohertz to 300 megahertz in acoustic emission. And this is a diagram about like what the process is all about. And the procedure, as I said, the procedure is like external load is applied over the sample and a disturbance is made where the acoustic emission generates, and the acoustic emission is collected through the transducer, and the inputs are sent to the amplifier as the energy comes out as in a low range, so it can be increased by this amplifier and then sent to the measurement system, and the localization can be detected. And this is a pictorial representation of what I have mentioned in the procedure. And what is the innovation and the technique which I have used in this is actually basically the acoustic waves are made with time of arrival method, which is actually a traditional one, and then the triangulation method comes into the source, and they use this triangulation method to localize the source where the defect is. And uh, from the traditional method, I have just renovated to parameter based approach and the waveform approach, so that the result of the output will be like in a better way. And after like determining the parameters result, the energy is calculated by using the trapezoidal rule and Hilbert transform to localize the source area or the defect area, so called. And uh, I have also generated them using MATLAB. So it will be like it will be like a large number of data will be like generated. So it can't be made manually. By using MATLAB, I have just generated the result. And the main part is like I have used 2D techniques so that we can like minimize the usage of sensors like nowadays, because sensors are much way expensive. So making it economical, I have just made in 2D technique. And this is the block which I have taken for a sample, which is the length of 112 centimeter, and the depth is 31 and the breadth is 30.5 centimeters. And the right side I have denoted the picture of the wave, like the duration is like how many counts it have, and the arise time is like the largest, I mean, or the tallest wave which is generated, and the amplitude is the highest point of frequency, and the count is like how many waves, I mean a rise of waves which comes beyond the threshold point is denoted as the counts. And the time is like overall how much time or the duration it takes for the wave to propagate. And the observation part is like this is done manually. Basically that in each sensors we will be like getting the arrival time, like how what are the time received by the sensors. I have like denoted three sensors like 15, 16 and 17, and in that we just got an output of 10 data of arrival time. And the threshold is like basically what are the capacity of the sensors to be like it can be recorded. Like I have taken the sensor of which can capture about 30 decibels. So converting decibels to the threshold value, it comes as 4.48 into the power of 6 of volt. And the hits I have mentioned before, like how many waves like which come beyond threshold, and the amplitude and the rise time duration. The energy I have like used calculated them in MATLAB, and the average I have taken and the counts apart. Why I have like highlighted the 16 is that it can be like easily viewed. The amplitude of the 16 sensor is much way higher than 15 and 17, which denote that the source is like nearby located to that 16 sensor. So that I have just highlighted. This observation part is just to denote like where the sensor is like it won't give the correct point or the exact location where this source is, but we can just assume or we can come to a conclusion that it will be like 16 near the 16 sensor and so on. And these are the calculation part. It's actually the triangulation method which I have used. Actually we have taken these coordinates and the data from a journal where that author used 3D localization and came to a result. And we have like transform them to a 2D localization so that we can reduce the sensor, which I have mentioned in my innovation part. And there are 3 sensors, as I have mentioned before. And taking the distances and the formulas of triangulation method, we just came to a conclusion that the source is localized between like 61 centimeter from the x-axis and 18 centimeter from the y-axis. We can conclude that this is the exact point where the sources have been cracked, and this is a pictorial representation where my calculation denotes. And the result, actually this expected result is like I have taken from the journal which I have referred. They have done with a new technique called as like short-term frequency test and triangulation method and MATLAB. But the calculated value which I have generated is with the innovation which what I have gone through, as I said, like triangulation technique and that so on. So when we are looking at the results which I have found and the result which the journal have given, there's a minute change, but that doesn't matter. But when you're taking an economical way, it will be like much more efficient than the 3D localization. So this can be used. And the conclusion part, like the acoustic emission have proved that the damage sources can be detected with the 2 sensors also. And this is a budding technique where the non like everyone knows that non-tested test is like a budding technique in our stream. So this can be like adapted in various forms. And even tall buildings can be like used acoustic emission for frequently monitoring the structure, health monitoring of the structure. So I have chosen this topic for. And the applications, like it has various applications in every sector, even in civil engineering and in aerospace engineering. In civil engineering, it's like common, we all know that it's used for detecting the crack or the breathing cracks which have been ongoing to the structures. And it can warn us from upcoming dangers or any destruction of the structures gonna happen. And in aerospace engineering, if we take, we can find the ductility and so on, or the strength of the wing, or and many such uses can be done in aerospace too. And the future scope is like the main concept. What I have done in the research is to minimal the economical price, or to bring that project into economical way. So I have like done in 2D. If you want, you can just proceed in 3D for a better outcome. And when you are going for a 3D, it should be like FEM method can be like done, so that the point will be like in accurate manner we can just determine where the source are located. And the bibliographies are like, well, what are the journals I have referred for the project to go on. Thank you, sir. Sir? Sir, am I audible?
To understand about the acoustics,
Yes, sir.
what are the parameters that we can understand for your classroom otherwise?
Sorry, sir?
To understand the parameters of acoustics in terms of decibels,
Yes, sir.
what is the acoustics requirement of your classroom?
My classroom.
Yeah,
So
for a classroom, for a meeting hall, for a association hall, what do you recommend?
so the thing is like what I have done, the decibels, the sensor you're asking for, sir. Like what type of sensor you are supposed to do for when you take measuring for your class? That's what you're asking for.
No. What is the ultimate result? After measuring, so what type of measurement that you require?
After making what is the use of converting that into decibel you're asking for?
Yes. In terms
So
of
like,
decibel.
yes, sir. Like if you convert them into decibel, like there will be a unwanted noise will be generated, sir. When we take the waveform. So to avoid the unwanted thing, I have just converted them to decibels. So the sensor which I used is 30 decibel. So within 30 decibel, it will be like neglecting all the waves which propagate through them. So above 30 will be recorded in the sensor. So
If I want to ask you one question,
yes, sir.
we have constructed the state assembly in AP Secretariat buildings
Okay, sir.
after bifurcation. somebody told that whether this is a comfortable place for the MLAs to sit and speak, or some measurements have to be taken. So
Yes,
what do
sir.
you suggest there?
Yes, sir. Like it will be like based upon the size of the structure or what the concrete is about, and it can be like varied from the sensors to sensor depending upon the structure. So like it's for in my project I have just taken a concrete block, so for that it's okay with 30 decibels. So if you want to do with a bigger structure, you will be like getting a higher value of sensors based upon the structure. So it's what given in the journal, what I referred for.
What type of requirements, instrumental requirements
Sir,
are there?
yes, sir.
What is the instrumental requirement?
Sorry, sir.
What type of instrument you suggest to make a experiment in assembly, otherwise in our state?
Yes, sir. Like basically for a mega project like hall or assembly basically in auditorium, right, sir? So like about 40
Yes.
decibel will be the maximum kind of decibel. I think so for a bigger structure, because they have denoted for a marriage hall it will be like about 40 or somewhat. So I hope it will be like around 35 to 40, hopefully, sir. So when we take for a classroom, it will be like a minimal size, so that won't be a bigger issue.
Okay, okay. Right, right. All the best.
Thank you, sir.
Yeah, Sweta,
Yes, sir.
question from my end. Suppose you
Yes, sir.
have a conference hall. So
Yes,
in
sir.
order to improve the acoustics nature for the particular conference hall,
Yes, sir.
what precautions you can take to improve the acoustic performance of the particular existing conference hall?
Existing, like to improve. Sorry, sir, I can't get your point.
Already, maybe there is a building, maybe conference hall, you have just like that build without considering the acoustics in consideration.
Okay, so the arrangements of seat can be made, or uh, there are like lot of sheets are available, no, sir, like to reduce the outgoing noise from the structure, and a foam can be used, like foaming seals are like upgrading nowadays, so that can be done, or floor mats can be also implemented, so that this voice can be like can be minimized, so that can be made, I hope so, sir.
Okay, then how
Like,
it is guaranteed the acoustic is performed well? Is there how to measure it actually?
sir, that's what I have like, no, sir. The acoustic, the emission is like based upon the load which I have induced. So, if a source is present in a structure, it reflects and comes out. So that reflection of waves are captured by the sensors and then transfer the amplifier.
Okay.
Yes, sir.
So, do you have any equipment like to measure the performance of acoustic of a particular building?
Sorry, sir.
How to measure actually? So, whether the particular hall which is given to you is
Yes, sir.
having
Yes, sir.
poor acoustics, how to identify?
So I think there'll be like a sound level meter, or a kind of a measurement is made. So basically, so based upon the echo also will be like denoted over in this matter. So while doing the construction, they will be like gathering all these points, and then they will be like based upon it.
Okay.
हैंड रेस कर हैंड रेस
Okay, Ma Sweta, all the best. Meet you
हैंड रेस
again.
करेंगे
Thank you, sir.
तभी लेंगे वो
Next
Sir,
paper
yes,
ID.
sir.
Yes, yes, yes. Please,
Yeah,
please.
you asked for the instrument, no, sir, that what they will be like using for
कौन
measure.
टेंशन
They
लेना
will be, I think they will be inbuilding some like noise level meter. I'm not sure about the instrument, but I think it will be like a noise level meter, or indication meter, where if the sound is like arises or falls down, it will be like indicated what's the current acoustic range of the building is present. So depending upon that, we can just choose the sensors what can be done for the structural health monitoring and so on. So because it can vary from one building to another, so based upon the structure, we can inbuild the sensors like what we used over it. Yes, sir.
Okay, good. Good luck.
Thank you, sir.
Dear all participants, there is an announcement. Please don't leave the meeting. At the end of the meeting, you need to fill the feedback form. So please be in the meeting only. Paper ID number 172.
Yes, sir. Yes, sir. I am here.
Okay. Please share your screen.
Yes, you can proceed.
Okay, sir. Okay, sir. Just a second. Hello, sir. Hello, sir. Good, good,
Yeah,
good.
your sharing is
Good of you,
seen
sir.
on the screen. Yes. Please continue, sir.
Okay, sir. Okay, sir. My name is Saurabh Subhash Hirat, and I am to GH Raisoni College of Engineering, and my my title is Wind Analysis of a Multi-Story Structure. Introduction. In simple words, the building means an empty structure surrounding by walls and roof in order to give shelter for human beings. Buildings are the necessary indicators of social progress of the country, so that the buildings are built economically and quickly to fulfill the needs of the people. A building frame is a three-dimensional structure which consists of a column, beam, and slab. Because of growing population, high-rise building coming into demand. The building should be constructed for human requirements and not for earning money. Buildings are built in different sizes, shapes, and functions. All over the world, there is high demand for construction of tall building due to increasing urbanization and the spiral population, and wind loads have the potential for causing the greatest damage to the structures. Since wind forces are random in nature, the engineering tools need to be sharp for analyzing structure under the action of three forces. It is a it is a key requirement to survive anywhere. For the reason, multi-story buildings are best choice for the construction in metro cities, whereas a smaller amount of property is present. Methodology: create the grid and creation of the structure in tabs. All the properties, assigning of all the properties, assigning of the supports, defining of the load, assigning of the dead load, live load, and the wind load. Wind loads are defined as IS 875 Part 3 based on intensity calculated and exposure factor. Then the loads are added in the cases details, that is plus x, yx, plus x, plus y, minus y direction. Assigning of the load combination, analysis and design. Types of load I have used in my design. The loads which are considered for analysis are dead load, live load, and wind load. IS code in my design are IS 456-2000, design of ICC structural element, IS 875 part 1 for dead load, IS 875 part 2 for live load, and IS 875 part 3 for wind load. Load combinations for the different combination used in my projects are 1 plus 5 into dead load plus live load. These are the load combinations I have taken in consultation in ETAP software only. Required required data taken. G plus 13 commercial building for modeling. Area equals to 38 meter into 29 meter. Story height, typical story height. One story height is 3 meter, and base to floor story height is 3.5 meter. Number of stories is equal to 13. Beam size is 300 into 500 mm, and column size is 450 into 500 mm. I am taking M30 grade concrete and as well as M25 grade concrete and Fe415 and Fe500 steel. Live load of 3.5 kilonewton per meter square from IS 875 Part 2 1987, and dead load is the self weight of the building itself. This is the manual calculation, sir. So I am designing my building in Nagpur. That's why I am taking basic wind speed VB is equal to 44 meter per second. Wind basic so therefore, sir, design wind speed is equal to VB into K1 into K3. VZ is equal to design wind speed at any height. K1 is the probability risk factor. K2 is the category, and K3 is equal to topography. Design wind pressure PZ is equal to 0.6 into VZ square. So these are the formulas for calculating the wind pressure, force acting on the building, wind load on individual factor, and the fifth one is force acting on the whole structure. F is equal to CF into AE into PZ. So and there is one keynote, sir. The wind speed will be taken as constant up to the height of 10 meter. However, pressure for building less than 10 meter may have been reduced by 20% for the stability and design of the framing, sir. This is my model, sir. This is the partition grid from plan from 6 to plan from base to 6, sir, and plan from 6 to 13 is my cylindrical grid, sir. And this is my 3D model, sir. And these are the figure when wind load acting in plus x direction for a regular building, and here is the deflection of the regular building, and it is the elevation, sir. Graphs, graphs, story displacement, story drift, lateral loads on stories, sir. These are the results and discussions, sir. Maximum story displacement in x direction of the whole model, sir. In the x-axis there are number of stories, and in the y-axis there are displacement in mm. So, sir, as we go up, sir, the story displacement is maximum, and here is the and here in the displacement maximum story displacement in y direction of the model, sir. There is there is there is some fluctuation in 6 to 7 or 5 to 7 story number, sir. And and here is, sir, when I am applied my wind forces, only the wind forces in the direction. So here are some different results, sir. When I am applying my wind, then my displacement is my story displacement is maximum from 0 to 70 mm maximum. This is my x direction, and this is the y direction at which the story displacement is about 90 mm. This is the and sir, this is the maximum story drift in x direction. Uh, from story 1 to 8, it is rising, but from 9 to 13, it's been decreasing in x direction, and and as similar to y direction, as similar to y direction, maximum story deflection in y direction, sir. and and these are the lateral loads to the stories, sir. Auto lateral loads to the stories in x direction. So there are in 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 the story 1 to 4, there is no there is no there is no lateral loads because of I am taking the wind from 4 to 13 floor because of the, sir, because of the node, the 10-meter height. I am taking the load from 4 to 13, and it is the maximum story for the story number 4, 5, and 6. These are the values are tabulated as follow: height in meters 10, 15, 20, 25, 30, and 40. This is the value for K2. I have taken 0.91 to 1.40, and this is the VZ 52.9, 92, 61.1, and PD is equal to 1680.32 to 2498.01, and this is the PI in X direction and in Y direction, sir. And sir, Niket, and these are the conclusion. The wind loads increments with height of structure. Proposed structure of the elements can be used in the structure. It has graphically input generation facility allowed generation of structural models graphically. All other specification like section properties, material constant, support loads, analysis, and design requirement, printing, plotting facilities are available. Hence, I conclude that we can more knowledge in practical work when compared to the theoretical work. Is fast and accurate software design. It's also provide economical design of the structure. Wind loads are more basic for tall structure than the seismic loads, and structure thought to be designed for loads got in the two direction individually for more accurate and critical wind forces. These are my references, sir. Thank you. So,
Yes, your presentation is good.
yes, sir. Thank
What
you,
is
sir.
your what is your comparison of height versus the what is called the seismic load and the wind load combinations or the differences?
My sir topic is on only sir nika wind load, wind analysis of a multi-story structure. But when I compared to others, when I'm compared to the other projects, as well as my conclusion number said, as well as my conclusion number says, कि wind loads are more basic for tall structures than the seismic loads.
To which height? To which floors?
Maximum from sir above sir nika 10-meter height, above 10-meter height. As we go up, the nika wind pressure will act. As we go up, the wind pressure will act about 10-meter.
Nice, nice. Okay.
Yes, sir. Yes, sir. Yes, sir.
Mr. Shaurabh.
Ha, sir.
So you have done the
Yes, sir.
analysis with 13-storied building,
Yes.
right?
Ha, sir.
So
Ha, sir. Yes, sir.
wind loads are always considered as lateral loads only.
Ha, sir. Ha, sir.
Here
Yes, sir.
you have
These
taken
are the
more
slide.
load as a lateral load from story number 4 to story number 6. Similarly, from story
Yes,
1 to
sir.
story 3, load is 0 you have shown. That is good.
No,
But
sir. No, sir. No, sir.
beyond
There is load, but
seventh story to
there is
third
a load.
story, you have used very less load. What is the reason here? Why the load is decreased towards the top of the building?
Sir, when I am taking the results, I am calculating from 13. Sir, my story height is of 3. So because from 0, 1, 2, 3, there is a total height of 9.5 meter only. That's why I am taking wind load from story number 4 to 13. And in 4, 5, 6, the lateral loads of the stories is maximum because of the shape, sir. Because of the shape,
Usually,
sir.
whenever you do the analysis of any multi-story building by using ETABS, by using any other software, the
Yes, sir.
wind load will be always increased with respect to the height of the building. That was given as a conclusion number 1 in your presentation. What is the
Yes, sir.
conclusion
Yes, sir.
number 1 here? Load is increased, wind load is increased towards the top. But now here
Yes, sir.
the load
Yes,
is
sir.
getting decreased towards the top. It's not at all matching your bar chart as well as your conclusion number 1. They are not at all matching in the presentation.
No, sir. No, sir. No, sir. These are the results. Displacement results, sir.
Go
Maximum
to
results.
conclusion number 1. Go to the conclusion slide, please.
Yes, sir. Conclusion, sir.
Read the first conclusion.
The wind load increments with the height of the structure, sir. Yes, sir.
What is the meaning here?
Yes, sir. Yes, sir. Correct, sir.
If it increases, wind load has to be increased.
Yes, yes, sir. Yes, sir.
And then what? In your case, you have considered very big. Generally, up to G+2, you don't have the effect of wind load. That is sure because of
Yes, sir.
the effect of surroundings. But beyond
Yes, sir. Yes, sir.
G+2, you need to consider, but that wind load intensity will be increased towards the top, or at the most
Okay,
constant.
sir.
It will never be
Yes, sir.
decreased.
Yes, sir. Yes, sir. Yes, sir.
So you have used the ETAP software here for the analysis of the building.
Yes, sir. Yes, sir.
Considering only wind load, you
Yes, sir. Yes,
have
sir.
you combined the wind
Only
and
wind load.
vertical loads like
Yes, sir.
live loads? Have you combined
Yes,
direct
sir.
load
Yes, sir.
and wind,
Yes, sir.
lateral loads?
Yes, sir.
Can you show me any
Live load, date load, and wind load, sir.
any screen related to ETABS here? Maybe analysis results of through ETABS.
No,
Do you
sir.
have any slide here that you have
In
used
this,
the
sir,
ETABS?
ETABS is not involved.
Nothing is there.
Yes, sir. Yes, sir. I will share you. I will share my results with you, sir, by email, sir.
Okay.
I will email you, sir. Yes, sir.
Yeah, no problem. Yeah, sure.
Yes, sir. Okay.
Yeah. Good. All the best.
Okay, sir. Thank you.
Yes, sir. Renu, are you ready? Renu, Sarah, I'm making you the presenter. Please share your screen.
Hello, sir.
Yes.
Am I
Yes,
audible?
yes, you are audible. Please share your screen.
Okay, sir.
What is your paper ID?
63.
Oh, okay.
You can present your paper.
Okay, sir.
हेलो हाँ
Sir, is it visible?
यही तो होता है भाई, अगर तू ज्यादा कंटेंट डालेगा
Hello,
Yes,
sir.
yes, you can go ahead.
Okay, sir.
तू
Thank you.
ज्यादा कंटेंट अगर डालेगा तो क्वेश्चन ज्यादा ही
Hello.
आएंगे।
Good evening, all.
Yes,
My
yes, you are
topic
audible.
is a video on design and optimization of functionally graded lattice structure. Me, Renu Saracharian, PG student from Amaljodi College of Engineering, Kanirpalli, Kerala. And my guide is Jins P. Sakaria, Assistant Professor, Amaljodi College of Engineering, Kerala. These are the content dealing with.
I will send you my
Mainly,
result by email,
optimization means maximizing or minimizing some function
अरे
related to
इसने
some
किया ही
set of
क्या, पूरा
conditions.
पढ़ के बताया ना।
Related to design process,
और इसमें पूरी
optimization
क्वालिटी
means
पूरी
to
डिश
achieve
चिपकाई
the
है
best
पूरी।
design related
फर्स्ट
to
की
a
स्लाइड
set
है
of
भाई,
criteria or
8 स्लाइड
constraints.
नहीं थी।
Coming to the structural
Excuse
optimization.
me, Renu, sorry for interruption. So there is a disturbance from your side. Please ensure that.
Sir, someone is unmuted.
Hello.
I think.
No, from your side.
आ गए तीनों कॉन्फ्रेंस में।
Hello, sir.
हाँ।
Yes,
Not from me, sir.
from your side
Someone.
only. From your side only some disturbance is coming. Just see. Please ensure that.
एक सेकंड सौरभ, तेरा माइक ऑफ है कि ऑन है?
Am I audible now, sir?
Yes, perfectly. Go ahead.
Okay, sir. Coming to structural optimization, it is a technique for finding the optimum number, position, and shape of openings subjected to a set of loads and boundary conditions within a given continuum. Mainly, there are three types of structural optimization: shape, size, and topology optimization. In shape optimization, there is only finding the optimum position of the member of the structure. In size optimization, it is only finding the optimum size of members. In topology optimization, it is the most effective method to obtain lightweight structures with optimal performance by distributing the amount of given material in the design domain, and it was first introduced by Bensu and Kikuchi in 1988. We can see a topology optimization application in the figure, that is a Qatar in conventional center. We are dealing with optimization of functionally graded lattice structure. Lattice structures, as we all know, these are made up of simply cubic unit cells like face-centered cubic unit cell, body-centered cubic unit cell, etc. are shown in the figure. Lattice structures are of various types. Uniform lattice structure. Here I am dealing with functionally graded lattice structure, in which the density of solid material changes gradually over the volume. It can be shown in the figure, and also its application can be seen in the functionally graded mesostructure of bamboo, as depicted here. Next, mainly, we can look into what is topology optimization problem. Mainly, optimization model consists of an objective function and set of constraints expressed in the form of a system of equations. Mainly, topology optimization contains an objective equation that is minimum of F raised to TU, where F raised to TU is the compliance or strain energy, that is minimizing the compliance is objective equation, that is to maximize the stiffness of the structure. Subjected to a static equation of elasticity, Ku is equal to F. And also, the topology flow or topology design contains various steps. It can be seen in the figure. First, for example, considering a simply supported beam with a center point load, we are initializing the structure, and the goal is to reduce the beam weight with a volume constraint, compliance or a strain energy as the objective function, and that will change during the optimization process. And the variable that is the design variable will be the density of material. After initializing the structure, finite element analysis is done by dividing the structure into a number of finite elements, and the density of 1 will represent the solid and density of 0 will be void. That can be seen as the white and dark color. And the density will be applied to Young's modulus in finite element analysis, and the strength of the structure is calculated. Then sensitivity analysis is done since every point in a structure is not at all important in the design problem. Therefore, sensitivity analysis is performed to check the how sensitive is the objective function regarding the change of density of particular point. Next is task of optimization, which is executed iteratively every time and checks the design variable is providing minimum compliance or maximum stiffness and update the design variables, and is repeated until the optimum value is reached for minimum compliance, and the results are plotted and steps will end. This is the basic steps in a topology optimization problem. Let's understood topology optimization method, that is SIMB method, solid isotropic material with penalization. It is used for functionally graded lattice structure topology optimization. In SIMB method, they are choosing the relation between relative element density and element Young's modulus and connected with the equation as shown here. And the density is penalized to a power, that is penalization power, in order to get the solid and void solution. And the SIM technique is based on determining the optimum structure by varying the material density within the defined domain. The major steps involved in SIM method of topology optimization are dividing the structure into finite elements for the FEM procedure, and the number of elements, type of elements are all specified. The material properties are specified, that is Young's modulus, and from that the element K metric is calculated using the SIM equation already told, and load's boundary condition are all specified. The displacement is calculated using Ku is equal to F. The structure, which is to be optimized for the principle of minimum compliance, that is objective function of topology optimization, which is iterated in an optimization loop, which calculates the compliance and check if it is minimum, and display figure is got. Here, the overall steps already told is shown in the figure. We are initializing, example, we are initializing a cantilever beam and optimizing with respect to the above steps. We get the figures likely after minimizing the compliance or increasing the stiffness of the structure. Major overview of the study includes to understand the topology optimization for functionally graded lattice structure and apply it for unit cell design and manufacture of functionally graded lattice structure. And the review paper focuses on the design and optimization of functionally graded lattice structure. Majority of works, literature works are programmed on MATLAB code and tested the feasibility of the design structure in a finite element softwares. And the topology optimization is used for developing lattice structures with enhanced performance. Hence, the various topology optimization methods for functionally graded lattice structures are discussed in my review paper. And the results and discussions from major literature reviews are: topology optimization produces lattice structures with optimum material distribution with improved performance based on various algorithms implemented. And this, among that, functionally graded exhibit much higher stiffness and 7.8% lighter than the lattice structure with a uniform fill. And also, topology optimization of graded structures were identified as being the most effective, that is 40 to 50% higher than the uniform lattices in terms of stiffness. And also, from the results, topology optimized functional gradient cellular structure is much stiffer and have better heat conductivity than the uniform cellular structure. And also, from the numerical evaluation results of various studies, solid solution derived from the SIMB-based topology optimization method attain the lowest strain energy or maximizing maximum stiffness. Considering the manufacturer evaluation, graded lattices have a lower surface area when compared to other lattices. The surface area increases when the extent of latticing increases. The major conclusions from the paper study are, hence we can conclude that strategies for lattice structure design using topology optimization are superior in terms of stiffness. And from the study, it is evident that topology optimization of functionally graded lattice structure is the most typical optimized design method. And since these are complex structures, additive manufacturing technology are used to making these structures to be a reality. The major significance of this study is that instead of spending time creating a model, we can use topology optimized model as a starting point or reference while simultaneously improving performance. And also we can use topology optimization studies to explore new ideas and varying design options and help refine designs by understanding where to add material and where to take it away. While this may not be the best option in terms of structures and efficiency, however, offers design engineers a chance for lightweight and better structure. And the advantage of the design process with an optimum structure is far better than a purely manual design process. The future scope, however, noticed from the study includes functional graded lattice structure is an emerging area in additive manufacturing that is related to 3D printing that opens new pathways towards the fabrication of multifunctional material systems with superior performance, and an effective topology optimization algorithm is still under research specifically for functional graded lattice structure. And also it is found that limited comparative studies of topology optimization algorithms are done to optimize functionally graded lattice structures, or more effective studies on graded lattice structures optimization for additive manufacturing is an important area for future research. And these are the references. Thank you. Hello, sir.
Yeah, good presentation. Very good.
Thank you, sir. Hello, sir. Am I audible? Hello?
Yes, you are audible. So, any questions from participants?
Sarah, there is a question from Myanmar. So,
hello, sir.
Lattice structure. Lattice structures are basically light in weight, right?
Yes, sir.
But now I'm having doubt on strength and stiffness of the lattice structure. So how to, because generally once if the structure is light in weight, automatically we will be worrying about the strength itself, because the other parameter is strength only. So how to identify the strength or stiffness of the lattice structure?
Basically, there are various types of unit cells are combined together to form a lattice structure. We are here using the functionally graded lattice structure. From the literatures, it is noted that functionally graded lattice structures have advanced functional properties, minimizing overall weight of structural part, and also showed improved structural applications like high stiffness, high energy absorption, etc. Sir. Hello, sir.
Yeah. So you have studied only the steel structures only?
Mainly lattice structures. I reviewed about the steel structures. Yes.
Completely. Okay. So that completely the jointed structures like castellated beams are coming under this category?
Yes, sir. Lattice structures main field are castellated beams, etc. I am reviewing about this functionally graded lattice structures.
Okay. Very good. Okay. Good. Yes.
Okay, sir. We shall move
Hello,
to the
sir.
next one. Yeah, thank you.
Thank you, sir. Thank you very much, sir.
Saurabh? Paper ID number 155?
Yes, sir.
Yeah, now you can share the screen. The paper ID number 155.
Yes, right, sir. So my screen is visible to you? Hello.
Yes, Saurabh. Yes, Saurabh.
Yes. Screen is good. Come on. Go ahead.
Sir, good evening, sir. Hello.
Yes, Saurabh, you are audible.
Good evening, sir.
Please go ahead,
Good
sir.
evening, sir. My topic is comparative study of seismic behavior of diagonal structure with conventional structure. This is the introduction about my topic. Diagonal structure is a system of triangulated beams, straight or curve, and horizontal ring that together make a structural system. In which diagonal structure is a vertical member I have placed in a tangential. The outer face of building, that column are placed and tangentially. Diagonal. I mean diagonal.
What is the paper ID? Can you please tell me? Your paper ID is how much?
150.
151. Yeah, please carry.
In my buildings, the outer face of column are placed diagonally. That's why we call it diagonal structure. Problem theories are nowadays using software analysis building was various non-linear method. If we analyze the non-linear time history analysis, this is not possible. The structure has not yet studied. From the earlier research work till now, various researchers have carried out study for geometrical irregular shape building by incorporating diagonal structure system. However, there is an absence of scientific research dealing with performance of diagonal structure system in high-rise building, especially when geometrical irregular shape and unsymmetrical shaping plan. In which say that the unsymmetrical plan with or irregular shape have not studied it over this topic. The analysis of the model has done grid model only. No researchers have done the by taking actual plan of the building. For this, we can say that only in this project we can say outer face of column are placed diagonally, inner are as a vertical place. These are my objective: to study the structural diagram system, to analyze diagram and conventional structural system using Strato software, to compare the performance of building with diagram structure system with conventional frame subsystem, to obtain the response in terms of parameters such as story displacement, story drift, story shear, and bending moment as well as. These are my methodology. I'm modeling with the Strato using Strato software. This is my plan, sir. We are showing in figure number 1. Sir, I have taken 15-story of building in which 576 meter square of area, and side margin is 24 meter by 24 meter. And column size I have taken is 300 by 600 mm, and beam size I have taken is 300 by 450 mm. I have analysis using the Strato software. These are my result and discussion. Study shows that the diagonal structure decrease the bending moment, in which result decrease the reinforcement requirement. It shows that if we place diagonal column in the building, it gives minimum bending moment over that column. So that's why we save the up to 20 or 15 up to 20% of steel. It shows that the lateral displacement can be minimized by using diagonal. Due to the diagonal column on its perimeter, diagram shows better resistance to lateral load, and due to this inner column get relaxed and carry only gravity load, while in conventional building both inner and outer column are designed for the both gravity and lateral load. A significant decrease of building moment in interior column of diagram bending is found to be comparison on conventional building. These are my results of member displacement. The first result is a member displacement of structure, in which result shows that the I have taken 4 model. First one the conventional, second digrid, third one is a 4 model digrid structure, and fourth one is 6 model digrid structure. In this result, member displacement of structure, in this result, it shows that the conventional structure are not good enough as compared to the other one. But next one is picture, in which the conventional structure are less as compared to the Digrid 4 module and Digrid 6 module structure. This is base shear as compared to the conventional structure as low base shear as compared to the other structure. In this result shows that. And this time period analysis. Comparison of the it is observed from the graph that time period is maximum for the conventional building and minimum for Digrid structural system. Thus it is observed that the Digrid structure is stiffer than the other structural system. These are support reaction graph in which show the yellow line, blue line shows the conventional building, other is Digrid structural system. These are my conclusion. The comparison of lateral load resisting system is done by the researchers. In the above study, some researchers have compared the top story displacement and conventional system with Digrid system and found that Digrid system is superior in performance the conventional system. Some researchers have compared the story drift and story shear of the Digrid. The unique composition of characteristics of the structure provides great structural efficiency for tall building and aesthetic potential in any existing orthological urban constraints. Sir, these are the references. Thank you. Hello.
Any results that you have done? You can
Sir,
share any results, anything?
Sir, I have taken 5 graphs: member displacement, peak shear, base shear, time period, and support reaction. Sir.
What about the wind load?
What, sir?
What about the wind load?
Wind load.
Yes.
Sir, if we, when we consider the earthquake load as compared to the earthquake load, wind load is as compared to negligible. So we didn't consider it, sir.
To what height it is negligible from your findings?
What, sir?
To what height? What do you mean? You are talking about the tall structure and Digrid structure, and what I feel is the Digrid structure is good for wind loads. Then base shear, or what about the what is called the seismic load?
So my building height is about 48 meters. So when I applied earthquake load over it, sir, as compared to the earthquake load, wind load is negligible. So I didn't consider it. When if wind load is act on the building, that is not negligible to it. It is not effect on the building. Wind load is not effect on the building.
Even then, you are preferring the Digrid as a structural member.
Okay.
Is it so? Is it so required when wind load is not there? For the entire height of the building, you need to prefer the Digrid structure.
Without wind load, actually, I have applied earthquake load. That's why I didn't take it.
It is contrary.
What's up?
It is contrary, yeah. When a tall building is considered, the wind load will be effective and the Digrid will be good in terms of wind load only. Otherwise,
so I
your
consider
the basic idea of calculating the only earthquake system may not be correct. I have never calculated. But still I am speaking.
Sir, I have analysis this building over the status software, but it results give the proper results. So I didn't consider the wind load. So I have preferred many research paper over the Digrid structure by Elsevier or anywhere else. There is no wind load considered over it. Many of them never consider wind load, sir.
Okay, which seismic zone that you have considered this?
What, sir?
Which seismic zone?
Sir, I have taken seismic zone 4.
4?
4, sir. Seismic zone 4. Yes. I have taken all data about IS code 1893. Yes, sir.
You have compared here the seismic behavior of a Digrid structure with the conventional structure, right? Do you have any Digrid structure here? Can you show me one Digrid structure?
What's it?
Digrid structure. Can you show me an example here? Any particular building which is fabricated by the completely diagrids.
Sir, I have not taken actually I have diagram structure example, but I have not taken in this slide, sir, because due to some limitations.
You have
I
compared
have
only.
example.
Yeah, diagrid structure means it is like RC structure or it is a steel structure.
We can take as a steel we can take as a steel, but I have considered it a concrete structure.
You have taken RCC structure.
Yeah, sir. Right, sir.
Okay. So you identified the seismic behavior between these two structures with reference to any software you have adopted here while comparing the seismic resistance of these two structures.
Sir, StatPro, I have StatPro.
StatPro here.
Right, sir.
So finally, you conclude the diagrid structures are better having seismic resistance than conventional.
When it comes to the maximum high-rise building, diagram structure is preferable. It gives it saves up to 20% of our steel, sir, and it's stable as compared to the conventional structure. It's stable. And main point is that 20% steel are saved in this building.
That's what. If you show the diagram structure after it is built, like you can have better comparison between the regular conventional structure of RCC and similarly RCC diagram structure. You don't have just you can have the complete the conventional RCC building and the diagram RCC building. Do you have anything photographs like that so that we can compare how actually a diagram structure will be differently looking when compared with the conventional building?
Okay. Can I see other file?
I think the time is not permitted. If it is there in the PPT, it will be better. Again,
Okay, but I have not taken in this slide, sir. I have not taken in this because due to limitations of limitation of slides, sir.
Afterwards, you
Yeah,
can share.
I have in my PC. I have in my PC images.
Again, now we are running out of time. We need to take care of so many presentations. Okay, we'll meet again.
Okay, sure, sir. Anything?
Nice, very good. Okay.
Thank you so much, sir.
Next participant, Mr. S. Yes.
Hello.
So,
Sir,
yes,
is it visible?
Yes. What is your paper ID number?
Sir, my paper ID is 156.
156. Okay. Okay, please go ahead.
Okay, sir.
Okay, you can proceed.
Yes, sir. Yes, sir. Good evening, all of you. My name is Ashatani, and today I am here to present my topic: seismic performance of L-shaped building through plan irregularities. As you know, the trend of irregular building have rapidly increased due to aesthetic and limited availability of the land. But past studies have shown that the structure with configuration irregularity are damaged under strong ground motion. So structural irregularities are important factor which decrease the seismic performance of the structure. So irregularity I discuss about is plan irregularity I have taken. So method I have used is equivalent static analysis method and response spectrum analysis method. And I calculated the structural response like story displacement, story depth, torsional irregularity, etc. in the ETAP 2018. These are my plan details. I have actually compared both the plans irregular L shape and regular square shape. I have taken 6x6 course in the equal length of 5 meter, and I have taken 11 stories, and all the parameters required for the designing like column size, beam size, and uh, seismic zone factor, uh, response reduction factor, etc. And but I have faced some problems like as per the data IS 1893 according to the study as per IS 1893, the data provided to design the irregular shape is not sufficient. So, but there is a new IS code which is 2016, IS 1890 2016, and the changes has been made that I have taken in my model designing. The changes are they mention the importance factor 1.2, and they strictly mention the damping factor used is 5% only, but in old there is also 2% used, and moment of inertia are also taken, and dynamic analysis are compulsory for all the zones. Results and discussions. And one second. The RSX and RSY stands for the response spectrum analysis in X and Y direction, and EQX and EQR stands for equivalent static analysis in X and Y direction, respectively. This is the graph of variation of base shear. It is seen that the base shear of irregular building is less than the structure in both the static and dynamic methods. So the building having less base shear is vulnerable as per the references. Story shear, this is the graph of story shear. Story shear is the graph how much lateral load, seismic load is acting per story. The lower you go, the greater the shear becomes. So in story shear, regular building is performed well and the irregular is building not well. This is the story versus displacement graph. As you see, the height is increased, the displacement is also increased. But regular structure have more displacement and irregular have less displacement. So in that, regular building is vulnerable. This is the graph of story drift. As observed from the IS 1893 part 2016, story drift from both the structure are passed as per the IS 1893. But if we see the values are vulnerable for the irregular shape. This is the graph of time period. As you know, time period is the building, time span is the building is the time taken by go through one complete pattern of the oscillation. And it is inborn property of a structure certain by mass and solidness according to different impact characteristics when the solidness of a building increments. On the rigid building, time period should be less as possible. Hence, above graph shows the regular building has high time period as compared to irregular structure. The conclusion, the performance of the regular model was good only in base shear and story shear, and in the other responses, it is not performed good. On the other hand, irregular was good in every response except the base shear and story shear. And the after effects of fundamental natural time period have proved that the IS 1893 doesn't think about the inconsistency of structure, because in that only one formula, not only one, I have taken the one formula which is 0.075 into H, that gives the constant value. But as you see in this graph, the ETAP software gives the variation of the values. These are the references. Thank you.
Good, very good presentation. Very good. Okay.
Yes, sir. Thank you, sir.
We shall move to the
So
next.
any questions?
So any questions, sir? Any questions for participants?
Yeah, you please go to the title side, Mas. What's your name?
Yes, sir.
Yes. What is the title of your presentation?
Seismic performance of L-shaped through planned irregularities.
Okay. So finally, you identified the seismic performance is good for regular buildings than L-shaped buildings, like symmetric building.
Sir, yes, but some of the performance are not good for regular according my point of view.
Okay.
Like displacement is more in regular buildings. I don't know how,
But in the
but it
presentation,
is not good.
people are not showing any result-oriented things actually, because while you are comparing L-shaped building with a regular building or symmetric building, where actually you are comparing with respect to the results point of view, maybe you might have used any software, something like that. Okay.
Sir, I compared as per the seismic responses.
Right.
Yes, sir.
Of course, now regular buildings are always better seismic resistant than irregular buildings. That is quite obvious.
Yes, sir. Yes.
Okay. Yeah, ma.
Thank
Okay,
you,
ma.
sir.
All right, good.
Thank you, Yash.
Or how to make presenter to you?
No, no need. Just
Okay. Okay. Thank you,
Sheetal.
sir.
Sheetal.
Yes, sir.
Yeah. What is our paper ID? 212. Right?
212, sir.
Yes, fine. So now we can present you, share your screen.
So it is visible.
Yes, Sheetal.
Ah,
Please go
yes,
ahead.
yes. Good, good. Go ahead.
Good evening, everyone. My name is Sheetal Borkar. I am from GS Raisoni College of Engineering, Nagpur. I am representing my review paper on comparative study of flat slab structure and conventional slab structure. This review paper is done under the guidance of Dr. Kuldeep Dabekar and Dr. Isha Khedikar. Now come to the introduction. This multi-story building is becoming a necessary part of our living, polished and tasteful from each increasing required of space. The lack of space is forcing us to raise the height of structure as much as possible to accommodate maximum number of people and also is harmony with the architecture necessities. This multi-story building constructions can be done by the various structure system. Two main group according to arrangement of slab, beam, girders, and column are the frame building and flat slab building. The flat slab structures are structured in which the slab support directly by column. In this, the floor to floor height reduce. As a result of structure become cost effective. These are the literature surveys. First, Anusha I. Kohli has done work in 2018. She found that the post-tensioning with a buffer reduced to the stress concentration in the post of slab junctions due to the tensioning of the flat slab and not effective what found of the most gravity at unconfident extent but the most of the shear and the post increasing. Second, Imran B.K. He analyzed the office tower of G plus 5 building of flat slab and conventional slab using ETAP software. He found that the flat slab is not economically at all. Due to the slab thickness of and size is waffle panel, the construction cost is increases. Anga Jamis, Mithun Katodia, Neil Vagadia, Sandeep Mullani, March 2019. They used two types of slab, first flat slab structure and second conventional slab structure. When they compared it, they found the time required of conventional slab building is more than the flat slab building. In the flat slab building, base shear only increase, whereas the conventional slab base shear decrease after 6th floor. Similarly, Vinod Kaut, Volume 6, Issue 2019, he worked on the flat slab structure with and without shear wall. He found that the thickness of building change with the story height and the surface shear bending stress increases in 10 to 20 story building and decreases in 20 to 30 story building. B. Anjan Elu, K. Jaya Prakash, Volume 4, Issue 2020. He found that the flat slab provide more structural stability to the building and give aesthetic view of the building. Imran S.M. Raghunandan Kumar. He carried out paper 2020. In 2020, they found that the saving up to 25% can obtain by the optimization in reinforcement touchable ribbit slab. Raj Joshi, Ganga Patadidar carried out the research working on 2020, they analyzed the feasibility of the G+5 tower with the single column. They found that the flat slab structure and waffle slab is one from the with or without outer column have had a noticeable effect in the property of multi-story towers design, enabled with their utilized for the variegated purpose of the building. These are the problems. Definition. They are the very few research work available for the varying flat slab span in highly seismic zone. The dynamic analysis of various structures have been assessed, but the FAR has the RC building, RC flat slab building with varying the span in concentrate. No work has been reported. There are issues which are not mentioned in post-engineering construction in the India, which is higher cost. The methods are the selections of 5 variegated types of slab models are considered is conventional slab model, flat slab with drop, flat slab with common column head, and the combination of drop and head. There are 2 methods of seismic analysis, linear static analysis and linear dynamic analysis for the different seismic zones factor. The 5 slab models are examined for the different zones factors. Analysis is conducting using E-type software 2015. Table 1. For the analysis of required for the following data is preliminary data and seismic data. Preliminary data, the number of story is G+5, plane dimension is 30 to 20 meter, type of structure is commercial building, floor to floor height is 4 meter, total height of structure is 24 meter. Come to the seismic data. Seismic loading is as per IS code 1893 part 1. This IS code related to earthquake. Type of soil is medium. 3D models. For analysis data above, we get the output shown in figure 1, it's flat slab model, and figure 2, conventional slab model. This is a 3D representation of data. These are done using E-type software. This reading are the given in below tables. The table 2 is represented, 3D model axial load. From the analysis data above, we get the output of showing figure 3, flat slab structure axial load, and figure 4, conventional slab of axial load. This also is 3D representation of data. This is done using E-type software. Results and discussions. Increment in base shear of structure is noticed to increase the dead weight of building as well as with increasing zone factors. There are not much difference in base shear in x direction and y direction. These readings are given in below tables. The table 2 is represented the base shear in x direction. Table 3 is represented base shear in y direction. As per the reading, we can say that the base shear increases for zone 2, zone 3, zone 4, and zone 5. This story drift along x-axis and y-axis for G+5 building with no infill are given in table 5 and table 4 and table 5 for zone 2. The story drift representation in highest value, we get all loads combinations are applied. The table 4 represented story drift in x direction for zone 2 and table 5 represented story drift in y direction zone 2. The story shear rises with the rise in the number of story, but in flat slab structure, it is observed to be the less than the conventional structure. This graphical representation is shown in the figure 5 is conventional slab story shear and figure 6 flat slab story shear. Come to the conclusion is from the above analysis, we can conclude that the story displacement is maximum in flat system and least in conventional slab system in all the seismic zones for both regular and irregular structure. Story shear is maximum in flat slab system and least in flat slab with drop system in all the seismic zone for both regular and irregular structure. For all the zones, the drift value followed the parabolic path along story height with maximum value lying near the middle story level. The story drift is building with the flat slab. Without drop is significantly light as compared as beam has slab building. This happened because of the rigidity of the beam slab structure. These are the references which are taken. Thank you.
Good presentation. You have, it seems you have selected the same size of the columns and same panel size also for the slab. Not differentiating. Same columns and same size, same panel, same room size you have selected, I hope, for the both the.
All the dimensions are same for flat slab and conventional slab, sir.
Okay, okay. Any change that we can recommend?
What, sir?
Any change that we can recommend, that number of columns can be reduced or the size of the span can be increased? Such.
No, sir. I will take all dimensions for flat slab and conventional slab are same. That's where.
Is it with PT or without PT?
So it's PPT. All dimensions I will show in PPT, which are the dimensions for same for flat and conventional slab.
I'm talking about any post tensioning has been taken or only the regular reinforced structure in flat slab also.
It's a regular structure, sir.
Okay, okay. How come it can be? What you recommend then at the end?
Sir, flat slab is more recommended because of the nowadays people want to space where they are living in the want to a strong stable structures, and also the aesthetic point of view, flat slab structure is better than conventional slab structure.
In one of the literature review, it is telling that the flat slab is more thickness, more reinforcement, so not recommended. One of the literature
sir.
review is telling that.
Thickness of slab is 125 mm according to the IS code 456-200.
For regular slab or flat slab?
In both sir. In my project, I will take thickness same, sir, for flat slab and conventional slab.
Then, because of the no beams and other things, rigidity is not there, and certain moment sharing and base shear are more in case of flat, in case of regular slab. Proper conclusion. What is your conclusion?
Sir, conclusion.
తర్వాత యాక్చువల్గా అతను ఏంటి ఎక్కడ పని చేస్తారు మీరు పేరు మీరు జాబ్ ఎక్కడ చేస్తున్నారు?
Otherwise, what is your panel size?
Okay. Sorry, sir.
What is your panel size? Column to column size.
Column to column size, sir. It's all over the 400 into 400 meters, sir.
4 meters by 4 meters.
Yes, sir.
అదే 4 మీటర్ జాబ్ ఇస్తారు ఎట్లా ఎలా వస్తున్నాడు ఇక్కడ ఏంటో వస్తారు? ఓకే.
Sir, from your side only.
సరే అన్ని చూసుకుందాం మాట్లాడదాం అండి.
Sir, any questions from your side?
Hello.
So we shall. Yeah, Sheetal.
Yes, sir.
Okay, all the best. Next participant.
Thank you.
Avinash. So, with this 1950210007.
Yes, sir. Yes, sir.
Yeah. Okay. So please share your screen.
Okay, sir.
What is the paper ID?
154, sir.
154. Okay.
Good evening, sir.
Good evening, Harsha.
Good
Please
evening,
go
Andy. Good evening. Good evening. Go ahead.
My name is G. Harshavardhan. My title is Analysis and Design of Flyover, which is ongoing project on Vijayawada Binsakil. Introduction: bridges are the key elements in any road network for infrastructure development. Uses of pre-stressed girder type bridges became popular because of its stability, economy, serviceability, and appearance, structural competence. The bridge deck is analyzed by grillage analysis. There are various types of bridges: are whole steel girder bridge, plain girder bridge, box girder bridge. Objective: to analyze the bridge structure using StatPro in an effective manner, to calculate the maximum shear force and bending moment within deck, to design appropriate bridge deck, applying loads using IS codes to it, and determining the behavior of the bridge under these loads. These are the section properties. Input for grillage analysis: center to center of end jacking is equal to 30 meters. Distance between cross-sectional length of end jacking to cross-sectional length of bearing on left side is equal to 0.55 meters. Distance between cross-sectional length of end jacking and cross-sectional length of end bearing of right side is equal to 0.55 meters. Effective span length is equal to 28.9 meters. Projection of girders. Projection of girders beyond diaphragm is equal to 0.225 meters. Length of girder is equal to 28.2 meters. Distance of jacking point from face of girder is equal to 0.15 meters. Distance of cross-sectional length of bearing from face of girder is equal to 0.4 meters. Distance of cross-sectional length of bearing from face of girder is equal to 0.4 meters. Center to center distance of jacking points is equal to 28.2 meters. Distance of temporary support from face to face of girder is equal to 7 meters. Types of girder is equal to precast girder. Force movements. Force movements. The deck is represented by an equivalent grillage of beams. It was found that the results obtained from grillage analysis compared with experiments and more precise methods and accurate enough for design purpose. The orientation of the longitudinal member should be always parallel to free edges, while the orientation of transform members can be either parallel to support or orthogonal to the longitudinal beams. The other method used in modeling the bridges is finite element method. The finite element method is as well known for the solution of complicated structural engineering problems, as it can accommodate many complexities in the solution. SFD and BMD, the girder. SFD due to self-weight of the girder and bending moment due to the self-weight of the girder. Conclusion: for self-weight of the girder condition, the maximum shear force is found to be 362 kilonewtons at section 1, which is placed at the distance of 0.5 meters from the face of the girder. The maximum bending moment is found as 2350 kilonewtons per meter at section 11, which is placed at a distance of 14.25 meters from the face of the girder. The conditioned extra plus diaphragm, the maximum shear force is attained at section 11 and 21, which is present at the distance of 0.15 meters of and 28.35 meters and it is 102 kilonewtons. The maximum bending moment of 481 kilonewton meters attained at section 8, which is placed at a distance of 9.325 meters from the face of the girder. These are the references which I have used. Thank you, sir.
Harsha. Sir, any questions, sir?
Good. Okay, good. All the best.
Next, Avinash is ready.
Yes, sir.
Yes, Avinash?
Yes, so you can hear me?
Yes, sir. Your paper ready, Avinash?
The paper ID is 131.
Okay. Okay, please go ahead, Avinash.
Okay, sir. Yes.
Please share your screen.
Yes. Good evening, sir. Can you hear me and can you see the display?
Yes, Avinash.
Hello.
Please go ahead.
Okay. So I'm start now.
Yeah. Okay, you can start.
Okay. Good evening, sir. It's Avinash Kadamkar from GH Raiswani College of Engineering and Technology, Nagpur. My paper ID is 131. The topic is controlling seismic excitation in the RCC building with the tune mass damper. The author is Avinash Kadamkar, myself. The co-author is NH Pitle sir, and the second co-author is BP Patil sir, GH Raiswani College of Engineering, Nagpur, Akola, Maharashtra. Abstract, introduction, methodology, result, discussion, conclusion, and references. Abstract. Using the multiple tune, the use of multiple tune mass damper to monitor the seismic response of tall building in investigation. The multiple tune mass damper are located in the three locations in the reinforced concrete structure. The time domain seismic analysis is performed on ETAP software using the imperial ground motion for time history analysis. The performance of the multiple tune mass damper is compared with that of tune mass damper on the top floor and the tune mass damper on the third and fifth floor. The tune mass damper on each floor and tune mass damper. The base shear versus time and displacement parameter were examined, and it was determined that the multiple tune mass damper on each floor is better than the building seismic response. Furthermore, it has been discussed the multiple tune mass damper are more powerful than the single tune mass damper. Introduction. The tune mass damper is a structured depending system that decreases the amplitude of mechanical vibration by using the large masses. They avoid the structured damages during the seismic event. The tune mass damper may be used as a pendulum, the pendulum water tank, or a system consisting of a large mass surrounded by the spring and a despot. The tune mass damper was first operated in in 1940s. It consists of secondary mass with properly tuned spring and damping element that provides frequency dependent hysteresis in the primary structure, increasing the damping. It is now well established that such a system can reduce the wind excitation structure vibration. The tune mass damper effectiveness in reducing seismic response of structure has recently been studied numerically and experimentally. Methodology. The analysis of G+5 story building with and without installation of tune mass damper analysis and design is done by the ETAP software. The structure load applied by the considering the gravity load, dead and live load, and the requirement load, the earthquake load, and the analysis is done by the method of time history analysis, considering the imperial valley data. Time history analysis. The time history technique calculation all calculate the forces, and as a result, the structure displacement during the entire reduction of ground motion at the equal interval, typically 0.05 to 0.1 second. The behavior of the structure under the historical earthquake or wind acceleration data is studied using the time history analysis. The structure does not have to be an SDOF system. The structure relation is compared at the number of consecutive time instant in time history analysis. In the other words, as the result, the temporal history of the structure respond to a given input are obtained. The time evolution of a response cannot be established in the response spectrum analysis. This is building parameter. The model of building G plus 5 story RCC structure consider for the analysis. The building has bay width of 5 in X and Y direction with 5 story height. The base floor height is 3 meter. The tune mass damper is installed at the top of the building, at third and fifth floor. At all the story with different model, linear time history analysis is carried out in ETAPS version 16 software using the earthquake record such as Imperial Valley data. The building is designed for all the 4 seismic zones: Zone 2, Zone 3, Zone 4, and Zone 5 as per IS code 1893/2016. Contain the number of story is G plus 5. Floor height is 3 meter. Base floor is 3 meter. Wall thickness is 230 mm. The imposed load is 4.5 kilonewton per meter. Size of column is 500 mm into 500 mm. Size of beam is 230 mm into 450 mm. The depth of slab is 125 mm. The type of soil is medium black cotton soil. The grade of concrete or steel is M20 and Fe415. Response spectrum and the response spectrum as per the IS code part 1 2016 for 5% damping. The response reduction factor is 3 OMRF. The live load on top is 2 kilonewton. The mass damper calculation is 44.56 ton. The stiffness of damper is 61.21 kilonewton. The damping coefficient is 1.458 kilonewton meter per second. The damping ratio is 5%. Ratio is considered 5%. This is the model, sir, which I have done on ETAPS. This is here the damper is being installed on the top floor. Here the damper is installed on the third and fifth floor. Here the damper is installed on each floor. The result. These are the all the 3 zones. The brown color represents the zone number 2. Orange color represents the zone number 3. Again, the zone number 4 is 4, and zone number 5 is represented by the color which we can see on the screen. The above graph shows the base shear versus the time result for damping location at the top floor for all the 4 seismic zones. In the maximum base shear 0.1 kilonewton at 5.5 second for zone 5, as the effect of seismic force is more at the at zone 5, whereas it is less for the other zone condition. Second graph for the damper located at third and fifth floor. For the above graph shows that the basic shear versus the time result for damper located at third floor and fifth floor for all the 4 seismic zone. In this, the maximum base shear 0.1 kilonewton and 5.5 second for zone 5th. Here the base shear is almost similar to the zone 5 for the damper at the floor third, fourth, and fifth floor condition, but in this condition the other seismic zone has graph in the same pattern here for the damper located for each floor. The above graph shows that the basic shear versus the time result for the damper located at each floor for all all the four floors seismic zone. In this, the maximum base shear is 0.17 kilonewton at 5.1 second for zone number 5th. Here the other seismic zone has graph in the same pattern. Now the other condition is without damper condition. The above graph shows that the base shear versus the time result for damper located as each floor for all four seismic zone. In this, the maximum base shear 0.08 kilonewton at 6.7 second for zone 5th. Here the other seismic zone has the graph in the same pattern. As here there is no damper, the amount of forces generated by the earthquake will be more, but the structure will not take more seismic forces. So the base shear value is the amount of the force the structure can resist. Here the comparison is done for the damper located at the top floor. The above graph shows that the displacement result for the damper located at the top floor for all the four seismic zones. In the maximum displacement of 61 mm in fourth is found at the zone 5th. So the structure is displaced to to a to a displacement of 61 mm for the origin when the zone 5 seismic force act on the structure. Here for the displacement of location at third and fifth floor. The above graph shows that the displacement result for damper located at the top floor for all the four seismic zones. In this, the maximum displacement of 57 mm is found at zone 5, so that the structure is displaced to the distance of 57 for the origin when the zone uh, zone 5 seismic force act on the structure, which is less than the value of damper at the top floor. For the damper located at each floor. The above graph shows that the displacement result for the displacement located at the top floor for all the four seismic zones. In this, the maximum displacement of 49 mm is found at the zone 5, so that the structure is displaced at the distance of 49 mm for the origin when the zone 5 seismic forces act on the structure, which is less as compared to the value of damper at that floor at the top floor and damper at third and fifth floor. For without damper condition, the above graph shows that the displacement result for the damper located at top floor for all the four seismic zones. In this, the maximum displacement of 81 mm is found at zone 5, so that the structure is displaced to a distance of 81 mm for the origin when the zone 5 seismic force act on the structure, which is more as compared to the other damping condition because there is no damper to resist the seismic force. Conclusion: the tune mass damper is a structured depending system that decrease the amplitude of the mechanical vibration. By using the large masses, they avoid the structural damages during the seismic event. The tune mass damper may be used as a pendulum, uh, a water tank, or a system consisting of a large mass surrounded by spring and a dispute. The base shear versus the time graph comparison shows that the shear versus the time is more in the condition where the damper is applied at each floor. In the deflection comparison, it is seen that the structure without without damper has more deflection, while the structure having damper at the each floor has very less deflection than the other damper condition. The study conclude that the damper reduces the deflection of the structure while increases the base shear vibrations with the structure. When it comes to dynamic reaction control of buildings subjected to seismic load, the multiple tune mass damper outperform than single tune mass damper. These are the references, sir. Thank you.
Good presentation.
Okay, thank you, sir.
Any difference between provision of the damper as water tank and as a moss? Which is correct and why?
So will you please repeat?
You are talking about sometimes you can use damper as a water tank, right?
Yes.
And sometimes it can be a moss with supported by springs.
Yes.
So which place, what is required, when?
Sir, it depends on the condition as per the seismic zone also, and as per the previous case studies which we have which were taken in references.
Suppose I got a one doubt. What is
Yes.
the displacement allowed according to the length of the building? It is L by 500.
Yes.
Right? As per the code.
Yes. Okay.
Suppose if you take 200 meters as the building height, what will you expect as the displacement?
It is 500 by L, so 500 by 200.
Yeah. Yeah.
Yes.
How much? 200 meters, 500 parts.
It will near come thing. I need to calculate it.
How much it is coming?
Uh, 2.5. 2.5.
What is 2.5? Mm? Meters.
Meters.
200 meters made by 500 parts. Almost half of the 200 meters.
Yes.
1 meter. Half of 1 meter.
Yes.
Like 500 mm or 400 mm. Do you feel for such a long building, is it good to have a deflection of 400 mm?
No, it's not good.
Then how the codal provision for the long buildings, and how come you can justify with your dampers?
Sir, I have not done the study of such a long building. The study is still up to G+5. In further research, as per your reference, I will go for that also.
Okay, okay. But G+5, does it require any of such dampers?
Sir, if the area is highly seismic, then it may required, and and sometimes we can't guess the nature, no.
Okay, okay. You are right. You are right. You are right. Okay, good. The future research can be like what my prima facie doubt is like this. When I am going for my own building, I have got the same doubt. That is why I am posing before you.
Sir, some years back, if you allow me, I want to tell some incidents.
Yes.
Some years back, we were having a great tsunami in Japan. The building which was destroyed by the Japan was made as that the tsunami will not destroy it. but the height of tsunami was so that it broke all the safety of that building. So we can't guess the nature. So each and every life is important for us. So I think G+5 is also important.
Good, good. Okay, I'm not denying you. I'm not denying you. But I'm comparing with the codal provisions, the deflection allowed, the displacement allowed, whether it can be imaginable. That's what my question and answer is.
Yes, I have done the measurement as per the IS code and the paper.
Good, good. You are good. I'm not talking anything bad about you. And I'm just giving a reality where I have started my building with 200 meters length, and I got a doubt with all the people that how a displacement of 400 mm in a reality, though the code book allows as L by 500, is good for our structure. It is not as a layman, it is not believable by me.
Yes.
So what to do? What type of dampers, how to control? It is allowed up to 400 mm for a 200 meter tall building. How to construct it otherwise when it is being deflected by the wind loads?
So we can take the building's ETAB model, and as I have compared your G+5 building, and I have taken the result, we have to take the building whatever it may be G+N, and we can see the result. What are they? And if we do the mathematical model and the analysis model, we can get some strong conclusion for the respective building.
Okay, good. Okay. Take care. All the best.
Okay, thank you, sir.
Okay, Shekashar garu, three
sir.
people are raising their hand.
Yes, sir.
Just kindly.
Yes, sir.
Aman Agarwal, Ashwin, and Rishabh Shinde. Just.
Yes, sir. Amman Agarwal, I'm giving you a presenter privilege. So please share your screen.
Yes, sir.
Amman?
Yes, sir. I'm sharing my screen. Just a second.
Yes. What is the paper ID? Amman?
Sir, 179. My paper. Am I audible? Hello, sir. Hello.
Yes, you can continue, Agarwal.
Yes, sir. So my topic is comparative studies between precast and conventional cast in situ structural systems. I'm Aman Agrawal, the author. The supporting authors or the co-authors are S.S. Sanghai sir and Kuldeep Dhabeka sir. Both are the assistant professors in our college, J.H. Raiswani College, Nagpur. I would like to start my presentation. So mostly the construction is done by conventional cast in situ. Like we construct the columns over in the site, like beams in the site. But as the demand is increasing for the construction, we need to adopt an alternative way. Precast concrete is one of the methods of construction which can be readily adopted, and it is seen that it is mostly adopted for commercial buildings or high-rise buildings or industrial buildings. It's just because of its improved and better qualities and properties which it have it with its stands. It also withstands various conditions like high seismic loadings, cyclic loadings, and more similar loadings. Also, we have an appreciable quality control, requires less manpower for construction and can be easily installed. So for this precast construction, we require very less manpower for the construction in the site area. The quality is controlled very well because all the construction is being done in the controlled environment. Depending upon the load-bearing structures, there are three types of precast units or the structures which we can see. First is the large panel system, second the frame system, third the slab column system. The large panel system, in an easy word, we can say is the load-bearing walls which we had in the earlier times. But in this, there is a floor and a wall being very thin, being of 200 mm or 500 mm, but it is reinforced, being pre-stressed reinforced. Frame structures is similar to like conventional buildings, beam column, assemblages of beam column, and the slabs. And this slab column systems with one is generally the assemblages of slab with the columns sustaining the lateral loads, and the slab and these systems rely on the shear walls, which sustain gravity loads. So the method adopted for this is I have used for analysis and modeling purpose, I have used Icace 2016 software. For the purpose of modeling and analysis, a basic plan of building was taken, in which a building was G+5-story building was considered. Both the plan was same for both the type of buildings, being the conventional cast in situ and the precast building. The height of individual floors was 3 meter height, and the square carpet area being 625 square meter. The columns I have taken was of two sizes, being 700 cross 700 mm and 650 cross 650 mm. 700 cross 700 mm were taken for first 4 floors, means ground plus 3, ground plus 2, sorry. And for 650 cross 650 was taken for the 4th and the 5th floor. And the beam was taken as 600 cross 600 mm. It was taken entirely same for all over the structure. The slab was taken to be 150 mm thick. So in both the types of structural systems, the slab which is taken in conventional cast in situ can support for two-way slab as well as one-way slab. And in precast system, the slabs are maximum to the maximum being 1.2 meter width. Sorry for the length, as it helps in the transportation purpose, and it's taken to be a membrane system, and it's simply supported, means it allows only one way load distribution. This was the reference plan I have taken, and this was the 3D view from the Icace software. Now coming to the result and discussion part of my presentation. The outline construction, one being precast concrete design and other being traditional cast in situ structure, having G+5 story, is analyzed for gravity and various different loads, and for wind, wind and seismic zone, considering to be the Srinagar part. The modeling and analysis is done in Icace software, and its planning is likewise checked to protect whether the areas give really bear the loadings, and it outcomes the short. After the investigation work, estimates are ready for various levels and introduced as appeal. First, I'm taking the parameters being the story drift. So as per the clause mentioned in IS 1893/2016, the story drift for individual story should not exceed the 0.004 times of its height. And by following though that, both the buildings are safe for the story drift. And for the story placements of both the buildings appears to be safe for the displacement. The maximum displacement I have seen, I have got obtained was 35 to 40 mm. Higher displacement was seen in precast building. Now comes the story shear. The acceleration spectrum estimate was 0.08 for the ordinary, that is cast in situ building, and 0.1 for the precast concrete construction. The story shear was multiple of acceleration spectrum estimate and seismic load. Now talking about the time period, these are the means for the different modes the graph shows. The time span of the building is taken by it go through one complete pattern of the oscillation. It is intrinsic property of the structure constrained by its mass and firmness. The conclusion, the comparative studies accomplished for both precast construction and ordinary construction. In this investigation, different boundaries were viewed, like story displacement, story shear, story drift, time, which I showed in the result, and examination of both between both the kinds of outline construction, being precast and conventional, having G+5 story building. In examination, just individuals are planned. Joints were not planned and may be done for the future scope. Execution of two buildings were discovered and to be fulfilled. Both the buildings were seen to be having better outcomes They were good, but precast was seen to be better. These are the references I've gone through. Thank you.
Good. Take care. All the best.
Thank you, sir.
Next, Ashwin. Please share your screen. Ashwin, are you there? Paper ID 171, Ashwin.
Hello?
Yes.
Yes,
Ashwin.
sir, could you, yes, sir. Can you hear me, sir?
Yes. Please share your
Yes,
screen.
Ashwin. Okay.
Yeah.
Share your screen and proceed.
Is my presentation visible, sir?
Share your screen. Yeah, now it is okay.
Okay. Good morning to everyone. My team is presenting a research paper on the topic retrofitting of an existing structure, design and techniques. The paper ID is 171. So the team members are listed here below. Today, me and my team member Srinivas will be presenting this particular presentation. So in general, when we look at structures, retrofitting is done for improving the strength and stability of a structure. In many situations, we use it for seismic enhancement. But this particular project was taken to investigate on how this retrofitting solution can be used to change the functionality of a given structure. For example, if you want to convert a commercial building into a residential building or vice versa, we can use retrofitting to capacitate the extra loads that may be used in that particular situation and change the functionality of a given structure. So these has many benefits. So retrofitting instead of complete reconstruction may have benefits in terms of financial, that is, it's very cost efficient. It has energy conservation properties. It reduces labor hours, and overall duration of time of the project itself reduces. So this particular project that we took up is taking a 10-story commercial building, and we want to change that into a data center building. So in order to do that, we are using certain retrofitting strategies such as carbon wrapping and steel capping, and which will be explained further in further section. So this is a rough flowchart that we put for how this analysis was carried out. This particular analysis used the finite element analysis, and we used the ETABS software. So what we initially did is we took the plan of the existing 10-story commercial building. We put that in ETABS. We applied relevant gravity loads. That is, we took live load parameters as 3 kilonewton per meter square, dead load parameters as 5 kilonewton per meter square, and the self-load of the self-weight of the building itself. Now, once we did that, we applied the relevant load combinations as per IS 456, and then we saw the reports of the buildings for the beams, columns, and slabs. After which we applied extra load, that is, the live load parameters were changed from 5 kilonewton per meter square to 10 kilonewton per meter square, which was in accordance to IS 875 part 1 and part 2. Now, once we did that, we obtained the results for the data center building and the commercial building, compared the bending moment and the failure sections, and suggested necessary retrofitting. Now, this is the CAD diagram of the building that we took for analysis. Over here, you can see that the building is divided into specific strips. These are the load parameters over here, as mentioned before. Now, these are the sizes. So the flat plate thickness that we adopted was 250 mm. The column size was 800 cross 800. The perimeter beam is 800 cross 600. and the floor height that we took was 4 meters. Now, as mentioned above, when we took the building to be a data center building, the live load parameters was shifted from 5 kilonewton per meter square to 10 kilonewton per meter square. Now here you can see the framing layout of the structure. Here is the longitudinal section of the beam, and here are the reinforcement details. Now, when we move, this was the first analysis that we carried out. So here you can see the 3D structure which shells and frames. Now we have a core wall present over here in this particular section. The core wall encompasses 6 separate lifts and a staircase. Now over here, what we particularly did is we took the 4th story and we applied the load over there, and we used repetition for the other floors to check out how the behavior of the structure is. Now here are the material properties for the particular structure present over here. We chose Fe 500 over here. Moving on, we chose a grade of M2025, and these are just the slab properties. In certain sections, we took 250 mm thickness, and in certain sections, we took 200 mm thickness. Now, for the first analysis, we took this particular structure, and you can see the deformation results over here. To get a better picture, we go on to the next slide. So here you can see that it's the structure is first divided into x-axis and y-axis, which were named as layer A and layer B respectively. These were further divided into strips called as column strips and middle strips. Now over here, after these loads are applied, we saw the analysis of the particular structure. This is after the analysis for the first section was analyzed. Now you can see over here that all the columns are safe because there's no red pigmentation. If there were, there will be failure. And these were the different reports that were generated after we got the these were the different reports we got after we generated the analysis. This was for the punching shear, this is for the beam, and this is for the column. Now all three, in a concise form to explain, all three show that the structure is well within its permissible limits. This was the column interaction graph that we obtained. It shows some certain level of linearity, which means that the structure is safe. Over here, you can see that the punching shear ratio we obtained was 1.363. Now, this is well within its permissible limits of 1.5, which shows that the structure is safe. And when we calculated also, we found that the tau v value was lesser than the tau c max value, which shows that the structure is safe. Now, over here, this is the last section of the first analysis. We can see that there is no red pigmentation over here in the core walls, which means that the core walls are safe also. Now, I'll be passing it on to my teammate Srinivas to discuss about the second analysis.
Shashwin, who is the teammate?
Srinivas, sir.
Srinivas. I'm not finding him. Please raise your hand, Srinivas. So I think he's available, Ashwin. Please wind up the presentation in one or 2 minutes.
Okay, sir. So he's available, sir, but I think he's only if you unmute him will it be possible to join, sir.
No, he can raise his hand so that I can recognize him.
Has he raised him, sir?
Yeah, Srinivas MK.
Yes, sir.
Hello, sir. Sir, am I audible, sir?
Yes, sir.
Sorry,
yes,
sir.
Yes.
Okay, sir. So here, sir, the presentation, Ashwin.
Yeah.
Hello.
Just a second. Sir, you need to give me permission to share, sir.
Yes, please. Ashwin, you please give it to Srinivas. No problem.
Okay, sir.
Sir, now I shall present it, sir.
Yes.
Come on. Please.
Okay, sir. I will be continuing it from the analysis too, sir. Just a minute. Yes, sir. So.
Nice. Speed up.
Yes, sir. Okay, sir. Just 2 minutes, we'll conclude. So this is the analysis 2, sir. I'm going to continue from where he left. So on this analysis 2, we haven't changed anything with respect to the design aspects, sir. We have just modified our live load from 5 kilonewton per meter square to 10 kilonewton per meter square as per the IS 875 Part 2 1987. So we have also kept our dead load as constant and the properties were also being unchanged. So what we wanted to find out is that mainly to see whether the structure is showing any sort of a failure when the heavy duty load is being increased to the present or the existing commercial building. So these were the strip moments which was being calculated through the ETAP software along the layer A and the layer B. As you could see that there is a tremendous increase in the forces as well, which was being quite expected. And this shows the negative and the positive moments as well. So moving on to this next slide, where we were also able to find out that the longitudinal reinforcement percentage was also increased, and the rebar percentage was also being increased when compared to that of a commercial building. So the next was the important step in our project, where to find out the failure modes in our story. So we were able to find out some severe column failing in the ground floor and the first floor, as it is being indicated in the red color. So this indicates that the column is being failing.
Screen is not shared. Screen is not shared. Share your screen.
Sir,
yeah.
Sir, now is it?
Yes.
Okay. Yes, sir. So over to this slide, we were able to find out that the column has been failing once the live load is being increased from 5 kilonewton per meter square to 10 kilonewton per meter square. So this column has been failing, especially in the ground floor and the first floor severely, which was our major objective, whether to find out whether the building is failing or not. So this is the corresponding column report and as well as the punching shear report also, sir. So this is the 3D view of the building showing that the column has been failing and the column report as well. So what it actually says is that as the shear force and the design moment is also being increased, the total amount of reinforcement which is to be provided in the column exceeds the maximum limit. So which is why the column has been failing. And moving on to the punching shear failure, which is happening in the flat slab also, what it says is that the nominal is actually higher than the tau c max, which is the maximum shear force. So which is the ratio of the nominal to the permissible shear stress is greater than 1.5. So there has been a failure in the punching as per the codal conditions also. So this is the failing occurring in the core walls beams also. So this failing is being accommodated by providing a shear links of diameter 10 millimeter, which is being provided at a spacing of 100 mm center to center at the support and 200 mm center to center at the midspan. So this is the longitudinal section of the beam and the shear link which is being provided. So after finding out the failures occurring at the column and beam, which is why we decided to move on to the retrofitting methods. This is the capacity check for beams and slabs as well, through which what we wanted to find out is that with the existing moment and the existing reinforcement which is being provided for both beams and slabs, when there is an increase in the load, there will definitely be an increase in the moment. Whether the same amount of reinforcement is able to withstand the increased amount of load and the increased amount of moment is what we were able to find out. And there were an increase of steel to 9.92% in the beams, and for the columns, it was an increase in 12.93% for a column at the column strip at the midspan, and 25% nearly to the column strip at the middle strip. So moving on to the retrofitting method, after finding out so many failures are occurring at the beam and column, what we decided is to move on to the retrofitting method. So basically it is increasing the strength of any particular section. The retrofitting method we have used here is the column jacketing. It's a column jacketing. So as the percentage of steel has been increasing from 4 to 6%, we decided to move into the column jacketing. As you could see, the size of the column has been increased. Later on, the failure was being overcome. But this did not fully complete our objectives, sir, as there was still found to be there was a significant failure in the punching shear as well, which is why we moved on to the second retrofitting, which is the steel column capital, which is to be explained and further concluded by the teammate Ashwin, sir. Or hello.
Please carry on, Ashwin.
Yes, sir. So just to conclude quickly, sir. So once we added another retrofitting method, which is steel column capital, we kept the size for the same to be 100 mm cross 100 mm, which is just a cap which is put onto the column. And once we did that, we found out that the punching shear ratio was fine. It was well within its permissible limit, and the tau E value was lesser than the tau C max value. So moving on to the conclusion. So yes, sir. In the conclusion, what we decided to do is we decided to do a cost-benefit analysis, and we took various parameters such as time for completion, the erection cost, the cost of steel, all of these parameters. And in conclusion, we found that there was a significant difference in using retrofitting over reconstruction. Over here, the price can be written. Two odd crores it takes to complete this project through retrofitting. However, for complete reconstruction, it takes around 10 odd crores. And this is a graph we obtained for the same. So in conclusion, we want to suggest that retrofitting for changing the functionality of a given structure will be a viable option. It is energy efficient, it's cost efficient, and it should be more adopted in future projects, sir. Thank you.
Sir, these are the several references which we have obtained through our research works.
Okay, thank you, Ashwin and Srinivas.
Thank you.
Any questions,
Okay,
sir?
what about your foundations?
Sir, we actually didn't. Our research was mainly to the superstructure. We didn't consider the substructure of the structure, but maybe through the foundation, what we were able to find out is that we can even provide a suitable retrofitting to the soil system as how can I explain is that while the construction of the column itself, sir, while putting the foundation itself, we can maybe if we could accommodate any failures, we might provide any suitable retrofitting for the same, sir.
What about the slab system? Is it good? Is it satisfying all the things in the slab?
Yes, sir. Comparatively,
Yes, sir.
the slab we have accommodated is a flat slab system. It is the most efficient, which is being currently used overweight in the field of construction. So we actually wanted to reduce the cost to be involved in the beams, which is why we introduced a column flat slab system. So that in a flat slab system, the beam will not be taking the load directly; it will be transmitted to the columns. So, which is why we adopted another alternative method, sir.
Do you mean to say that while retrofitting, you will go to the flat slab system?
No, not like that, sir.
So the building itself encompasses a flat slab system, sir. So in order to address the same, we gave the column jacketing so that the column can have better load bearing capacity. Since in flat slab systems, beams are not there, the load is directly transferred. That's why we chose column jacketing, sir.
Good.
Instead of why we decided to strengthen the column rather than the beam, sir.
Good. As per the reference, do you feel is it exactly correct that 5 kilonewtons can be enhanced to 10 kilonewtons as per the code?
Yes, sir. It has been
Yes,
mentioned in the
for IS 875 Part 2 for heavy industrial loading, it is 10 kilonewton per meter square.
We have considered there is totally 3 different loadings, sir. One is 5 kilonewton per meter square, 7.5 and 10. We have considered
so we chose the worst
maximum
case.
load. Yes, sir.
Yes,
Okay,
sir. We
for
took
data
the maximum.
Then in your speech you are talking about the conversion of commercial into residential. Do you feel that more loads will come while residential is coming up?
No, sir,
No,
not
sir.
residential.
That was just an example, sir, of how
Yes,
we
sir.
want to change the functionality. In this particular project, we took commercial building into a data center building, so that should definitely have much more load bearing capacity, sir. That is why we are introducing retrofitting here.
Yes, sir.
Good. Any dampers and other things, any wind load analysis? Any confusion?
Actually, what we wanted to conclude is that, sir, we didn't consider any seismic load. We only considered gravity load. This is just to find out that definitely if we are taking a seismic load into circumstances, severe behavior of the structure will be there and severe failure will be there. Firstly, on a basic note, what we wanted to find out is that whether the building is withstanding the basic gravity load, but through which we were able to find out some severe failures in the column. So maybe at the future research work we'll be taking into seismic.
we are planning to extend this research further in the future. So that time we may incorporate these analysis.
If it's a real consultancy, you can take up all the things at a time, right? Very good.
Yes.
Maybe Chennai will be falling under the zone 3. Maybe we'll take a seismic load condition accordingly.
Yes, sir.
Yeah. Very good. Very good. Very good. Keep
Thank
it
you,
up. Very good. You did a great work, I hope, and your presentation is good.
Thank you, sir. Thank you.
Very good. Very good.
Thank you, Ashwin and Srinivas.
Thank you, sir.
One more paper is there. Devendra, please respond. Devendra Damle. So there are participants. Please respond to the feedback form. We are sharing the feedback form in the chat box. All of you, please respond to the feedback form. Yes, sir. Yes, sir. You can share your screen. Shinde.
Yes, sir. Yes, sir. Am I audible, sir?
Yes. Your paper ID, please.
Can you see the screen?
Yeah, not yet. Not yet. Screen is not seen.
Screen is not seen. Okay. 1 second.
So your paper ID, please, Mr. Shinde.
Yes, sir. 185.
Once again, please.
185, sir.
Okay. Share your screen.
Please go ahead.
Share your screen and go ahead.
Yes, sir. So can you see the screen now? Hello?
Not yet.
Still
Not seen.
Okay. So 1 second. Hello? Sir?
Yes. Screen is coming.
Okay, sir.
Okay, proceed.
Yes, sir. 1 second. Myself, Rishabh Shinde. My co-authors are Prashant Khivshe and Dr. Sadha Sid. Today, I am going to present on topic structural assessment of RCC elevated service reservoir for different capacities. Aim of my project is to done the analysis of RCC elevated service reservoir for different capacity and parametric study about time period, base shear, base moment for empty and full condition, and hydrodynamic pressure and seismic pressure with respect to H/D ratio. Objective: selection of different components such as dimension of container, top dome, bottom slab, staging bracing, consideration of different capacities, and calculation of weight of component in empty and full condition. Design and analysis of elevated service reservoir using StatPro software. Design and analysis of following result performed with respect to parameters like time period, base moment, base shear, hydrodynamic pressure, seismic pressure. To study the guidelines given in the IS codes. Introduction. Civil engineering has always played an important role right from the ancient civilization where its canal system of Harappa or road construction in Rome. It was always a part of our culture. As time moves on, the usage of infrastructure was increased by a significant amount. The discovery of cement, concrete, steel used in reinforcement bring the revolution in it. In today's scenario, the structure of any country decided by the infrastructure development done by them. Many developed and developing countries are focusing to enhance the structural ecosystem and the creation of extensive highways for faster transportation, bridges, and tunnels to connect the offshore areas, dams and power plants for storage and electricity generation, high-rise building, accommodation, water treatment plant, and sewage treatment plant to supply and collect the water distribution system. Elevated water reservoirs are the part of this water distribution system. These are basically small man-made reservoirs which collect mostly water, and these water then distributed to household via gravity flow. These ESR have high strength and durability, but they are vulnerable to lateral forces like earthquake, mainly because of the large mass concentration at the top. Hence, the capabilities of this structure are very much important to check in the subcontinent region. Methodology. When elevated service reservoirs are subjected to earthquake, a strong lateral forces are generated, causing the reservoir to oscillate. These fluid are comprises of two parts, the container and the fluid kept in it. When lateral forces are induced, the bottom portion of the fluid undergoes oscillation along with the container wall. This portion is called impulsive fluid mass MI, and it creates impulsive hydrodynamic pressure. Similarly, the top portion undergoes sloshing phenomena. This portion is called as convective fluid mass MC, and it creates convective hydrodynamic pressure. To analyze their effect, model mass system is used. Since this system contains both container and fluid, two mass system are more effective than one mass system. A two mass system means it has 2 degrees of freedom, but these are obtained as a single degree of freedom because of their difference in time period. The structural mass MS is the system in the container mass in addition to 1/3 mass of staging, and chaos being the lateral stiffness of staging. Problem statement. For the analysis of the elevated service reservoir, 4 different capacities of the tank are taken in such a way that H/D ratio was maintained in an increase of 0.05, where H is the depth of water and D is the inner dia of the tank. The design of the ESR is done by using StatPro in accordance with IS 456 and IS 3370 Part 2, and seismic design is done using IS 1893 Part 2. Design data are taken as M25 FE500 EC is equal to 25,000 MPa. Table 1. It contains design constants such as Z value, importance factor, response reduction factor, soil. Table 2 contains design component of water tank, in which capacity of 50, 100, 250 and 500 meter cube are taken, where D is the inner dia of tank, H is the height of tank, wall thickness, H/D ratio, bottom slab dia, bottom slab thickness, and number of columns are calculated. Table 3 contains load calculation of water tank in kilonewtons. For container, 50 meter cube, 100 meter cube, 250 meter cube, and 500 meter cube. These calculation contain calculation of roof slab, top ring beam, cylindrical wall, weight of water, floor slab, bottom ring beam, column load, and bracing load. Result and analysis. First one, for time period. Time period of impulsive mode and convective mode are analyzed with respect to empty and full condition. First one, full tank condition. In this, the pink one shows time period for convective mode, and the green one is showing time period for impulsive mode. Figure 3 gives H/D ratio versus time period. Second one, for empty tank condition. Figure 4 is showing H/D ratio versus time period, in which the green one is showing time period for impulsive condition. Third one is base shear. Base shear in this base shear for full condition and base shear for empty condition is calculated, and figure 5 shows base shear obtained from resultant of convective and impulsive mode. Fourth one, base moment. In this chart, base moment for full condition and empty condition is given, and figure 6 gives the overturning moment in accordance with empty and full condition of tank. Fifth one, hydrodynamic pressure. Hydrodynamic pressure acting on per unit circumferential length is given in this chart. And sixth one is sloshing height. Sloshing height represent maximum value of height at which fluid can be reached during seismic forces. Freeboard of container depends on this sloshing height. Conclusion. Time period of convective mode is larger compared to impulsive mode, and the tank in full condition has more time period compared to empty condition. Second one, tank in full condition has more base shear compared to tank in empty condition, and as the capacity increases, the difference between them increases. Third one, base moment in full tank condition increases rapidly compared to base moment in empty tank condition, but the increase is linear. Fourth one, the hydrodynamic pressure increases linearly with respect to H/D ratio, but the increase in hydrodynamic pressure is more compared to increase in H/D ratio. Fifth one, sloshing height increases linearly with respect to H/D ratio, and the increase in both sloshing height and H/D are almost equal. These are the references which are used during these projects. Hello.
Nice presentation, Shinde.
Thank you, sir.
Sir, only one presentation is there, sir.
Yes, sir.
Okay. Next, call
Okay,
that.
okay.
Next.
Paper ID
Okay, sir.
144. Please raise your hand. Paper ID number 144. Sir, ready, sir? Number 22, not registered, sir.
Number 22 has not reported.
Not registered, sir. Not registered for presentation. 115 also not
Okay.
registered. 140.
Okay.
146.
Okay, 122, 140, 115, 146 also not.
140 and 146 not available. And
Okay.
188, sir. 188.
Now 180 is also not available.
188 also not registered, sir. Only one paper is left, 144.
Okay, 63 and 228 completed. Yeah, 63 completed. 228.
63 completed, sir. 61 also completed.
Yeah. 144. Please call 144.
144. Someone raising hand. One
No,
minute.
1 minute. Co-chairman wants to say something.
Good. Please go ahead. Share your screen, please.
Shekhar sir.
Yes, sir. Yes, sir.
Co-chair want to say something.
Yes, sir. Yes, sir.
Tell us, sir. Yes.
Yes, sir. Devendra ji, you can speak. No, sir. We can't hearing you, Devendra ji.
Sir, unmute at your level, please. Devendra ji. Unmute at your level. Not audible.
Sir, you are the presenter, sir. You can share your screen also. Sir, are you able to hearing me? Please raise your hand. Yes, sir. Okay. Thank you. But we can't hear you anything from your side, sir. So there is a problem with your mic, I think so. So in the meanwhile, dear all participants, please fill the feedback form. So that will be your attendance. Please don't forget to fill the feedback form.
Sir, what happened to the paper number 144? Whether they are ready to present the paper? Ravindra Kumar. Or do they have any problem to present the paper?
I think he is not here, sir.
So he is not able to present the paper.
Yes,
then anybody else is there to present, sir? After 144?
No, sir. No, sir. Actually, 146 not registered, sir. But sorry, saying something. We are not hearing anything.
154. Paper ID 154,
Yes, sir.
is it over?
Completed, sir. Yes, sir. Over, sir.
It's completed, yeah. So, red color 188, then 146, 140, 115, and 22.
Sir, number 22 and 115, sir, 140, 146, sir. These are not registered, sir, for the conference.
188 also.
188 also.
Yeah.
Hello. Hello.
Devendra sir. Yes, sir. You are
Yes.
audible.
Sir, sir. You are
Oh,
audible.
good. Okay. So I'm number 146.
Sir, 146 not registered actually.
I'm 146.
Okay, sir. Okay.
Right. Oh, so can I?
Yes, sir. Please share your screen.
Okay. So good evening, everybody. So my review paper is on use of friction dampers for seismic performance enhancement in existing and new buildings, and I'm the author along with co-author Professor Vijay Kumar Basare and Dr. Navnath Khadke, and I'm affiliated with the JSPM's Imperial College of Engineering and Research, Bhagoli, Pune. So coming to the abstract, the friction dampers are one of the most efficient ways to enhance the seismic performance of structures subjected to high seismic activity. Friction dampers allow structure to dissipate
Sir,
the
excuse
energy
me, sir.
generated. Sorry,
Excuse
yes,
me, sir. Please share your screen, sir. Please share your screen.
Oh, it's not. Is it there?
Yes,
Can
sir.
you
Yes,
see
sir.
my
Correct.
screen? Okay.
Yes, sir. Please go ahead.
Okay. So yes. So good evening, everybody. I'm Devendra Damle, and from JSPM's Imperial College of Engineering Research, Bhagoli, Pune, and my sorry. Yes, my review paper on use of friction dampers in enhancement of performance for existing and new structures. The abstract, the friction dampers are one of the most efficient ways to enhance the seismic performance of structure subjected to high seismic activity. Friction dampers allow the structure to dissipate the energy generated and transfer it to the building, thereby avoiding the damage to the building. And they are operated under the principle of Coulomb damper, which transform the kinetic energy induced by earthquake into heat through friction. The Paul damper is one of the most common type friction dampers used. They are easy to install and have less maintenance. Another important application of friction damper is the enhancing of performance of existing buildings that need seismic retrofitting. Apart from enhancing the seismic behavior of the building, they also help in reducing the overall cost of the project and contribute to the reducing global warming and carbon footprint, thereby contributing positively to the climate. Now coming to the introduction. Seismic dampers are used in damping the oscillations of the building during an earthquake. The friction damper operates by dissipating kinetic energy through friction. Dampers allow the building to move elastically and dissipate the energy of the earthquake. They are designed to activate prior to member yielding and are reusable after the earthquake has occurred. There are many types of dampers of the building, and damping through friction tends to be the most efficient method of dissipating seismic energy. This in turn produces substantial savings in structural elements and can be optimized for cost savings. Thus, the building is able to withstand an earthquake without sustaining much damage to the structure. The principle of friction dampers. The friction dampers are allow the buildings to elastically deformable in both tension and compression, dissipating the energy of earthquake. Although any two attack and dissipate energy through consistent process, the key element is to avoid considerable variations even after multiple cycles. The friction dampers are velocity, their performance are not affected by variations in velocity of the building. Since only axial displacement and axial force are required to be addressed, thus these can be easily introduced in structure. Friction dampers dissipate the large amount of energy as compared to other alternatives. This is due to the force exerted by damper is constant after doing a cycle. These are the various different types of dampers. We can see comparison. The Paul friction damper gives the highest efficiency. Others are viscous dampers, yield plate, self-centering, and viscoelastic. I'll just come to the modeling part. Friction damper is modeled as a yielding brace. However, in reality, during yielding, damper is slipping. Friction damper can be simply modeled as fictitious bracelet. The damper acts as a normal structural member under service load and only activate once the slip load is reached, at which point the force is maintained remains constant under reversing action also. So there are different type of dampers can be adopted. Type in this in the configuration. I mean, one is the equal number of braces per floor, equal. This is the first part, in which all the braces on all the floors are equally placed, and the forces are different for different floors. The second is the unequal number of braces per floor. This is done where we have got some architectural restraint that we cannot apply all the braces at one particular location. So thereby the forces are distributed and the number of braces are unequally distributed. In cross section of the brace, the cross section area of an axle set force per floor by the number of braces selected at that floor. It is ensured that the lateral system of braces always must. This in turn allows the dampers in floor to absorb the lateral forces first and before the frame reaches either yielding limits or early stages of ductile behavior. In the optimum slip load, this is the force that allowed you maximum energy absorption for a given frame configuration and given a lateral force. This is generally 50% below the ratio. The installation. The system can be adopted in any design. The system can be adopted with materials, that is wood, reinforced concrete. Connection design is simple and have multiple options to choose from. Connections like bolted connections, welded connections. In benefits, the safety can be seriously damaged after an earthquake as they make use of ductility after energy dissipation and therefore undergo permanent deformation at times. Friction dampers prevent the permanent deformation. The building can remain operational during and after the earthquake by preventing structural damage, thus protecting life and property. Savings in construction. Approximately 3 to 7% of the total project cost can be saved using the friction dampers vis-a-vis conventional buildings. In retrofitting projects, the cost saving go even up higher, even as the minimal charges are required to be done as the buildings are already into operations and major alteration is not feasible and not practical in many cases. This is one of the case study we have done in a hospital building, which is an operational hospital building, and there the challenge was that there were some cracks which were developed, and after NDT came and the data available, we found out that there are problem on two aspects. One was a quality issue during the construction of the building, and one was the workmanship and the reinforcement provided versus required. So there was a deficiency there. So we had this structural drawings available luckily, and so although no geodetic report was available, E-time model was developed the E-time model. And these are the dimensions of the building. This height is 35-meter above ground. The year built is 2015, which is prior to 2016. So 1893 2002 was used, and this was dual system with RCC wall and RC beams, and foundation system is raft. So the scope of the work included reviewing of the available non-destructive testing reports. So there was a testing report done already, noting requirement of the reinforcement of the column and shear wall from EDA's model versus the drawing and the available NDT data. Noting the provided reinforcement in the GFC structural drawing and providing BOQ, that's a part of the scope. Site location was it's a hospital building in Delhi, actually, but we cannot name since because of the clause. So available is GFC structural drawings, architectural drawings, NDT report, and the ETA. We had some and the provided steel, and have made a table. I'll show you further. And yeah, so I'll just skip on the yes. So here the flat slab was used with drop panels in the basement floor. In the upper floor, this was conventional beam and slab system, and this had a raft foundation. So this is the ETA model which we had developed. Let me show you 3D. And this was the floor plan actually of the typical floor. So this is seismic zone 4, and response spectrum was adopted. Importance factor of 1.5 being a building. So it has 2 and response reduction is 5. So here, compared reinforcement for various. So this is the reinforcement. I just show you. Yeah. So this is the column location on the grid basis. Grid. This is story numbers. Total required envelope for gravity and envelope both. So this is basically the provided. In green you can send, in the red it is the deficient steel. So I'll skip this. So this we had done for all the floors, and wherever we had the NDT results available. This being an operational hospital, I'll just skip all these results. So for retrofitting we had to for a combination of seismic dampers and conventional jacketing and jacketing system. This given the company. There was one executing company along with the seismic brake company, which is from Canada. I will not name both of the companies right now. So we developed this combination of seismic damper and jacketing in the columns. And since this is a proper operational hospital, we did not have much of a choice to do much in this building. So anyway, so these are the codes which have been followed. These are standard codes: IS 456, 875, 1893, and 139.2. Of course. And I'll just skip this. Yeah. So finally, we had also because we had to take out a BOQ, and so total cost of 3 crores was incurred to strengthen the entire hospital, which is double basement ground plus 7 stories. So and we found out that this is that we had to go for both what do you say friction damper and the conventional system. Only friction damper was not.
Sir, please conclude. Sir, please
yes.
conclude.
So this is my conclusion. Yes, please. Any questions?
Sir, what is your contribution in this?
Yeah. Hello, sir.
What is your contribution exactly?
So we had developed this friction damper because the challenge was to make this operational hospital and to strengthen it. So only seismic, only retrofitting was also not serving the purpose, and neither only friction dampers. So we had to go for a combination.
Okay.
Yes.
Thank you, sir.
Right, sir. Thank you. Should I stop my?
Yes, sir. Sir, please. Sir, ready, sir. We shall wind up the session, sir. He is not available.
144
One
miss.
more. Yes, sir. He is
144
not.
miss.
Yes, sir. 144 is not available here, sir. I think he might be absent.
Okay. So everything is good.
Yes, sir. Good, sir. Commissioner, sir.
Sir, on behalf of KL Demutuba University, we thank Chairman sir and co-chairman sir for effectively conducting the session. We thank you for sparing your valuable time. Thanks a lot, sir. Thank you.
Sir,
Thank
how
you.
to get the feedback, sir?
Sir, I shared the link here, sir, in the chat box. Please fill the chat,
Okay, sir.
feedback form.
Okay. It will take time. Sir will take care.
Okay, sir. Thank you.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir. Srinivasan, sir, and Reddy, sir. Thank you very much.
Thank you very much, sir.
Thank you very much. Thank you very
Okay,
much.
thank you, sir.
Yes, sir.
Any
Sir,
of the sections you can take
yes,
care what has happened exactly in the running this thing. Please take care of
yes, sir.
everything. Announce certain things, whatever you feel like convenient.
Okay, sir. Thank you, sir. Sir, please send me the best paper rubric, sir, to me.
Okay.
Thank you very much.
Okay. I will give you in my WhatsApp. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Yeah. Right, sir.
Thank you, sir, Shivakishore sir and Kameshwar sir for effectively handling the session.
Thank you, sir. Thank you very much, sir. Thank you. Okay, sir.
Thank
Shivakishore,
you,
sir. So thanks a lot, sir, for cooperating me. Thanks, sir.
Thank you very much, sir.
Sir, shall I end the session, sir?
Okay, sir. Okay, sir.
Sure, sir.
Shall I wait or shall I end the session, sir? Kishore garu?
సార్ ఒక్కసారి అనౌన్స్ చేద్దాం సార్ ఫీడ్బ్యాక్ ఫామ్ అందరు ఫిల్ చేశారు లేదో.
Okay, sir. I request the participants to please fill the feedback form if you are not filled. And tomorrow, once again, we'll meet by exactly 9 o'clock for day 2 of this ICIC conference. And we'll meet for session 3. Thank you very much. Thank you all once again. Okay, sir. I'm ending the session, sir. Kishore, sir.
Okay.
Yes, sir. Okay, sir. Thank you, sir.